Section 1 of The Descent of Man, Part 2. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Avai in November 2010. The Descent of Man, Part 2 by Charles Darwin. Chapter 8, Principles of Sexual Selection, Part 1. Secondary sexual characters, sexual selection, manner of action, excess of males, polygamy, the male alone generally modified through sexual selection, eagerness of the male, variability of the male, choice exerted by the female, sexual compared with natural selection, inheritance at corresponding periods of life, at corresponding seasons of the year, and as limited by sex. Relations between the several forms of inheritance. Causes why one sex and the young are not modified through sexual selection. Supplement on the proportional numbers of the two sexes throughout the animal kingdom. The proportion of the sexes in relation to natural selection. With animals which have their sexes separated, the males necessarily differ from the females in their organs of reproduction, and these are the primary sexual characters. But the sexes often differ in what Hunter has called secondary sexual characters, which are not directly connected with the act of reproduction. For instance, the male possesses certain organs of sense or locomotion, of which the female is quite destitute, or has them more highly developed, in order that he may readily find or reach her, or again, the male has special organs of prehension for holding her securely. These latter organs, of infinitely diversified kinds, graduate into those which are commonly ranked as primary, and in some cases can hardly be distinguished from them. We see instances of this in the complex appendages at the apex of the abdomen in male insects. Unless indeed we confine the term primary to the reproductive glands, it is scarcely possible to decide which ought to be called primary and which secondary. The female often differs from the male in having organs for the nourishment or protection of her young, such as the mammary glands of mammals and the abdominal sacs of the marsupials. In some few cases also the male possesses similar organs, which are wanting in the female, such as the receptacles for the ova in certain male fishes, and those temporarily developed in certain male frogs. The females of most bees are provided with a special apparatus for collecting and carrying pollen, and their ovipositor is modified into a sting for the defense of the larvae and the community. Many similar causes could be given, but they do not here concern us. There are, however, other sexual differences quite unconnected with the primary reproductive organs, and it is with these that we are more especially concerned, such as the greater size, strength, and pugnacity of the male, his weapons of offense or means of defense against rivals, his gaudy coloring and various ornaments, his power of song, and other such characters. Besides the primary and secondary sexual differences, such as the foregoing, the males and females of some animals differ in structures related to different habits of life, and not at all, or only indirectly, to the reproductive functions. Thus the females of certain flies, Culicidae and Tabanidae, are blood-suckers, whilst the males, living on flowers, have mouths destitute of mandibles. The males of certain moths and of some crustaceans, for example Tanais, have imperfect, closed mouths and cannot feed. The complemental males of certain cirripedes live like epiphytic plants, either on the female or on the hermaphrodite form, and are destitute of a mouth and of prehensile limbs. In these cases it is the male which has been modified, and has lost certain important organs which the females possess. In other cases it is the female which has lost such parts, For instance, the female glowworm is destitute of wings, as also are many female moths, some of which never leave their cocoons. Many female parasitic crustaceans have lost their natatory legs. In some weevil beetles, Curculionidae, there is a great difference between the male and female in the length of the rostrum or snout, but the meaning of this and of many analogous differences is not at all understood. Differences of structure between the two sexes in relation to different habits of life are generally confined to the lower animals, but with some few birds the beak of the male differs from that of the female. In the huia of New Zealand the difference is wonderfully great, and we hear from Dr. Buller that the male uses his strong beak in chiseling the larvae of insects out of decayed wood, whilst the female probes the softer parts with her far longer, much curved and pliant beak, and thus they mutually aid each other. In most cases, differences of structure between the sexes are more or less directly connected with the propagation of the species. Thus, a female, which has to nourish a multitude of ova, requires more food than the male, and consequently requires special means for procuring it. A male animal, which lives for a very short time, might lose its organs for procuring food through disuse, without detriment, but he would retain his locomotive organs in a perfect state, so that he might reach the female. The female, on the other hand, might safely lose her organs for flying, swimming, or walking, if she gradually acquired habits which rendered such powers useless. We are, however, here concerned only with sexual selection. This depends on the advantage which certain individuals have over others of the same sex and species solely in respect of reproduction. When, as in the cases above mentioned, the two sexes differ in structure in relation to different habits of life, they have no doubt been modified through natural selection, and by inheritance limited to one and the same sex. So again, the primary sexual organs and those for nourishing or protecting the young come under the same influence, for those individuals which generated or nourished their offspring best would leave, ceteris paribus, the greatest number to inherit their superiority, whilst those which generated or nourished their offspring badly would leave but few to inherit their weaker powers. As the male has to find the female, he requires organs of sense and locomotion, but if these organs are necessary for the other purposes of life, as is generally the case, they will have been developed through natural selection. When the male has found the female, he sometimes absolutely requires prehensile organs to hold her. Thus Dr. Wallace informs me that the males of certain moths cannot unite with the females if their tarsi or feet are broken. The males of many oceanic crustaceans, when adult, have their legs and antennae modified in an extraordinary manner for the prehension of the female. Hence we may suspect that it is because these animals are washed about by the waves of the open sea that they require these organs in order to propagate their kind, and if so, their development has been the result of ordinary or natural selection. Some animals extremely low in the scale have been modified for this same purpose. Thus the males of certain parasitic worms, when fully grown, have the lower surface of the terminal part of their bodies roughened like a rasp, and with this they coil round and permanently hold the females. M. Perrier advances this case as one fatal to the belief in sexual election, inasmuch as he supposes that I attribute all the differences between the sexes to sexual selection. This distinguished naturalist, therefore, like so many other Frenchmen, has not taken the trouble to understand even the first principles of sexual selection. An English naturalist insists that the claspers of certain male animals could not have been developed through the choice of the female. Had I not met with this remark, I should not have thought it possible for anyone to have read this chapter and to have imagined that I maintain that the choice of the female had anything to do with the development of the prehensile organs in the male. When the two sexes follow exactly the same habits of life, and the male has the sensory or locomotive organs more highly developed than those of the female, it may be that the perfection of these is indispensable to the male for finding the female, but in the vast majority of cases they serve only to give one male an advantage over another, for, with sufficient time, the less well-endowed males would succeed in pairing with the females, and judging from the structure of the female, they would be in all other respects equally well adapted for their ordinary habits of life. Since in such cases the males have acquired their present structure, not from being better fitted to survive in the struggle for existence, but from having gained an advantage over other males, and from having transmitted this advantage to their male offspring alone, sexual selection must here have come into action. It was the importance of this distinction which led me to designate this form of selection as sexual selection. So, again, if the chief service rendered to the male by his prehensile organs is to prevent the escape of the female before the arrival of other males, or when assaulted by them, these organs will have been perfected through sexual selection, that is, by the advantage acquired by certain individuals over their rivals. But in most cases of this kind it is impossible to distinguish between the effects of natural and sexual selection. Whole chapters could be filled with details on the differences between the sexes in their sensory, locomotive, and prehensile organs. As, however, these structures are not more interesting than others adapted for the ordinary purposes of life, I shall pass them over almost entirely, giving only a few instances under each class. There are many other structures and instincts which must have been developed through sexual selection, such as the weapons of offense and the means of defense of the males for fighting with and driving away their rivals, their courage and pugnacity, their various ornaments, their contrivances for producing vocal or instrumental music, and their glands for emitting odors, most of these latter structures serving only to allure or excite the female. It is clear that these characters are the result of sexual and not of ordinary selection, since unarmed, unornamented, or unattractive males would succeed equally well in the battle for life and in leaving a numerous progeny, but for the presence of better endowed males. We may infer that this would be the case, because the females, which are unarmed and unornamented, are able to survive and procreate their kind. Secondary sexual characters of the kind just referred to will be fully discussed in the following chapters, as being in many respects interesting, but especially as depending on the will, choice, and rivalry of the individuals of either sex. When we behold two males fighting for the possession of the female, or several male birds displaying their gorgeous plumage, and performing strange antics before an assembled body of females, we cannot doubt that, though led by instinct, they know what they are about, and consciously exert their mental and bodily powers. Just as man can improve the breeds of his gamecocks by the selection of those birds which are victorious in the cockpit, so it appears that the strongest and most vigorous males, or those provided with the best weapons, have prevailed under nature, and have led to the improvement of the natural breed or species. A slight degree of variability leading to some advantage, however slight, in reiterated deadly contests, would suffice for the work of sexual selection, and it is certain that secondary sexual characters are eminently variable. Just as man can give beauty, according to his standard of taste, to his male poultry, or more strictly can modify the beauty originally acquired by the parent species, can give to the sea-bright bantam a new and elegant plumage, an erect and peculiar carriage, So it appears that female birds in a state of nature have by a long selection of the more attractive males added to their beauty or other attractive qualities. No doubt this implies powers of discrimination and taste on the part of the female, which will at first appear extremely improbable, but by the facts to be adduced hereafter, I hope to be able to show that the females actually have these powers. When, however, it is said that the lower animals have a sense of beauty, it must not be supposed that such sense is comparable with that of a cultivated man, with his multiform and complex associated ideas. A more just comparison would be between the taste for the beautiful in animals and that in the lowest savages, who admire and deck themselves with any brilliant, glittering, or curious object. From our ignorance on several points, the precise manner in which sexual selection acts is somewhat uncertain. Nevertheless, if those naturalists who already believe in the mutability of species will read the following chapters, they will, I think, agree with me that sexual selection has played an important part in the history of the organic world. It is certain that amongst almost all animals there is a struggle between the males for the possession of the female. This fact is so notorious that it would be superfluous to give instances. Hence, the females have the opportunity of selecting one out of several males, on the supposition that their mental capacity suffices for the exertion of a choice. In many cases, special circumstances tend to make the struggle between the males particularly severe. Thus, the males of our migratory birds generally arrive at their places of breeding before the females, so that many males are ready to contend for each female. I am informed by Mr. Jenner Weir that the bird catchers assert that this is invariably the case with the nightingale and blackcap, and with respect to the latter he can himself confirm the statement. Mr. Swaysland of Brighton has been in the habit during the last 40 years of catching our migratory birds on their first arrival, and he has never known the females of any species to arrive before their males. During one spring he shot 39 males of Ray's wagtail, Budites raii, before he saw a single female. Mr. Gould has ascertained by the dissection of those snipes which arrive the first in this country that the males come before the females. And the like holds good with most of the migratory birds of the United States. The majority of the male salmon in our rivers, on coming up from the sea, are ready to breed before the females. So it appears to be with frogs and toads. Throughout the great class of insects, the males almost always are the first to emerge from the pupal state, so that they generally abound for a time before any females can be seen. Even with those plants in which the sexes are separate, the male flowers are generally mature before the female. As first shown by C.K. Sprengel, many hermaphrodite plants are dichogamous, that is, their male and female organs are not ready at the same time, so that they cannot be self-fertilized. Now, in such flowers, the pollen is in general matured before the stigma, though there are exceptional cases in which the female organs are beforehand. The cause of this difference between the males and females in their periods of arrival and maturity is sufficiently obvious. Those males which annually first migrated into any country, or which in the spring were first ready to breed or were the most eager, would leave the largest number of offspring, and these would tend to inherit similar instincts and constitutions. It must be borne in mind that it would have been impossible to change very materially the time of sexual maturity in the females, without at the same time interfering with the period of the production of the young, a period which must be determined by the seasons of the year. On the whole, there can be no doubt that with almost all animals in which the sexes are separate, there is a constantly recurrent struggle between the males for the possession of the females. Our difficulty in regard to sexual selection lies in understanding how it is that the males which conquer other males, or those which prove the most attractive to the females, leave a greater number of offspring to inherit their superiority than their beaten and less attractive rivals. Unless this result does follow, the characters which give to certain males an advantage over others could not be perfected and augmented through sexual selection. When the sexes exist in exactly equal numbers, the worst endowed males will, except where polygamy prevails, ultimately find females and leave as many offspring as well fitted for their general habits of life as the best endowed males. From various facts and considerations, I formerly inferred that with most animals in which secondary sexual characters are well developed, the males considerably exceeded the females in number, but this is not by any means always true. If the males were to the females as 2 to 1, or as 3 to 2, or even in a somewhat lower ratio, the whole affair would be simple, for the better armed or more attractive males would leave the largest number of offspring. But after investigating as far as possible the numerical proportion of the sexes, I do not believe that any great inequality in number commonly exists. In most cases, sexual selection appears to have been effective in the following manner. Let us take any species, a bird for example, and divide the females inhabiting a district into two equal bodies, the one consisting of the more vigorous and better nourished individuals, and the other of the less vigorous and healthy. The former, there can be little doubt, would be ready to breed in the spring before the others, and this is the opinion of Mr. Jenner Weir, who has carefully attended to the habits of birds during many years. There can also be no doubt that the most vigorous, best nourished, and earliest breeders would on an average succeed in rearing the largest number of fine offspring. Here is excellent evidence on the character of the offspring from an experienced ornithologist. Mr. J. A. Allen, in speaking of the later broods, after the accidental destruction of the first, says that these, quote, are found to be smaller and paler colored than those hatched earlier in the season. In cases where several broods are reared each year, as a general rule, the birds of the earlier broods seem in all respects the most perfect and vigorous. End footnote. The males, as we have seen, are generally ready to breed before the females. The strongest, and with some species the best armed of the males, drive away the weaker, and the former would then unite with the more vigorous and better nourished females, because they are the first to breed. Footnote: Hermann Müller has come to this same conclusion with respect to those female bees which are the first to emerge from the pupa each year. End footnote. Such vigorous pairs would surely rear a larger number of offspring than the retarded females, which would be compelled to unite with the conquered and less powerful males, supposing the sexes to be numerically equal. And this is all that is wanted, to add, in the course of successive generations, to the size, strength, and courage of the males, or to improve their weapons. But in very many cases the males which conquer their rivals do not obtain possession of the females, independently of the choice of the latter. The courtship of animals is by no means so simple and short an affair as might be thought. The females are most excited by, or prefer pairing with, the more ornamented males, or those which are the best songsters, or play the best antics, but it is obviously probable that they would at the same time prefer the more vigorous and lively males, and this has in some cases been confirmed by actual observation. Footnote: With respect to poultry, I have received information, hereafter to be given, to this effect. Even birds, such as pigeons, which pair for life, The female, as I hear from Mr. Jenner Weir, will desert her mate if he is injured or grows weak. End footnote. Thus, the more vigorous females, which are the first to breed, will have the choice of many males, and though they may not always select the strongest or best armed, they will select those which are vigorous and well armed, and in other respects the most attractive. Both sexes, therefore, of such early pairs would, as above explained, have an advantage over others in rearing offspring, and this apparently has sufficed during a long course of generations to add not only to the strength and fighting powers of the males, but likewise to their various ornaments or other attractions. In the converse and much rarer case of the males selecting particular females, it is plain that those which were the most vigorous and had conquered others would have the freest choice, and it is almost certain that they would select vigorous as well as attractive females. Such pairs would have an advantage in rearing offspring, more especially if the male had the power to defend the female during the pairing season, as occurs with some of the higher animals, or aided her in providing for the young. The same principles would apply if each sex preferred and selected certain individuals of the opposite sex, supposing that they selected not only the more attractive, but likewise the more vigorous individuals. Numerical proportion of the two sexes. I have remarked that sexual selection would be a simple affair if the males were considerably more numerous than the females. Hence I was led to investigate, as far as I could, the proportions between the two sexes of as many animals as possible, but the materials are scanty. I will here give only a brief abstract of the results, retaining the details for a supplementary discussion, so as not to interfere with the course of my argument. Domesticated animals alone afford the means of ascertaining the proportional numbers at birth, but no records have been specially kept for this purpose. By indirect means, however, I have collected a considerable body of statistics, from which it appears that with most of our domestic animals the sexes are nearly equal at birth. Thus 25,560 births of race horses have been recorded during 21 years, and the male births were to the female births as 99.7 to 100. In greyhounds the inequality is greater than with any other animal, for out of 6,878 births during 12 years, the male births were to the female as 110.1 to 100. It is, however, in some degree doubtful whether it is safe to infer that the proportion would be the same under natural conditions as under domestication, for slight and unknown differences in the conditions affect the proportion of the sexes. Thus, with mankind, the male births in England are as 104.5, in Russia as 108.9, and with the Jews of Livonia as 120 to 100 female births. But I shall recur to this curious point of the excess of male births in the supplement to this chapter. At the Cape of Good Hope, however, male children of European extraction have been born during several years in the proportion of between 90 and 99 to 100 female children. For our present purpose we are concerned with the proportions of the sexes, not only at birth, but also at maturity, and this adds another element of doubt, for it is a well ascertained fact that with men the number of males dying before or during birth, and during the first years of infancy, is considerably larger than that of females. So it almost certainly is with male lambs, and probably with some other animals. The males of some species kill one another by fighting, or they drive one another about until they become greatly emaciated. They must also be often exposed to various dangers, whilst wandering about in eager search for the females. In many kinds of fish the males are much smaller than the females, and they are believed often to be devoured by the latter, or by other fishes. The females of some birds appear to die earlier than the males. They are also liable to be destroyed on their nests or whilst in charge of their young. With insects, the female larvae are often larger than those of males, and would consequently be more likely to be devoured. In some cases the mature females are less active and less rapid in their movements than the males, and could not escape so well from danger. Hence, with animals in a state of nature, we must rely on mere estimation in order to judge of the proportions of the sexes at maturity, and this is but little trustworthy, except when the inequality is strongly marked. Nevertheless, as far as a judgment can be formed, we may conclude from the facts given in the supplement that the males of some few mammals, of many birds, of some fish and insects, are considerably more numerous than the females. The proportion between the sexes fluctuates slightly during successive years. Thus, with race horses, for every 100 mares born, the stallions varied from 107.1 in one year to 92.6 in another year, and with greyhounds from 116.3 to 95.3. But had larger numbers been tabulated throughout an area more extensive than England, these fluctuations would probably have disappeared, and such as they are, would hardly suffice to lead to effective sexual selection in a state of nature. Nevertheless, in the cases of some few wild animals, as shown in the supplement, the proportions seem to fluctuate either during different seasons or in different localities in a sufficient degree to lead to such selection. For it should be observed that any advantage gained during certain years or in certain localities by those males which were able to conquer their rivals, or were the most attractive to the females, would probably be transmitted to the offspring, and would not subsequently be eliminated. During the succeeding seasons, when, from the equality of the sexes, every male was able to procure a female, the stronger or more attractive males previously produced would still have at least as good a chance of leaving offspring as the weaker or less attractive. End of section 1. Section 2 of The Descent of Man, Part 2. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Avai in November 2010. The Descent of Man, Part 2 by Charles Darwin. Chapter 8. Principles of Sexual Selection, Part 2. Polygamy. The practice of polygamy leads to the same results as would follow from an actual inequality in the number of the sexes, for if each male secures 2 or more females, many males cannot pair, and the latter assuredly will be the weaker or less attractive individuals. Many mammals and some few birds are polygamous, but with animals belonging to the lower classes I have found no evidence of this habit. The intellectual powers of such animals are, perhaps, not sufficient to lead them to collect and guard a harem of females. That some relation exists between polygamy and the development of secondary sexual characters appears nearly certain, and this supports the view that the numerical preponderance of males would be eminently favorable to the action of sexual selection. Nevertheless, many animals which are strictly monogamous, especially birds, display strongly marked secondary sexual characters, whilst some few animals which are polygamous do not have such characters. We will first briefly run through the mammals and then turn to birds. The gorilla seems to be polygamous, and the male differs considerably from the female, So it is with some baboons, which live in herds containing twice as many adult females as males. In South America, the Mycetes caraya presents well-marked sexual differences in color, beard, and vocal organs, and the male generally lives with 2 or 3 wives. The male of the Cebus capucinus differs somewhat from the female and appears to be polygamous. Little is known on this head with respect to most other monkeys, but some species are strictly monogamous. The ruminants are eminently polygamous, and they present sexual differences more frequently than almost any other group of mammals. This holds good especially in their weapons, but also in other characters. Most deer, cattle, and sheep are polygamous, as are most antelopes, though some are monogamous. Sir Andrew Smith, in speaking of the antelopes of South Africa, says that in herds of about a dozen there was rarely more than 1 mature male. The Asiatic antelope saiga appears to be the most inordinate polygamist in the world, for Pallas states that the male drives away all rivals and collects a herd of about 100 females and kids together. The female is hornless and has softer hair, but does not otherwise differ much from the male. The wild horse of the Falkland Islands and of the western states of North America is polygamous, but, except in his greater size and in the proportions of his body, differs but little from the mare. The wild boar presents well-marked sexual characters in his great tusks and some other points. In Europe and in India he leads a solitary life, except during the breeding season, but as is believed by Sir W. Elliot, who has had many opportunities in India of observing this animal, he consorts at this season with several females. Whether this holds good in Europe is doubtful, but it is supported by some evidence. The adult male Indian elephant, like the boar, passes much of his time in solitude, but as Dr. Campbell states, when with others, "it is rare to find more than 1 male with a whole herd of females," the larger males expelling or killing the smaller and weaker ones. The male differs from the female in his immense tusks, greater size, strength, and endurance. So great is the difference in these respects that the males when caught are valued at 1/5 more than the females. The sexes of other pachydermatous animals differ very little or not at all, and as far as known they are not polygamists. Nor have I heard of any species in the orders of Cheiroptera, Edentata, Insectivora, and rodents being polygamous, excepting that amongst the rodents the common rat, according to some rat catchers, lives with several females. Nevertheless, the 2 sexes of some sloths, Edentata, differ in the character and colour of certain patches of hair on their shoulders. And many kinds of bats, Cheiroptera, present well-marked sexual differences, chiefly in the males possessing odoriferous glands and pouches, and by their being of a lighter colour. In the great order of rodents, as far as I can learn, the sexes rarely differ, and when they do so, it is but slightly in the tint of the fur. As I hear from Sir Andrew Smith, the lion in South Africa sometimes lives with a single female, but generally with more, and, in one case, was found with as many as 5 females, so that he is polygamous. As far as I can discover, he is the only polygamist amongst all the terrestrial carnivora, and he alone presents well-marked sexual characters. If, however, we turn to the marine carnivora, as we shall hereafter see, the case is widely different, for many species of seals offer extraordinary sexual differences, and they are eminently polygamous. Thus, according to Perron, the male sea elephant of the Southern Ocean always possesses several females, and the sea lion of Forster is said to be surrounded by from 20 to 30 females. In the north, the male sea bear of Steller is accompanied by even a greater number of females. It is an interesting fact, as Dr. Gill remarks, that in the monogamous species, quote, or those living in small communities, there is little difference in size between the males and females. In the social species, or rather those of which the males have harems, the males are vastly larger than the females. End quote. Amongst birds, many species, the sexes of which differ greatly from each other, are certainly monogamous. In Great Britain we see well-marked sexual differences, for instance in the wild duck, which pairs with a single female, the common blackbird, and the bullfinch, which is said to pair for life. I am informed by Mr. Wallace that the like is true of the chatterers or Cotingidae of South America, and of many other birds. In several groups I have not been able to discover whether the species are polygamous or monogamous. Lesson says that birds of paradise, so remarkable for their sexual differences, are polygamous, but Mr. Wallace doubts whether he had sufficient evidence. Mr. Salvin tells me he has been led to believe that hummingbirds are polygamous. The male widow bird, remarkable for his caudal plumes, certainly seems to be a polygamist. Footnote: on the polygamy of the capercailzie and great bustard, see L. Lloyd, Game Birds of Sweden, 1867, pages 19 and 182. Montagu and Selby speak of the black grouse as polygamous and of the red grouse as monogamous. End footnote. I have been assured by Mr. Jenner Weir and by others that it is somewhat common for 3 starlings to frequent the same nest, but whether this is a case of polygamy or polyandry has not been ascertained. The Gallinaceae exhibit almost as strongly marked sexual differences as birds of paradise or hummingbirds, and many of the species are, as is well known, polygamous, others being strictly monogamous. What a contrast is presented between the sexes of the polygamous peacock or pheasant and the monogamous guinea-fowl or partridge! Many similar cases could be given, as in the grouse tribe, in which the males of the polygamous capercailzie and black cock differ greatly from the females, whilst the sexes of the monogamous red grouse and ptarmigan differ very little. In the cursors, except amongst the bustards, few species offer strongly marked sexual differences, and the great bustard, Otis tarda, is said to be polygamous. With the grallators, extremely few species differ sexually, but the ruff, Machetes pugnax, affords a marked exception, and this species is believed by Montagu to be a polygamist. Hence it appears that amongst birds there often exists a close relation between polygamy and the development of strongly marked sexual differences. I asked Mr. Bartlett of the Zoological Gardens, who has had very large experience with birds, whether the male tragopan, one of the Gallinaceae, was polygamous, and I was struck by his answering, quote, "I do not know, but should think so from his splendid colours." End quote. It deserves notice that the instinct of pairing with a single female is easily lost under domestication. The wild duck is strictly monogamous, the domestic duck highly polygamous. The Rev. W. D. Fox informs me that out of some half-tamed wild ducks on a large pond in his neighbourhood, so many mallards were shot by the gamekeeper that only one was left for every 7 or 8 females, yet unusually large broods were reared. The guinea-fowl is strictly monogamous, but Mr. Fox finds that his birds succeed best when he keeps one cock to 2 or 3 hens. Canary birds pair in a state of nature, but the breeders in England successfully put one male to 4 or 5 females. I have noticed these cases as rendering it probable that wild monogamous species might readily become either temporarily or permanently polygamous. Too little is known of the habits of reptiles and fishes to enable us to speak of their marriage arrangements. The stickleback, Gasterosteus, however, is said to be a polygamist, and the male during the breeding season differs conspicuously from the female. To sum up on the means through which, as far as we can judge, sexual selection has led to the development of secondary sexual characters. It has been shown that the largest number of vigorous offspring will be reared from the pairing of the strongest and best armed males, victorious in contests over other males, with the most vigorous and best nourished females, which are the first to breed in the spring. If such females select the more attractive and at the same time vigorous males, they will rear a larger number of offspring than the retarded females, which must pair with the less vigorous and less attractive males. So it will be if the more vigorous males select the more attractive and at the same time healthy and vigorous females, and this will especially hold good if the male defends the female and aids in providing food for the young. The advantage thus gained by the more vigorous pairs in rearing a larger number of offspring has apparently sufficed to render sexual selection efficient. But a large numerical preponderance of males over females will be still more efficient, whether the preponderance is only occasional and local or permanent, whether it occurs at birth or afterwards from the greater destruction of the females, or whether it indirectly follows from the practice of polygamy. The male generally more modified than the female. Throughout the animal kingdom, when the sexes differ in external appearance, it is, with rare exceptions, the male which has been the more modified, for generally the female retains a closer resemblance to the young of her own species, and to other adult members of the same group. The cause of this seems to lie in the males of almost all animals having stronger passions than the females. Hence it is the males that fight together and sedulously display their charms before the females, and the victors transmit their superiority to their male offspring. Why both sexes do not thus acquire the characters of their fathers will be considered hereafter. That the males of all mammals eagerly pursue the females is notorious to everyone. So it is with birds, but many cock-birds do not so much pursue the hen as display their plumage, perform strange antics, and pour forth their song in her presence. The male in the few fish observed seems much more eager than the female, and the same is true of alligators and apparently of batrachians. Throughout the enormous class of insects, as Kirby remarks, quote, "The law is that the male shall seek the female." End quote. Two good authorities, Mr. Blackwell and Mr. C. Spence Bate, tell me that the males of spiders and crustaceans are more active and more erratic in their habits than the females. When the organs of sense or locomotion are present in the one sex of insects and crustaceans and absent in the other, or when, as is frequently the case, they are more highly developed in the one than in the other, it is, as far as I can discover, almost invariably the male which retains such organs, or has them most developed, and this shows that the male is the more active member in the courtship of the sexes. Footnote: One parasitic hymenopterous insect forms an exception to the rule, as the male has rudimentary wings and never quits the cell in which it is born, whilst the female has well-developed wings. Audouin believes that the females of this species are impregnated by the males which are born in the same cells with them, but it is much more probable that the females visit other cells, so that close interbreeding is thus avoided. We shall hereafter meet in various classes with a few exceptional cases in which the female instead of the male is the seeker and wooer. End footnote. The female, on the other hand, with the rarest exceptions, is less eager than the male. As the illustrious Hunter long ago observed, she generally, quote, requires to be courted, end quote. She is coy and may often be seen endeavoring for a long time to escape from the male. Every observer of the habits of animals will be able to call to mind instances of this kind. It is shown by various facts given hereafter, and by the results fairly attributable to sexual selection, that the female, though comparatively passive, generally exerts some choice and accepts one male in preference to others. Or she may accept, as appearances would sometimes lead us to believe, not the male which is the most attractive to her, but the one which is the least distasteful. The exertion of some choice on the part of the female seems a law almost as general as the eagerness of the male. We are naturally led to inquire why the male in so many and such distinct classes has become more eager than the female, so that he searches for her and plays the more active part in courtship. It would be no advantage and some loss of power if each sex searched for the other, but why should the male almost always be the seeker? The ovules of plants after fertilization have to be nourished for a time, hence the pollen is necessarily brought to the female organs, being placed on the stigma, by means of insects or the wind, or by the spontaneous movements of the stamens, and in the algae, etc., by the locomotive power of the antherozoids. With lowly organized aquatic animals, permanently affixed to the same spot and having their sexes separate, the male element is invariably brought to the female, and of this we can see the reason, for even if the ova were detached before fertilization and did not require subsequent nourishment or protection, there would yet be greater difficulty in transporting them than the male element, because, being larger than the latter, they are produced in far smaller numbers. So that many of the lower animals are, in this respect, analogous with plants. Footnote. Professor Sachs, in speaking of the male and female reproductive cells, remarks, quote, verhält sich die eine bei der Vereinigung aktiv, die andere erscheint bei der Vereinigung passiv. End quote, end footnote. The males of affixed and aquatic animals having been led to emit their fertilizing element in this way, it is natural that any of their descendants which rose in the scale and became locomotive should retain the same habit, and they would approach the female as closely as possible, in order not to risk the loss of the fertilizing element in a long passage of it through the water. With some few of the lower animals, the females alone are fixed, and the males of these must be the seekers. But it is difficult to understand why the males of species, of which the progenitors were primordially free, should invariably have acquired the habit of approaching the females, instead of being approached by them. But in all cases, in order that the males should seek efficiently, it would be necessary that they should be endowed with strong passions, and the acquirement of such passions would naturally follow from the more eager leaving a larger number of offspring than the less eager. The great eagerness of the males has thus indirectly led to their much more frequently developing secondary sexual characters than the females. But the development of such characters would be much aided if the males were more liable to vary than the females, as I concluded they were, after a long study of domesticated animals. Von Nathusius, who has had very wide experience, is strongly of the same opinion. Good evidence also in favor of this conclusion can be produced by a comparison of the two sexes in mankind. During the Novara expedition, a vast number of measurements was made of various parts of the body in different races, and the men were found in almost every case to present a further range of variation than the women, but I shall have to recur to this subject in a future chapter. Footnote: the results were calculated by Dr. Weisbach from measurements made by Drs. K. Scherzer and Schwarz. On the greater variability of the males of domesticated animals, see my Variation of Animals and Plants under Domestication. End footnote. Mr. J. Wood, who has carefully attended to the variation of the muscles in man, puts in italics the conclusion that, quote, "the greatest number of abnormalities in each subject is found in the males." End quote. He had previously remarked that, quote, "altogether in 102 subjects, the varieties of redundancy were found to be half as many again as in females, contrasting widely with the greater frequency of deficiency in females before described." End quote. Professor McAllister likewise remarks that variations in the muscles, quote, "are probably more common in males than in females." End quote. Certain muscles, which are not normally present in mankind, are also more frequently developed in the male than in the female sex, although exceptions to this rule are said to occur. Dr. Bert Wilder has tabulated the cases of 152 individuals with supernumerary digits, of which 86 were males and 39, or less than half, females, the remaining 27 being of unknown sex. It should not, however, be overlooked that women would more frequently endeavor to conceal a deformity of this kind than men. Again, Dr. L. Meyer asserts that the ears of men are more variable in form than those of a woman. Lastly, the temperature is more variable in man than in woman. The cause of the greater general variability in the male sex than in the female is unknown, except in so far as secondary sexual characters are extraordinarily variable and are usually confined to the males, and, as we shall presently see, this fact is, to a certain extent, intelligible. Through the action of sexual and natural selection, male animals have been rendered in very many instances widely different from their females, but independently of selection, the two sexes, from differing constitutionally, tend to vary in a somewhat different manner. The female has to expend much organic matter in the formation of her ova, whereas the male expends much force in fierce contests with his rivals, in wandering about in search of the female, in exerting his voice, pouring out odoriferous secretions, etc., and this expenditure is generally concentrated within a short period. The great vigor of the male during the season of love seems often to intensify his colors, independently of any marked difference from the female. Footnote: Professor Mantegazza is inclined to believe that the bright colors, common in so many male animals, are due to the presence and retention by them of the spermatic fluid, but this can hardly be the case, for many male birds, for instance young pheasants, become brightly colored in the autumn of their first year. End footnote. In mankind, and even as low down in the organic scale as in the Lepidoptera, the temperature of the body is higher in the male than in the female, accompanied in the case of man by a slower pulse. On the whole, the expenditure of matter and force by the two sexes is probably nearly equal, though effected in very different ways and at different rates. From the causes just specified, the two sexes can hardly fail to differ somewhat in constitution, at least during the breeding season, and, although they may be subjected to exactly the same conditions, they will tend to vary in a different manner. If such variations are of no service to either sex, they will not be accumulated and increased by sexual or natural selection. Nevertheless, they may become permanent if the exciting cause acts permanently, and in accordance with a frequent form of inheritance, they may be transmitted to that sex alone in which they first appeared. In this case, the two sexes will come to present permanent, yet unimportant, differences of character. For instance, Mr. Allen shows that with a large number of birds inhabiting the northern and southern United States, the specimens from the south are darker colored than those from the north, and this seems to be the direct result of the difference in temperature, light, etc. between the two regions. Now, in some few cases, the two sexes of the same species appear to have been differently affected. In the Agelaeus phoeniceus, the males have had their colours greatly intensified in the south, whereas with Cardinalis virginianus it is the females which have been thus affected. With Quiscalus major, the females have been rendered extremely variable in tint, whilst the males remain nearly uniform. A few exceptional cases occur in various classes of animals, in which the females instead of the males have acquired well-pronounced secondary sexual characters, such as brighter colours, greater size, strength, or pugnacity. With birds there has sometimes been a complete transposition of the ordinary characters proper to each sex, the females having become the more eager in courtship, the males remaining comparatively passive, but apparently selecting the more attractive females, as we may infer from the results. Certain hen birds have thus been rendered more highly coloured or otherwise ornamented, as well as more powerful and pugnacious than the cocks, these characters being transmitted to the female offspring alone. It may be suggested that in some cases a double process of selection has been carried on, that the males have selected the more attractive females, and the latter the more attractive males. This process, however, though it might lead to the modification of both sexes, would not make the one sex different from the other, unless indeed their tastes for the beautiful differed, but this is a supposition too improbable to be worth considering in the case of any animal, excepting man. There are, however, many animals in which the sexes resemble each other, both being furnished with the same ornaments, which analogy would lead us to attribute to the agency of sexual selection. In such cases it may be suggested with more plausibility that there has been a double or mutual process of sexual selection, the more vigorous and precocious females selecting the more attractive and vigorous males, the latter rejecting all except the more attractive females. But from what we know of the habits of animals, this view is hardly probable, for the male is generally eager to pair with any female. It is more probable that the ornaments common to both sexes were acquired by one sex, generally the male, and then transmitted to the offspring of both sexes. If indeed during a lengthened period the males of any species were greatly to exceed the females in number, and then during another lengthened period, but under different conditions, the reverse were to occur, a double but not simultaneous process of sexual selection might easily be carried on, by which the two sexes might be rendered widely different. We shall hereafter see that many animals exist of which neither sex is brilliantly coloured or provided with special ornaments, and yet the members of both sexes or of one alone have probably acquired simple colours, such as white or black, through sexual selection. The absence of bright tints or other ornaments may be the result of variations of the right kind never having occurred, or of the animals themselves having preferred plain black or white. Obscure tints have often been developed through natural selection for the sake of protection, and the acquirement through sexual selection of conspicuous colors appears to have been sometimes checked from the danger thus incurred. But in other cases the males during long ages may have struggled together for the possession of the females, and yet no effect will have been produced, unless a larger number of offspring were left by the more successful males to inherit the superiority than by the less successful, and this, as previously shown, depends on many complex contingencies. Sexual selection acts in a less rigorous manner than natural selection. The latter produces its effects by the life or death at all ages of the more or less successful individuals. Death, indeed, not rarely ensues from the conflicts of rival males. But generally the less successful male merely fails to obtain a female, or obtains a retarded and less vigorous female later in the season, or, if polygamous, obtains fewer females, so that they leave fewer, less vigorous, or no offspring. In regard to structures acquired through ordinary or natural selection, there is in most cases, as long as the conditions of life remain the same, a limit to the amount of advantageous modification in relation to certain special purposes. But in regard to structures adapted to make one male victorious over another, either in fighting or in charming the female, there is no definite limit to the amount of advantageous modification, so that as long as the proper variations arise, the work of sexual selection will go on. This circumstance may partly account for the frequent and extraordinary amount of variability presented by secondary sexual characters. Nevertheless, natural selection will determine that such characters shall not be acquired by the victorious males if they would be highly injurious, either by expending too much of their vital powers or by exposing them to any great danger. The development, however, of certain structures, of the horns for instance in certain stags, has been carried to a wonderful extreme, and in some cases to an extreme which, as far as the general conditions of life are concerned, must be slightly injurious to the male. From this fact we learn that the advantages which favored males derived from conquering other males in battle or courtship, and thus leaving a numerous progeny, are in the long run greater than those derived from rather more perfect adaptation to their conditions of life. We shall further see, and it could never have been anticipated, that the power to charm the female has sometimes been more important than the power to conquer other males in battle. End of section 2. Section 3 of The Descent of Man, Part 2. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Abai in November 2010. The Descent of Man, Part 2 by Charles Darwin. Chapter 8. Principles of Sexual Selection, Part 3. Laws of Inheritance. In order to understand how sexual selection has acted on many animals of many classes and in the course of ages has produced a conspicuous result, it is necessary to bear in mind the laws of inheritance as far as they are known. Two distinct elements are included under the term inheritance: the transmission and the development of characters, but as these generally go together, the distinction is often overlooked. We see this distinction in those characters which are transmitted through the early years of life, but are developed only at maturity or during old age. We see the same distinction more clearly with secondary sexual characters, for these are transmitted through both sexes, though developed in one alone. That they are present in both sexes is manifest when two species, having strongly marked sexual characters, are crossed, for each transmits the characters proper to its own male and female sex to the hybrid offspring of either sex. The same fact is likewise manifest when characters proper to the male are occasionally developed in the female when she grows old or becomes diseased, as, for instance, when the common hen assumes the flowing tail feathers, hackles, comb, spurs, voice, and even pugnacity of the cock. Conversely, the same thing is evident, more or less plainly, with castrated males. Again, independently of old age or disease, characters are occasionally transferred from the male to the female, as when, in certain breeds of the fowl, spurs regularly appear in the young and healthy females. But in truth they are simply developed in the female, for in every breed each detail in the structure of the spur is transmitted through the female to her male offspring. Many cases will hereafter be given where the female exhibits, more or less perfectly, characters proper to the male, in whom they must have been first developed, and then transferred to the female. The converse case of the first development of characters in the female and of transference to the male is less frequent. It will therefore be well to give one striking instance. With bees, the pollen-collecting apparatus is used by the female alone for gathering pollen for the larvae, yet in most of the species it is partially developed in the males to whom it is quite useless, and it is perfectly developed in the males of Bombus or the humble-bee. As not a single other hymenopterous insect, not even the wasp, which is closely allied to the bee, is provided with a pollen-collecting apparatus, we have no grounds for supposing that male bees primordially collect pollen as well as the female, although we have some reason to suspect that male mammals primordially suckled their young as well as the females. Lastly, in all cases of reversion, characters are transmitted through 2, 3, or many more generations, and are then developed under certain unknown favorable conditions. This important distinction between transmission and development will be best kept in mind by the aid of the hypothesis of pangenesis. According to this hypothesis, every unit or cell of the body throws off gemmules or undeveloped atoms, which are transmitted to the offspring of both sexes, and are multiplied by self-division. They may remain undeveloped during the early years of life or during successive generations, and their development into units or cells, like those from which they were derived, depends on their affinity for and union with other units or cells previously developed in the due order of growth. Inheritance at corresponding periods of life. This tendency is well established. A new character, appearing in a young animal, whether it lasts throughout life or is only transient, will, in general, reappear in the offspring at the same age and last for the same time. If, on the other hand, a new character appears at maturity or even old age, it tends to reappear in the offspring at the same advanced age. When deviations from this rule occur, the transmitted characters much oftener appear before than after the corresponding age. As I have dwelt on this subject sufficiently in another work, I will here merely give 2 or 3 instances for the sake of recalling the subject to the reader's mind. Footnote: the variation of animals and plants under domestication. In the last chapter but one, the provisional hypothesis of pangenesis above alluded to is fully explained. End footnote. In several breeds of the fowl, the down-covered chickens, the young birds in their first true plumage, and the adults differ greatly from one another, as well as from their common parent form, the Gallus bankiva, and these characters are faithfully transmitted by each breed to their offspring at the corresponding periods of life. For instance, the chickens of Spangled Hamburgs, whilst covered with down, have a few dark spots on the head and rump, but are not striped longitudinally as in many other breeds. In their first true plumage they are beautifully penciled, that is, each feather is transversely marked by numerous dark bars, but in their second plumage the feathers all become spangled or tipped with a dark round spot. Footnote: these facts are given on the high authority of a great breeder, Mr. Teabay. See Tegetmeier's Poultry Book, 1868. On the characters of chickens of different breeds, and on the breeds of the pigeon alluded to in the following paragraph, see Variations of Animals. End footnote. Hence, in this breed, variations have occurred at, and been transmitted to, 3 distinct periods of life. The pigeon offers a more remarkable case, because the aboriginal parent species does not undergo any change of plumage with advancing age, excepting that at maturity the breast becomes more iridescent, yet there are breeds which do not acquire their characteristic colours until they have moulted 2, 3, or 4 times, and these modifications of plumage are regularly transmitted. Inheritance at corresponding seasons of the year. With animals in a state of nature, innumerable instances occur of characteristics appearing periodically at different seasons. We see this in the horns of the stag and in the fur of Arctic animals, which becomes thick and white during the winter. Many birds acquire bright colors and other decorations during the breeding season alone. Pallas states that in Siberia domestic cattle and horses become lighter colored during the winter, and I have myself observed and heard of similar strongly marked changes of color, that is, from brownish cream color to reddish brown to a perfect white, in several ponies in England. Although I do not know that this tendency to change the color of the coat during different seasons is transmitted, yet it probably is so, as all shades of color are strongly inherited by the horse. Nor is this form of inheritance, as limited by the seasons, more remarkable than its limitation by age or sex. Inheritance as limited by sex. The equal transmission of characters to both sexes is the commonest form of inheritance, at least with those animals which do not present strongly marked sexual differences, and indeed with many of these. But characters are somewhat commonly transferred exclusive to that sex in which they first appear. Ample evidence on this head has been advanced in my work on Variation under Domestication, but a few instances may here be given. There are breeds of the sheep and goat in which the horns of the male differ greatly in shape from those of the female, and these differences, acquired under domestication, are regularly transmitted to the same sex. As a rule, it is the females alone in cats which are tortoise shell, the corresponding color in the males being rusty red. With most breeds of the fowl, the characters proper to each sex are transmitted to the same sex alone. So general is this form of transmission that it is an anomaly when variations in certain breeds are transmitted equally to both sexes. There are also certain sub-breeds of the fowl in which the males can hardly be distinguished from one another, whilst the females differ considerably in color. The sexes of the pigeon in the parent species do not differ in any external character. Nevertheless, in certain domesticated breeds, the male is colored differently from the female. The wattle in the English carrier pigeon and the crop in the pouter are more highly developed in the male than in the female, and although these characters have been gained through long continued selection by man, the slight differences between the sexes are wholly due to the form of inheritance which has prevailed, for they have arisen, not from, but rather in opposition to the wish of the breeder. Most of our domestic races have been formed by the accumulation of many slight variations, and as some of the successive steps have been transmitted to one sex alone, and some to both sexes, we find in the different breeds of the same species all gradations between great sexual dissimilarity and complete similarity. Instances have already been given with the breeds of the fowl and pigeon, and under nature analogous cases are common. With animals under domestication, but whether in nature I will not venture to say, one sex may lose characters proper to it, and may thus come somewhat to resemble the opposite sex. For instance, the males of some breeds of the fowl have lost their masculine tail plumes and hackles. On the other hand, the differences between the sexes may be increased under domestication, as with the merino sheep, in which the ewes have lost their horns. Again, characters proper to one sex may suddenly appear in the other sex, as in those sub-breeds of the fowl in which the hens acquire spurs whilst young, or, as in certain Polish sub-breeds, in which the females, as there is reason to believe, originally acquired a crest, and subsequently transferred it to the males. All these cases are intelligible on the hypothesis of pangenesis, for they depend on the gemmules of certain parts, although present in both sexes, becoming, through the influence of domestication, either dormant or developed in either sex. There is one difficult question which it will be convenient to defer to a future chapter, namely, whether a character at first developed in both sexes could through selection be limited in its development to one sex alone. If, for instance, a breeder observed that some of his pigeons, of which the characters are usually transferred in an equal degree to both sexes, varied into pale blue, could he, by long-continued selection, make a breed in which the males alone should be of this tint, whilst the females remained unchanged? I will here only say that this, though perhaps not impossible, would be extremely difficult, for the natural result of breeding from the pale blue males would be to change the whole stock of both sexes to this tint. If, however, variations of the desired tint appeared, which were from the first limited in their development to the male sex, there would not be the least difficulty in making a breed with the two sexes of a different colour, as indeed has been effected with a Belgian breed, in which the males alone are streaked with black. In a similar manner, if any variation appeared in a female pigeon which was from the first sexually limited in its development to the females, it would be easy to make a breed with the females alone thus characterized. But if the variation was not thus originally limited, the process would be extremely difficult, perhaps impossible. Footnote. Since the publication of the first edition of this work, it has been highly satisfactory to me to find the following remarks from so experienced a breeder as Mr. Tegetmeier. After describing some curious cases in pigeons of the transmission of colour by one sex alone, and the formation of a sub-breed with this character, he says, quote, "It is a singular circumstance that Mr. Darwin should have suggested the possibility of modifying the sexual colours of birds by a course of artificial selection. When he did so, he was in ignorance of these facts that I have related, but it is remarkable how very closely he suggested the right method of procedure." End quote. End footnote. End of section 3. Section 4 of The Descent of Man, Part 2. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Avai in November 2010. The Descent of Man, Part II, by Charles Darwin. Chapter 8. Principles of Sexual Selection, Part IV. On the relation between the period of development of a character and its transmission to one sex or to both sexes. Why certain characters should be inherited by both sexes and other characters by one sex alone, namely by that sex in which the character first appeared, is in most cases quite unknown. We cannot even conjecture why with certain subbreeds of the pigeon, black striae, though transmitted through the female, should be developed in the male alone, whilst every other character is equally transferred to both sexes. Why, again, with cats, the tortoise-shell colour should, with rare exceptions, be developed in the female alone. The very same character, such as deficient or supernumerary digits, colour blindness, etc., may with mankind be inherited by the males alone of one family, and in another family by the females alone, though in both cases transmitted through the opposite as well as through the same sex. Although we are thus ignorant, the two following rules seem often to hold good, that variations which first appear in either sex at a late period of life tend to be developed in the same sex alone, whilst variations which first appear early in life in either sex tend to be developed in both sexes. I am, however, far from supposing that this is the sole determining cause. As I have not elsewhere discussed this subject, and it has an important bearing on sexual selection, I must here enter into lengthy and somewhat intricate details. It is in itself probable that any character appearing at an early age would tend to be inherited equally by both sexes, for the sexes do not differ much in constitution before the power of reproduction is gained. On the other hand, after this power has been gained and the sexes has come to differ in constitution, the gemmules, if I may again use the language of pangenesis, which are cast off from each varying part in the one sex, would be much more likely to possess the proper affinities for uniting with the tissues of the same sex, and thus becoming developed, than with those of the opposite sex. I was first led to infer that a relation of this kind exists from the fact that whenever and in whatever manner the adult male differs from the adult female, he differs in the same manner from the young of both sexes. The generality of this fact is quite remarkable. It holds good with almost all mammals, birds, amphibians, and fishes, also with many crustaceans, spiders, and some few insects, such as certain Orthoptera and Libellulae. In all these cases the variations, through the accumulation of which the male acquired his proper masculine characters, must have occurred at a somewhat late period of life, otherwise the young males would have been similarly characterized, and, conformable with our rule, the variations are transmitted to and developed in the adult males alone. When, on the other hand, the adult male closely resembles the young of both sexes, these, with rare exceptions, being alike, he generally resembles the adult female, and in most of these cases the variations through which the young and old acquired their present characters probably occurred, according to our rule, during youth. But there is here room for doubt, for characters are sometimes transferred to the offspring at an earlier age than that at which they first appeared in the parents, so that the parents may have varied when adult, and have transferred their characters to their offspring whilst young. There are, moreover, many animals in which the two sexes closely resemble each other, and yet both differ from their young, and here the characters of the adults must have been acquired late in life. Nevertheless, these characters, in apparent contradiction to our rule, are transferred to both sexes. We must not, however, overlook the possibility or even probability of successive variations of the same nature occurring under exposure to similar conditions simultaneously in both sexes at a rather late period of life, and in this case the variations would be transferred to the offspring of both sexes at a corresponding late age, and there would then be no real contradiction to the rule that variations occurring late in life are transferred exclusively to the sex in which they first appeared. This later rule seems to hold true more generally than the second one, namely, that variations which occur in either sex early in life tend to be transferred to both sexes. As it was obviously impossible even to estimate in how large a number of cases throughout the animal kingdom these two propositions held good, it occurred to me to investigate some striking or crucial instances, and to rely on the result. An excellent case for investigation is afforded by the deer family. In all the species but one, the horns are developed only in the males, though certainly transmitted through the females, and capable of abnormal development in them. In the reindeer, on the other hand, the female is provided with horns, so that in this species the horns ought, according to our rule, to appear early in life, long before the two sexes are mature and have come to differ much in constitution. In all the other species the horns ought to appear later in life, which would lead to their development in that sex alone in which they first appear in the progenitor of the whole family. Now, in 7 species belonging to distinct sections of the family and inhabiting different regions, in which the stags alone bear horns, I find that the horns first appear at periods varying from 9 months after birth in the roebuck to 10, 12, or even more months in the stags of the 6 other and larger species. Footnote: I am much obliged to Mr. Cupples for having made inquiries for me in regard to the roebuck and red deer of Scotland from Mr. Robertson, the experienced head forester to the Marquis of Breadalbane. In regard to fallow deer, I have to thank Mr. Ayton and others for information. End footnote. But with the reindeer the case is widely different, for, as I hear from Professor Nielsen, who kindly made special inquiries for me in Lapland, the horns appear in the young animals within 4 or 5 weeks after birth, and at the same time in both sexes. So that here we have a structure developed at a most unusually early age in one species of the family, and likewise common to both sexes in this one species alone. In several kinds of antelopes only the males are provided with horns, whilst in the greater number both sexes bear horns. With respect to the period of development, Mr. Blyth informs me that there was at one time in the Zoological Gardens a young kudu, Antilope strepsiceros, of which the males alone are horned, and also the young of a closely allied species, the eland, Antilope aureus, in which both sexes are horned. Now it is in strict conformity with our rule that in the young male kudu, although 10 months old, the horns were remarkably small, considering the size ultimately attained by them, whilst in the young male eland, although only 3 months old, the horns were already very much larger than in the kudu. It is also a noticeable fact that in the prong-horned antelope only a few of the females, about 1 in 5, have horns, and these are in a rudimentary state, though sometimes above 4 inches long. Footnote: Antilocapra americana. I have to thank Dr. Canfield for information with respect to the horns of the female. End footnote. So that as far as concerns the possession of horns by the males alone, this species is an intermediate condition, and the horns do not appear until about 5 or 6 months after birth. Therefore, in comparison with what little we know of the development of the horns in other antelopes, and from what we do know with respect to the horns of deer, cattle, etc., those of the prong-horned antelope appear at an intermediate period of life, that is, not very early, as in cattle and sheep, nor very late, as in the larger deer and antelopes. The horns of sheep, goats, and cattle, which are well developed in both sexes, though not quite equal in size, can be felt, or even seen, at birth or soon afterwards. Footnote: I have been assured that the horns of the sheep in North Wales can always be felt, and are sometimes even an inch in length at birth. Youatt says that the prominence of the frontal bone in cattle penetrates the cutis at birth, and that the horny matter is soon formed over it. End footnote. Our rule, however, seems to fail in some breeds of sheep, for instance Merinos, in which the rams alone are horned, for I cannot find on inquiry that the horns are developed later in life in this breed than in ordinary sheep in which both sexes are horned. Footnote: I am greatly indebted to Professor Victor Keres for having made inquiries for me from the highest authorities with respect to the Merino sheep of Saxony. On the Guinea coast of Africa there is, however, a breed of sheep in which, as with Merinos, the rams alone bear horns, and Mr. Winwood Reade informs me that in one case observed by him, a young ram, born on February 10th, first showed horns on March 6th, so that in this instance, in conformity with rule, the development of the horns occurred at a later period of life than in Welsh sheep, in which both sexes are horned. End footnote. But with domesticated sheep the presence or absence of horns is not a firmly fixed character, for a certain proportion of the Merino ewes bear small horns, and some of the rams are hornless, and in most breeds hornless ewes are occasionally produced. Dr. W. Marshall has lately made a special study of the protuberances so common on the heads of birds, and he comes to the following conclusion: that with those species in which they are confined to the males, they are developed late in life, whereas with those species in which they are common to the two sexes, they are developed at a very early period. This is certainly a striking confirmation of my two laws of inheritance. In most of the species of the splendid family of the pheasant, the males differ conspicuously from the females, and they acquire their ornaments at a rather late period of life. The eared pheasant, Crossoptilon auritum, however, offers a remarkable exception, for both sexes possess the fine caudal plumes, the large ear tufts, and the crimson velvet about the head. I find that all these characters appear very early in life in accordance with rule. The adult male can, however, be distinguished from the adult female by the presence of spurs, and conformably with our rule these do not begin to be developed before the age of 6 months, as I am assured by Mr. Bartlett, and even at this age the two sexes can hardly be distinguished. Footnote: in the common peacock, Pavo cristatus, the male alone possesses spurs, whilst both sexes of the Java peacock, Pavo muticus, offer the unusual case of being furnished with spurs. Hence I fully expected that in the latter species they would have been developed earlier in life than in the common peacock, but Mr. Hegt of Amsterdam informs me that with young birds of the previous year, of both species, compared on April 23, 1869, there was no difference in the development of the spurs. The spurs, however, were as yet represented merely by slight knobs or elevations. I presume that I should have been informed if any difference in the rate of development had been observed subsequently. End footnote. The male and female peacock differ conspicuously from each other in almost every part of their plumage, except in the elegant head crest which is common to both sexes, and this is developed very early in life, long before the other ornaments, which are confined to the male. The wild duck offers an analogous case, for the beautiful green speculum on the wings is common to both sexes, though duller and somewhat smaller in the female, and it is developed early in life, whilst the curled tail feathers and other ornaments of the male are developed later. Footnote: in some other species of the duck family, the speculum differs in a greater degree in the two sexes, but I have not been able to discover whether its full development occurs later in life in the males of such species than in the male of the common duck, as ought to be the case according to our rule. With the allied Mergus cucullatus we have, however, a case of this kind. The two sexes differ conspicuously in general plumage, and to a considerable degree in the speculum, which is pure white in the male and greyish white in the female. Now, the young males at first entirely resemble the females, and have a greyish-white speculum, which becomes pure white at an earlier age than that at which the adult male acquires his other and more strongly marked sexual differences. See Audubon, Ornithological Biography, Volume 3, 1835, pages 249 to 250. End footnote. Between such extreme cases of close sexual resemblance and wide dissimilarity as those of the Crossoptilon and peacock, many intermediate ones could be given, in which the characters follow our two rules in their order of development. As most insects emerge from the pupal state in a mature condition, it is doubtful whether the period of development can determine the transference of their characters to one or both sexes. But we do not know that the colored scales, for instance, in two species of butterflies, in one of which the sexes differ in color whilst in the other they are alike, are developed at the same relative age in the cocoon. Nor do we know whether all the scales are simultaneously developed on the wings of the same species of butterfly, in which certain colored marks are confined to one sex, whilst others are common to both sexes. A difference of this kind in the period of development is not so improbable as it may at first appear, for with the Orthoptera, which assume their adult state, not by a single metamorphosis, but by a succession of moults, the younger males of some species at first resemble the females, and acquire their distinctive masculine characters only at a later moult. Strictly analogous cases occur at the successive moults of certain male crustaceans. We have as yet considered the transference of characters, relatively to their period of development, only in species in a natural state. We will now turn to domesticated animals, and first touch on monstrosities and diseases. The presence of supernumerary digits and the absence of certain phalanges must be determined at an early embryonic period. The tendency to profuse bleeding is at least congenital, as is probably color blindness. Yet these peculiarities and other similar ones are often limited in their transmission to one sex, so that the rule that characters developed at an early period tend to be transmitted to both sexes here wholly fails. But this rule, as before remarked, does not appear to be nearly so general as the converse one, namely, that characters which appear late in life in one sex are transmitted exclusively to the same sex. From the fact of the above abnormal peculiarities becoming attached to one sex, long before the sexual functions are active, we may infer that there must be some difference between the sex at an extremely early age. With respect to sexually limited diseases, we know too little of the period at which they originate to draw any safe conclusion. Gout, however, seems to fall under our rule, for it is generally caused by intemperance during manhood, and is transmitted from the father to his sons in a much more marked manner than to his daughters. In the various domestic breeds of sheep, goats, and cattle, the males differ from their respective females in the shape or development of their horns, forehead, mane, dewlap, tail, and hump on the shoulders, and these peculiarities, in accordance with our rule, are not fully developed until a rather late period of life. The sexes of dog do not differ, except that in certain breeds, especially in the Scotch Deerhound, the male is much larger and heavier than the female, and, as we shall see in a future chapter, the male goes on increasing in size to an unusually late period of life, which, according to rule, will account for his increased size being transmitted to his male offspring alone. On the other hand, the tortoise-shell colour, which is confined to female cats, is quite distinct at birth, and this case violates the rule. There is a breed of pigeons in which the males alone are streaked with black, and the streaks can be detected even in the nestlings, but they become more conspicuous at each successive moult, so that this case partly opposes and partly supports the rule. With the English carrier and pouter pigeons, the full development of the wattle and the crop occurs rather late in life, and, conformably with the rule, these characters are transmitted in full perfection to the males alone. The following cases perhaps come within the class previously alluded to, in which both sexes have varied in the same manner at a rather late period of life, and have consequently transferred their new characters to both sexes at a corresponding late period, and if so, these cases are not opposed to our rule. There exist sub-breeds of the pigeon, described by Neumeister, in which both sexes change their colour during 2 or 3 moults, as is likewise the case with the almond tumbler. Nevertheless, these changes, though occurring rather late in life, are common to both sexes. One variety of the canary bird, namely the London prize, offers a nearly analogous case. With the breeds of the fowl, the inheritance of various characters by one or both sexes seems generally determined by the period at which such characters are developed. Thus, in all the many breeds in which the adult male differs greatly in colour from the female, as well as from the wild parent species, he differs also from the young male, so that the newly acquired characters must have appeared at a rather late period of life. On the other hand, in most of the breeds in which the two sexes resemble each other, the young are coloured in nearly the same manner as their parents, and this renders it probable that their colours first appeared early in life. We have instances of this fact in all black and white breeds, in which the young and old of both sexes are alike. Nor can it be maintained that there is something peculiar in a black or white plumage, which leads to its transference to both sexes, for the males alone of many natural species are either black or white, the females being differently coloured. With the so-called cuckoo sub-breeds of the fowl, in which the feathers are transversely penciled with dark stripes, both sexes and the chickens are coloured in nearly the same manner. The laced plumage of the zebrite bantam is the same in both sexes, and in the young chickens the wing feathers are distinctly though imperfectly laced. Spangled Hamburgs, however, offer a partial exception, for the two sexes, though not quite alike, resemble each other more closely than do the sexes of the aboriginal parent species, yet they acquire their characteristic plumage late in life, for the chickens are distinctly penciled. With respect to other characters besides colour, in the wild parent species and in most of the domestic breeds, the males alone possess a well-developed comb, but in the young of the Spanish fowl it is largely developed at a very early age, and, in accordance with this early development in the male, it is of unusual size in the adult female. In the game breeds pugnacity is developed at a wonderfully early age, of which curious proofs could be given, and this character is transmitted to both sexes, so that the hens, from their extreme pugnacity, are now generally exhibited in separate pens. With the Polish breeds, the bony protuberance of the skull, which supports the crest, is partially developed even before the chickens are hatched, and the crest itself soon begins to grow, though at first feebly, and in this breed the adults of both sexes are characterized by a great bony protuberance and an immense crest. Finally, from what we have now seen of the relation which exists in many natural species and domesticated races between the period of the development of their characters and the manner of their transmission, for example, the striking fact of the early growth of the horns in the reindeer, in which both sexes bear horns, in comparison with their much later growth in the other species in which the male alone bears horns, we may conclude that one, though not the sole cause of characters being exclusively inherited by one sex, is their development at a late age. And secondly, that one, though apparently a less efficient cause of characters being inherited by both sexes, is their development at an early age, whilst the sexes differ but little in constitution. It appears, however, that some difference must exist between the sexes even during a very early embryonic period, for characters developed at this age not rarely become attached to one sex. Summary and concluding remarks. From the foregoing discussion on the various laws of inheritance, we learn that the characters of the parents often, or even generally, tend to become developed in the offspring of the same sex, at the same age, and periodically at the same season of the year in which they first appeared in the parents. But these rules, owing to unknown causes, are far from being fixed. Hence, during the modification of a species, the successive changes may readily be transmitted in different ways, some to one sex and some to both, some to the offspring at one age and some to the offspring at all ages. Not only are the laws of inheritance extremely complex, but so are the causes which induce and govern variability. The variations thus induced are preserved and accumulated by sexual selection, which is in itself an extremely complex affair, depending, as it does, on the ardor in love, the courage and the rivalry of the males, as well as on the powers of perception, the taste and will of the female. Sexual selection will also be largely dominated by natural selection tending towards the general welfare of the species. Hence, the manner in which the individuals of either or both sexes have been affected through sexual selection cannot fail to be complex in the highest degree. When variations occur late in life in one sex and are transmitted to the same sex at the same age, the other sex and the young are left unmodified. When they occur late in life, but are transmitted to both sexes at the same age, the young alone are left unmodified. Variations, however, may occur at any period of life in one sex or in both, and be transmitted to both sexes at all ages, and then all the individuals of the species are similarly modified. In the following chapters it will be seen that all these cases frequently occur in nature. Sexual selection can never act on any animal before the age for reproduction arrives. From the great eagerness of the male, it has generally acted on this sex and not on the females. The males have thus become provided with weapons for fighting with their rivals, with organs for discovering and securely holding the female, and for exciting or charming her. When the sexes differ in these respects, it is also, as we have seen, an extremely general law that the adult male differs more or less from the young male, and we may conclude from this fact that the successive variations by which the adult male became modified did not generally occur much before the age for reproduction. Whenever some or many of the variations occurred early in life, the young males would partake more or less of the characters of the adult males, and differences of this kind between the old and young males may be observed in many species of animals. It is probable that young male animals have often tended to vary in a manner which would not only have been of no use to them at an early age, but would have been actually injurious, as by acquiring bright colours which would render them conspicuous to their enemies, or by acquiring structures, such as great horns, which would expend much vital force in their development. Variations of this kind occurring in the young males would almost certainly be eliminated through natural selection. With the adult and experienced males, on the other hand, the advantages derived from the acquisition of such characters would more than counterbalance some exposure to danger and some loss of vital force. As variations which give to the male a better chance of conquering other males, or of finding, securing, or charming the opposite sex, would, if they happened to arise in the female, be of no service to her, they would not be preserved in her through sexual selection. We have also good evidence with domesticated animals that variations of all kinds are, if not carefully selected, soon lost through intercrossing and accidental deaths. Consequently, in a state of nature, if variations of the above kind chanced to arise in the female line, and not be transmitted exclusively in this line, they would be extremely liable to be lost. If, however, the females varied and transmitted their newly acquired characters to their offspring of both sexes, the characters which were advantageous to the males would be preserved by them through sexual selection, and the two sexes would in consequence be modified in the same manner, although such characters were of no use to the females. But I shall hereafter have to recur to these more intricate contingencies. Lastly, the females may acquire, and apparently have often acquired by transference, characters from the male sex. As variations occurring later in life and transmitted to one sex alone have incessantly been taken advantage of and accumulated through sexual selection in relation to the reproduction of the species, therefore it appears at first sight an unaccountable fact that similar variations have not frequently been accumulated through natural selection in relation to the ordinary habits of life. If this had occurred, the two sexes would often have been differently modified, for the sake, for instance, of capturing prey or of escaping from danger. Differences of this kind between the two sexes do occasionally occur, especially in the lower classes. But this implies that the two sexes follow different habits in their struggles for existence, which is a rare circumstance with the higher animals. The case, however, is widely different with the reproductive functions, in which respect the sexes necessarily differ. For variations in structure which are related to these functions have often proved of value to one sex, and, from having arisen at a late period of life, have been transmitted to one sex alone; and such variations, thus preserved and transmitted, have given rise to secondary sexual characters. In the following chapters I shall treat of the secondary sexual characters in animals of all classes, and shall endeavour in each case to apply the principles explained in the present chapter. The lowest classes will detain us for a very short time, but the higher animals, especially birds, must be treated at considerable length. It should be borne in mind that for reasons already assigned, I intend to give only a few illustrative instances of the innumerable structures by the aid of which the male finds the female, or, when found, holds her. On the other hand, all structures and instincts by the aid of which the male conquers other males, and by which he allures or excites the female, will be fully discussed, as these are in many ways the most interesting. End of section 4. Section 5 of The Descent of Man, Part 2. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Avai in November 2010. The Descent of Man, Part 2 by Charles Darwin. Chapter 8, Principles of Sexual Selection, Part 5. Supplement on the proportional numbers of the two sexes in animals belonging to various classes. As no one, as far as I can discover, has paid attention to the relative numbers of the two sexes throughout the animal kingdom, I will here give such materials as I have been able to collect, although they are extremely imperfect. They consist in only a few instances of actual enumeration, and the numbers are not very large. As the proportions are known with certainty only in mankind, I will first give them as a standard of comparison. Man. In England during 10 years, from 1857 to 1866, the average number of children born alive yearly was 707,120, in the proportion of 104.5 males to 100 females. But in 1857, the male births throughout England were as 105.2, and in 1865 as 104.0 to 100. Looking to separate districts, in Buckinghamshire, where about 5,000 children are annually born, the mean proportion of male to female births during the whole period of the above 10 years was as 102.8 to 100, whilst in North Wales, where the average annual births are 12,873, it was as high as 106.2 to 100. Taking a still smaller district, that is, Rutlandshire, where the annual births average only 739, in 1864 the male births were as 114.6, and in 1862 as only 97.0 to 100. But even in this small district, the average of the 7,385 births during the whole 10 years was as 104.5 to 100, that is, in the same ratio as throughout England. The proportions are sometimes slightly disturbed by unknown causes. Thus Professor Fay states, quote, that in some districts of Norway there has been during a decennial period a steady deficiency of boys, whilst in others the opposite condition has existed. End quote. In France, during 44 years, the male to female births have been as 106.2 to 100, but during this period it has occurred 5 times in one department and 6 times in another that the female births have exceeded the males. In Russia, the average proportion is as high as 108.9, and in Philadelphia, in the United States, as 110.5 to 100. The average for Europe, deduced by Bix from about 70 million births, is 106 males to 100 females. On the other hand, with white children born at the Cape of Good Hope, the proportion of males is so low as to fluctuate during successive years between 90 and 99 males for every 100 females. It is a singular fact that with Jews the proportion of male births is decidedly larger than with Christians. Thus in Prussia the proportion is as 113, in Breslau as 114, and in Livonia as 120 to 100. The Christian births in these countries being the same as usual, for instance in Livonia as 104 to 100. Professor Fay remarks that, quote, "a still greater preponderance of males would be met with if death struck both sexes in equal proportion in the womb and during birth. But the fact is that for every 100 stillborn females we have in several countries from 134.6 to 144.9 stillborn males. During the first 4 or 5 years of life, also, more male children die than females. For example, in England, during the first year, 126 boys die for every 100 girls, a proportion which in France is still more unfavorable." Footnote: Dr. Stark also remarks that, quote, "these examples may suffice to show that, at almost every stage of life, the males in Scotland have a greater liability to death and a higher death rate than the females. The fact, however, of this peculiarity being most strongly developed at that infantile period of life, when the dress, food, and general treatment of both sexes are alike, seems to prove that the higher male death rate is an impressed, natural, and constitutional peculiarity due to sex alone." End quote. End footnote. Dr. Stockton Hugh accounts for these facts in part by the more frequent defective development of males than of females. We have before seen that the male sex is more variable in structure than the female, and variations in important organs would generally be injurious. But the size of the body, and especially of the head, being greater in male than female infants is another cause, for the males are thus more liable to be injured during parturition. Consequently, the stillborn males are more numerous, and, as a highly competent judge, Dr. Crichton Browne believes, male infants often suffer in health for some years after birth. Owing to this excess in the death rate of male children, both at birth and for some time subsequently, and owing to the exposure of grown men to various dangers, and to their tendency to emigrate, the females in all old settled countries, where statistical records have been kept, are found to preponderate considerably over the males. Footnote: with the savage Guaranis of Paraguay, according to the accurate Azara, the women are to the men in the proportion of 14 to 13. End footnote. It seems at first sight a mysterious fact that in different nations under different conditions and climates, in Naples, Prussia, Westphalia, Holland, France, England, and the United States, the excess of male over female births is less when they are illegitimate than when legitimate. This has been explained by different writers in many different ways, as from the mothers being generally young, from the large proportion of the first pregnancies, etc. But we have seen that male infants, from the large size of their heads, suffer more than female infants during parturition, and as the mothers of illegitimate children must be more liable than other women to undergo bad labors, from various causes, such as attempts at concealment by tight lacing, hard work, distress of mind, etc., their male infants would proportionally suffer. And this probably is the most efficient of all the causes of the proportion of males to females born alive being less amongst illegitimate children than amongst the legitimate. With most animals the greater size of the adult male than of the female is due to the stronger males having conquered the weaker in their struggles for the possession of the females, and no doubt it is owing to this fact that the two sexes of at least some animals differ in size at birth. Thus we have the curious fact that we may attribute the more frequent deaths of male than female infants, especially amongst the illegitimate, at least in part to sexual selection. It has often been supposed that the relative age of the two parents determine the sex of the offspring, and Professor Leuckart has advanced what he considers sufficient evidence, with respect to man and certain domesticated animals, that this is one important, though not the sole factor in the result. So again, the period of impregnation relatively to the state of the female has been thought by some to be the efficient cause, but recent observations discountenance this belief. According to Dr. Stockton Hugh, in Social Science Association of Philadelphia, 1874, the season of the year, the poverty or wealth of the parents, residence in the country or in the city, the crossing of foreign immigrants, etc., all influence the proportion of the sexes. With mankind, polygamy has also been supposed to lead to the birth of a greater proportion of female infants, but Dr. J. Campbell carefully attended to this subject in the harems of Siam, and concludes that the proportion of male to female births is the same as from monogamous unions. Hardly any animal has been rendered so highly polygamous as the English race-horse, and we shall immediately see that his male and female offspring are almost exactly equal in number. I will now give the facts which I have collected with respect to the proportional numbers of the sexes of various animals, and will then briefly discuss how far selection has come into play in determining the result. Horses. Mr. Tegetmeier has been so kind as to tabulate for me from the racing calendar the births of race horses during a period of 21 years, that is, from 1846 to 1867, 1849 being omitted as no returns were that year published. The total births were 25,560, consisting of 12,763 males and 12,797 females, or in the proportion of 99.7 males to 100 females. Footnote. During 11 years a record was kept of the number of mares which proved barren or prematurely slipped their foals, and it deserves notice as showing how infertile those highly nurtured and rather closely interbred animals have become, that not far from 1/3 of the mares failed to produce living foals. Thus, during 1866, 809 male colts and 816 female colts were born, and 743 mares failed to produce offspring. During 1867, 836 males and 902 females were born, and 794 mares failed. End footnote. As these numbers are tolerably large, and as they are drawn from all parts of England during several years, we may with much confidence conclude that with the domestic horse, or at least with the race horse, the two sexes are produced in almost equal numbers. The fluctuations in the proportions during successive years are closely like those which occur with mankind, when a small and thinly populated area is considered. Thus, in 1856 the male horses were as 107.1, and in 1867 as only 92.6 to 100 females. In the tabulated returns the proportions vary in cycles, for the males exceeded the females during 6 successive years, and the females exceeded the males during 2 periods, each of 4 years. This, however, may be accidental. At least I can detect nothing of the kind with men in the decennial table in the Registrar's Report for 1866. Dogs. During a period of 12 years, from 1857 to 1868, the births of a large number of greyhounds throughout England were sent to the Field newspaper, and I am again indebted to Mr. Tegetmeier for carefully tabulating the results. The recorded births were 6,878, consisting of 3,605 males and 3,273 females, that is, in the proportion of 110.1 males to 100 females. The greatest fluctuations occurred in 1864, when the proportion was as 95.3 males, and in 1867 as 116.3 males to 100 females. The above average proportion of 110.1 to 100 is probably nearly correct in the case of the greyhound, but whether it would hold with other domesticated breeds is in some degree doubtful. Mr. Cupples has inquired from several great breeders of dogs, and finds that all without exception believe that females are produced in excess, but he suggests that this belief may have arisen from females being less valued, and from the consequent disappointment producing a stronger impression on the mind. Sheep. The sexes of sheep are not ascertained by agriculturists until several months after birth, at the period when the males are castrated, so that the following returns do not give the proportions at birth. Moreover, I find that several great breeders in Scotland, who annually raise some 1,000 sheep, are firmly convinced that a larger proportion of males than of females die during the first year or two. Therefore, the proportion of males would be somewhat larger at birth than at the age of castration. This is a remarkable coincidence with what, as we have seen, occurs with mankind, and both cases probably depend on the same cause. I have received returns from 4 gentlemen in England who have bred lowland sheep, briefly Leicesters, during the last 10 to 16 years. They amount together to 8,965 births, consisting of 4,407 males and 4,558 females, that is in the proportion of 96.7 males to 100 females. With respect to Cheviot and black-faced sheep bred in Scotland, I have received returns from 6 breeders, 2 of them on a large scale, chiefly for the years 1867 to 1869, but some of the returns extend back to 1862. The total number recorded amounts to 50,685, consisting of 25,071 males and 25,614 females, or in the proportion of 97.9 males to 100 females. If we take the English and Scotch returns together, the total number amounts to 59,650, consisting of 29,478 males and 30,172 females, or as 97.7 to 100. So that with sheep at the age of castration the females are certainly in excess of the males, but probably this would not hold good at birth. Footnote: I am much indebted to Mr. Cupples for having produced for me the above returns from Scotland, as well as some of the following returns on cattle. Mr. R. Elliot, of Leywood, first called my attention to the premature deaths of the males, a statement subsequently confirmed by Mr. Aitchison and others. To this latter gentleman and to Mr. Payan I owe my thanks for large returns as to sheep. End footnote. Of cattle I have received returns from 9 gentlemen of 982 births, too few to be trusted. These consisted of 477 bull calves and 505 cow calves, that is, in the proportion of 94.4 males to 100 females. The Rev. W. D. Fox informs me that in 1867 out of 34 calves born on a farm in Derbyshire, only 1 was a bull. Mr. Harrison Wyre has inquired from several breeders of pigs, and most of them estimate the male to the female births as about 7 to 6. This same gentleman has bred rabbits for many years, and has noticed that a far greater number of bucks are produced than does. But estimations are of little value. Of mammalia in a state of nature I have been able to learn very little. In regard to the common rat, I have received conflicting statements. Mr. R. Elliot of Leywood informs me that a rat catcher assured him that he had always found the males in great excess, even with the young in the nest. In consequence of this, Mr. Elliot himself subsequently examined some 100 old ones, and found the statement true. Mr. F. Buckland has bred a large number of white rats, and he also believes that the males greatly exceed the females. In regard to moles, it is said that "the males are much more numerous than the females," and as the catching of these animals is a special occupation, the statement may perhaps be trusted. Sir A. Smith, in describing an antelope of South Africa, Cobus ellipsiprimnus, remarks that in the herds of this and other species, the males are few in number compared with the females. The natives believe that they are born in this proportion; others believe that the younger males are expelled from the herds; and Sir A. Smith says that though he has himself never seen herds consisting of young males alone, others affirm that this does occur. It appears probable that the young, when expelled from the herd, would often fall a prey to the many beasts of prey in the country. Birds. With respect to the fowl, I have received only one account, namely, that out of 1001 chickens of a highly bred stock of Cochins, reared during 8 years by Mr. Stretch, 487 proved males and 514 females, that is, as 94.7 to 100. In regard to domestic pigeons, there is good evidence either that the males are produced in excess, or that they live longer; for these birds invariably pair, and single males, as Mr. Tegetmeier informs me, can always be purchased cheaper than females. Usually the two birds reared from the 2 eggs laid in the same nest are a male and a female, but Mr. Harrison Weir, who has been so large a breeder, says that he has often bred 2 cocks from the same nest, and seldom 2 hens; moreover, the hen is generally the weaker of the 2, and more liable to perish. With respect to birds in a state of nature, Mr. Gould and others are convinced that the males are generally the more numerous, and as the young males of many species resemble the females, the latter would naturally appear to be the more numerous. Large numbers of pheasants are reared by Mr. Baker of Leadenhall from eggs laid by wild birds, and he informs Mr. Jenner Weir that 4 or 5 males to 1 female are generally produced. An experienced observer remarks that in Scandinavia the broods of the capercailzie and black cock contain more males than females, and that with the dalripa, a kind of ptarmigan, more males than females attend the leks or places of courtship; but this latter circumstance is accounted for by some observers by a greater number of hen birds being killed by vermin. From various facts given by White of Selborne, it seems clear that the males of the partridge must be in considerable excess in the south of England, and I have been assured that this is the case in Scotland. Mr. Weir, on inquiring from the dealers, who receive at certain seasons large numbers of ruff (Machetes pugnax), was told that the males are much the more numerous. The same naturalist has also inquired for me from the bird catchers, who annually catch an astonishing number of various small species alive for the London market, and he was unhesitatingly answered by an old and trustworthy man that with the chaffinch the males are in large excess; he thought as high as 2 males to 1 female, or at least as high as 5 to 3. Mr. Jenner Weir received similar information on making inquiries during the following year. To show the number of living chaffinches caught, I may mention that in 1869 there was a match between two experts, and one man caught in a day 62 and another 40 male chaffinches. The greatest number ever caught by one man in a single day was 70. The males of the blackbird, he likewise maintained, were by far the more numerous, whether caught by traps or by netting at night. These statements may apparently be trusted, because this same man said that the sexes are about equal with the lark, the twite, Linaria montana, and goldfinch. On the other hand, he is certain that with the common linnet the females preponderate greatly, but unequally during different years. During some years he has found the females to the males as 4 to 1. It should, however, be borne in mind that the chief season for catching birds does not begin till September, so that with some species partial migrations may have begun, and the flocks at this period often consist of hens alone. Mr. Salvin paid particular attention to the sexes of the hummingbirds in Central America, and is convinced that with most of the species the males are in excess. Thus one year he procured 204 specimens belonging to 10 species, and these consisted of 166 males and of only 38 females. With 2 other species the females were in excess, but the proportions apparently vary either during different seasons or in different localities. For on one occasion the males of Campylopterus hemileucurus were to the females as 5 to 2, and on another occasion in exactly the reversed ratio. As bearing on this latter point, I may add that Mr. Powys found in Corfu and Epirus the sexes of the chaffinch keeping apart, and "the females by far the most numerous," whilst in Palestine Mr. Tristram found "the male flocks appearing greatly to exceed the female in number." So again with the Quiscalus major, Mr. G. Taylor says that in Florida there were "very few females in proportion to the males," whilst in Honduras the proportion was the other way, the species there having the character of a polygamist. Fish. With fish the proportional numbers of the sexes can be ascertained only by catching them in the adult or nearly adult state, and there are many difficulties in arriving at any just conclusion. Leuckart quotes Bloch that with fish there are twice as many males as females. Infertile females might readily be mistaken for males, as Dr. Gunther has remarked to me in regard to trout. With some species the males are believed to die soon after fertilizing the ova. With many species the males are of much smaller size than the females, so that a large number of males would escape from the same net by which the females were caught. M. Carbonnier, who has especially attended to the natural history of the pike, Esox lucius, states that many males, owing to their small size, are devoured by the larger females, and he believes that the males of almost all fish are exposed from this same cause to greater danger than the females. Nevertheless, in the few cases in which the proportional numbers have been actually observed, the males appear to be largely in excess. Thus Mr. R. Buist, the superintendent of the Stormont Field experiments, says that in 1865, out of 70 salmon first landed for the purpose of obtaining the ova, upwards of 60 were males. In 1867 he again "calls attention to the vast disproportion of the males to the females. We had at the outset at least 10 males to 1 female." Afterwards, females sufficient for obtaining ova were procured. He adds, "From the great proportion of the males, they are constantly fighting and tearing each other on the spawning beds." This disproportion, no doubt, can be accounted for in part but whether wholly is doubtful, by the males ascending the rivers before the females. Mr. F. Buckland remarks in regard to trout that "it is a curious fact that the males preponderate very largely in number over the females. It invariably happens that when the first rush of fish is made to the net, there will be at least 7 or 8 males to 1 female found captive. I cannot quite account for this; either the males are more numerous than the females, or the latter seek safety by concealment rather than flight." He then adds that by carefully searching the banks, sufficient females for obtaining ova can be found. Mr. H. Lee informs me that out of 212 trout taken for this purpose in Lord Portsmouth's park, 150 were males and 62 females. The males of the Cyprinidae likewise seem to be in excess, but several members of this family, viz., the carp, tench, bream, and minnow, appear regularly to follow the practice, rare in the animal kingdom, of polyandry, for the female whilst spawning is always attended by 2 males, 1 on each side, and in the case of the bream by 3 or 4 males. This fact is so well known that it is always recommended to stock a pond with 2 male tenches to 1 female, or at least with 3 males to 2 females. With the minnow, an excellent observer states that on the spawning beds the males are 10 times as numerous as the females. When a female comes amongst the males, "she is immediately pressed closely by a male on each side, and when they have been in that situation for a time, are superseded by other 2 males." End of section 5. Section 6 of The Descent of Man, Part 2. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Avai in November 2010. The Descent of Man, Part 2 by Charles Darwin. Chapter 8. Principles of Sexual Selection, Part 6. Insects. In this great class, the Lepidoptera almost alone afford means for judging of the proportional numbers of the sexes, for they have been collected with special care by many good observers, and have been largely bred from the egg or caterpillar state. I had hoped that some breeders of silk moths might have kept an exact record, but after writing to France and Italy and consulting various treatises, I cannot find that this has ever been done. The general opinion appears to be that the sexes are nearly equal, but in Italy, as I hear from Professor Canestrini, many breeders are convinced that the females are produced in excess. This same naturalist, however, informs me that in the 2 yearly broods of the ailanthus silk moth, Bombyx cynthia, the males greatly preponderate in the first, whilst in the second the 2 sexes are nearly equal, or the females rather in excess. In regard to butterflies in a state of nature, several observers have been much struck by the apparently enormous preponderance of the males. Leuckart quotes Meinecke that the males of butterflies are 3 or 4 times as numerous as the females. Thus Mr. Bates, in The Naturalist on the Amazons, Vol. 2, 1863, pages 228 and 347, in speaking of several species, about 100 in number, which inhabit the upper Amazons, says that the males are much more numerous than the females, even in the proportion of 100 to 1. In North America, Edwards, who had great experience, estimates in the genus Papilio the males to the females as 4 to 1, And Mr. Walsh, who informed me of this statement, says that with Papilio turnus this is certainly the case. In South Africa, Mr. R. Tryman found the males in excess in 19 species. Footnote: 4 of these cases are given by Mr. Tryman in his Rhopalocera africae australis. End footnote. And in one of these, which swarms in open places, he estimated the number of males as 50 to 1 female. With another species, in which the males are numerous in certain localities, he collected only 5 females during 7 years. In the island of Bourbon, M. Maillard states that the males of one species of Papilio are 20 times as numerous as the females. Mr. Tryman informs me that as far as he has himself seen or heard from others, it is rare for the females of any butterfly to exceed the males in number, but 3 South African species perhaps offer an exception. Mr. Wallace states that the females of Ornithoptera croesus in the Malay archipelago are more common and more easily caught than the males, but this is a rare butterfly. I may here add that in Hyperythra, a genus of moths, Guenee says that from 4 to 5 females are sent in collections from India for 1 male. When this subject of the proportional numbers of the sexes of insects was brought before the Entomological Society, it was generally admitted that the males of most Lepidoptera, in the adult or imago state, are caught in greater numbers than the females, but this fact was attributed by various observers to the more retiring habits of the females, and to the males emerging earlier from the cocoon. This latter circumstance is well known to occur with most Lepidoptera, as well as with other insects. So that, as M. Personnat remarks, the males of the domesticated Bombyx yamamai are useless at the beginning of the season, and the females at the end, from the want of mates. I cannot, however, persuade myself that these causes suffice to explain the great excess of males in the above cases of certain butterflies, which are extremely common in their native countries. Mr. Stainton, who has paid very close attention during many years to the smaller moths, informs me that when he collected them in the imago state, he thought that the males were 10 times as numerous as the females, but that since he has reared them on a large scale from the caterpillar state, he is convinced that the females are the more numerous. Several entomologists concur in this view. Mr. Doubleday, however, and some others, take an opposite view, and are convinced that they have reared from the eggs and caterpillars a larger proportion of males than of females. Besides the more active habits of the males, their earlier emergence from the cocoon, and in some cases their frequenting more open stations, other causes may be assigned for an apparent or real difference in the proportional numbers of the sexes of Lepidoptera when captured in the imago state, and when reared from the egg or caterpillar state. I hear from Professor Canestrini that it is believed by many breeders in Italy that the female caterpillar of the silk moth suffers more from the recent disease than the male, and Dr. Staudinger informs me that in rearing Lepidoptera more females die in the cocoon than males. With many species the female caterpillar is larger than the male, and a collector would naturally choose the finest specimens, and thus unintentionally collect a larger number of females. 3 collectors have told me that this was their practice, but Dr. Wallace is sure that most collectors take all the specimens which they can find of the rarer kinds, which alone are worth the trouble of rearing. Birds, when surrounded by caterpillars, would probably devour the largest, and Professor Canestrini informs me that in Italy some breeders believe, though on insufficient evidence, that in the first broods of the Ailanthus silk moth, the wasps destroy a larger number of the female than of the male caterpillars. Dr. Wallace further remarks that female caterpillars, from being larger than the males, require more time for their development and consume more food and moisture, and thus they would be exposed during a longer time to danger from ichneumons, birds, etc., and in times of scarcity would perish in greater numbers. Hence it appears quite possible that in a state of nature fewer female Lepidoptera may reach maturity than males, and for our special object we are concerned with their relative numbers at maturity, when the sexes are ready to propagate their kind. The manner in which the males of certain moths congregate in extraordinary numbers round a single female apparently indicates a great excess of males, though this fact may perhaps be accounted for by the earlier emergence of the males from their cocoons. Mr. Stainton informs me that from 12 to 20 males may often be seen congregated round a female Elachista rufocinerea. It is well known that if a virgin Lasiocampa quercus or Saturnia carpini be exposed in a cage, vast numbers of males collect round her, and if confined in a room will even come down the chimney to her. Mr. Doubleday believes that he has seen from 50 to 100 males of both these species attracted in the course of a single day by a female in confinement. In the Isle of Wight, Mr. Tryman exposed a box in which a female of the Lasiocampa had been confined on the previous day, and 5 males soon endeavoured to gain admittance. In Australia, Mr. Verreau, having placed the female of a small bombyx in a box in his pocket, was followed by a crowd of males, so that about 200 entered the house with him. Mr. Doubleday has called my attention to M. Staudinger's list of Lepidoptera, which gives the prices of the males and females of 300 species or well-marked varieties of butterflies, Rhopalocera. The prices for both sexes of the very common species are of course the same, but in 114 of the rarer species they differ, the males being in all cases, excepting one, the cheaper. On an average of the prices of the 113 species, the price of the male to that of the female is as 100 to 149, and this apparently indicates that inversely the males exceed the females in the same proportion. About 2,000 species or varieties of moths, Heterocera, are catalogued, those with wingless females being here excluded on account of the difference in habits between the two sexes. Of these 2,000 species, 141 differ in price according to sex, the males of 130 being cheaper, and those of only 11 being dearer than the females. The average price of the males of the 130 species to that of the females is as 100 to 143. With respect to the butterflies in this priced list, Mr. Doubleday thinks, and no man in England has had more experience, that there is nothing in the habits of the species which can account for the difference in the prices of the two sexes, and that it can be accounted for only by an excess in the number of the males. But I am bound to add that Dr. Staudinger informs me that he is himself of a different opinion. He thinks that the less active habits of the females and the earlier emergence of the males will account for his collectors securing a larger number of males than of females, and consequently for the lower prices of the former. With respect to specimens reared from the caterpillar state, Dr. Staudinger believes, as previously stated, that a greater number of females than of males die whilst confined to the cocoons. He adds that with certain species one sex seems to preponderate over the other during certain years. Of direct observations on the sexes of Lepidoptera reared either from eggs or caterpillars, I have received only the few following cases. The Rev. J. Hellins of Exeter reared, during 1868, imagos of 73 species, which consisted of 153 males, 137 females. Footnote: this naturalist has been so kind as to send me some results from former years, in which the females seemed to preponderate, but so many of the figures were estimates that I found it impossible to tabulate them. End footnote. Mr. Albert Jones of Eltham reared, during 1868, imagos of 9 species, which consisted of 159 males, 126 females. During 1869 he reared imagos from 4 species, consisting of 114 males, 112 females. Mr. Buckler of Emsworth, Hants, during 1869 reared imagos from 74 species, consisting of 180 males, 169 females. Dr. Wallace of Colster reared from 1 brood of Bombyx cynthia 52 males, 48 females. Dr. Wallace raised, from cocoons of Bombyx pernii sent from China during 1869, 224 males, 123 females. Dr. Wallace raised, during 1868 and 1869, from 2 lots of cocoons of Bombyx yamamai, 52 males, 46 females. Total: 934 males, 761 females. So that in these 8 lots of cocoons and eggs, males were produced in excess. Taken together, the proportion of males is as 122.7 to 100 females. But the numbers are hardly large enough to be trustworthy. On the whole, from these various sources of evidence, all pointing in the same direction, I infer that with most species of Lepidoptera the mature males generally exceed the females in number, whatever the proportions may be at their first emergence from the egg. With reference to the other orders of insects, I have been able to collect very little reliable information. With the stag beetle, Lucanus cervus, the males appear to be much more numerous than the females, but when, as Cornelius remarked during 1867, an unusual number of these beetles appeared in one part of Germany, the females appeared to exceed the males as 6 to 1. With one of the Elateridae, the males are said to be much more numerous than the females, and 2 or 3 are often found united with one female, so that here polyandry seems to prevail. With Ciagonium staphylinidae, in which the males are furnished with horns, the females are far more numerous than the opposite sex. Mr. Jansen stated at the Entomological Society that the females of the bark-feeding Tomicus villosus are so common as to be a plague, whilst the males are so rare as to be hardly known. It is hardly worth while saying anything about the proportion of the sexes in certain species and even groups of insects, for the males are unknown or very rare, and the females are parthenogenetic, that is, fertile without sexual union. Examples of this are afforded by several of the Cynipidae. In all the gall-making Cynipidae known to Mr. Walsh, the females are 4 to 5 times as numerous as the males, and so it is, as he informs me, with the gall-making Cecidomyidae, Diptera. With some common species of sawflies, Tenthredinae, Mr. F. Smith has reared hundreds of specimens from larvae of all sizes, but has never reared a single male. On the other hand, Curtis says that with certain species, Athalia, bred by him, the males were to the females as 6 to 1, whilst exactly the reverse occurred with the mature insects of the same species caught in the fields. In the family of bees, Hermann Müller collected a large number of specimens of many species, and reared others from the cocoons, and counted the sexes. He found that the males of some species greatly exceeded the females in number. In others the reverse occurred, and in others the two sexes were nearly equal. But as in most cases the males emerge from the cocoons before the females, they are at the commencement of the breeding season practically in excess. Müller also observed that the relative number of the two sexes in some species differed much in different localities. But as H. Müller has himself remarked to me, these remarks must be received with some caution, as one sex might more easily escape observation than the other. Thus his brother Fritz Müller has noticed in Brazil that the two sexes of the same species of bee sometimes frequent different kinds of flowers. With respect to the Orthoptera, I know hardly anything about the relative number of the sexes. Korte in Die Strich-, Zug- oder Wanderheuschrecke, 1828, page 20, however, says that out of 500 locusts which he examined, the males were to the females as 5 to 6. With the Neuroptera, Mr. Walsh states that in many, but by no means in all the species of the Odonatus group, there is a great overplus of males. In the genus Heterina also, the males are generally at least 4 times as numerous as the females. In certain species in the genus Gomphus, the males are equally in excess, whilst in 2 other species the females are twice or thrice as numerous as the males. In some European species of Psocus, thousands of females may be collected without a single male, whilst with other species of the same genus both sexes are common. In England, Mr. Maclachlan has captured hundreds of the female Apatenia muliebris, but has never seen the male, and of Boreas hyemaelis only 4 or 5 males have been seen here. With most of these species, excepting the Tenthredinae, there is at present no evidence that the females are subject to parthenogenesis, and thus we see how ignorant we are of the causes of the apparent discrepancy in the proportion of the two sexes. In the other classes of the Articulata I have been able to collect still less information. With spiders, Mr. Blackwell, who has carefully attended to this class during many years, writes to me that the males from their more erratic habits are more commonly seen, and therefore appear more numerous. This is actually the case with a few species, but he mentions several species in 6 genera in which the females appear to be much more numerous than the males. Footnote. Another great authority with respect to this class, Professor Thorel, speaks as if female spiders were generally commoner than the males. End footnote. The small size of the males in comparison with the females, a peculiarity which is sometimes carried to an extreme degree, and their widely different appearance may account in some instances for their rarity in collections. Some of the lower crustaceans are able to propagate their kind sexually, and this will account for the extreme rarity of the males. Thus von Siebold carefully examined no less than 13,000 specimens of Apus from 21 localities, and amongst these he found only 319 males. With some other forms, as Tanais and Cypress, as Fritz Müller informs me, there is reason to believe that the males are much shorter lived than the females, and this would explain their scarcity, supposing the two sexes to be at first equal in number. On the other hand, Müller has invariably taken far more males than females of the Diastylidae and of Cypridina on the shores of Brazil. Thus, with a species in the latter genus, 63 specimens caught the same day included 57 males, but he suggests that this preponderance may be due to some unknown difference in the habits of the two sexes. With one of the higher Brazilian crabs, namely a Gelassimus, Fritz Müller found the males to be more numerous than the females. According to the large experience of Mr. C. Spence Bate, the reverse seems to be the case with 6 common British crabs, the names of which he has given me. The proportion of the sexes in relation to natural selection. There is reason to suspect that in some cases man has by selection indirectly influenced his own sex-producing powers. Certain women tend to produce during their whole lives more children of one sex than of the other, and the same holds good of many animals, for instance cows and horses. Thus Mr. Wright of Yeldersley House informs me that one of his Arab mares, though put 7 times to different horses, produced 7 fillies. Though I have very little evidence on this head, analogy would lead to the belief that the tendency to produce either sex would be inherited, like almost every other peculiarity, for instance that of producing twins, and concerning the above tendency a good authority, Mr. J. Downing, has communicated to me facts which seem to prove that this does occur in certain families of short-horn cattle. Colonel Marshall has recently found on careful examination that the Todas, a hill tribe of India, consist of 112 males and 84 females of all ages, that is, in a ratio of 133.3 males to 100 females. The Todas, who are polyandrous in their marriages, during former times invariably practiced female infanticide, but this practice has now been discontinued for a considerable period. Of the children born within late years, the males are more numerous than the females, in the proportion of 124 to 100. Colonel Marshall accounts for this fact in the following ingenious manner. Quote, "Let us for the purpose of illustration take 3 families as representing an average of the entire tribe. Say that one mother gives birth to 6 daughters and no sons, a second mother has 6 sons only, whilst the third mother has 3 sons and 3 daughters. The first mother, following the tribal custom, destroys 4 daughters and preserves 2. The second retains her 6 sons. The third kills 2 daughters and keeps 1, as also her 3 sons. We have then from the 3 families 9 sons and 3 daughters with which to continue the breed. But whilst the males belong to families in which the tendency to produce sons is great, the females are of those of a converse inclination. Thus the bias strengthens with each generation until, as we find, families grow to have habitually more sons than daughters." That this result would follow from the above form of infanticide seems almost certain. That is, if we assume that a sex-producing tendency is inherited. But as the above numbers are so extremely scanty, I have searched for additional evidence, but cannot decide whether what I have found is trustworthy. Nevertheless, the facts are, perhaps, worth giving. The Maoris of New Zealand have long practiced infanticide, and Mr. Fenton states that he quote, "has met with instances of women who have destroyed 4, 6, and even 7 children, mostly females." However, the universal testimony of those best qualified to judge is conclusive that this custom has for many years been almost extinct. Probably the year 1835 may be named as the period of its ceasing to exist. Now amongst the New Zealanders, as with the Todas, male births are considerably in excess. Mr. Fenton remarks, quote, "One fact is certain, although the exact period of the commencement of this singular condition of the disproportion of the sexes cannot be demonstratively fixed, it is quite clear that this course of decrease was in full operation during the years 1830 to 1844, when the non-adult population of 1844 was being produced, and has continued with great energy up to the present time." The following statements are taken from Mr. Fenton, but as the numbers are not large, and as the census was not accurate, uniform results cannot be expected. It should be borne in mind, in this and the following cases, that the normal state of every population is an excess of women, at least in all civilized countries, chiefly owing to the greater mortality of the male sex during youth, and partly to accidents of all kinds later in life. In 1858, the native population of New Zealand was estimated as consisting of 31,667 males and 24,303 females of all ages, that is, in the ratio of 130.3 males to 100 females. But during this same year and in certain limited districts, the numbers were ascertained with much care, and the males of all ages were here 753 and the females 616, that is, in the ratio of 122.2 males to 100 females. It is more important for us that during this same year of 1858, the non-adult males within the same district were found to be 178, and the non-adult females 142, that is, in the ratio of 125.3 to 100. It may be added that in 1844, at which period female infanticide had only lately ceased, the non-adult males in one district were 281, and the non-adult females only 195, that is, in the ratio of 144.8 males to 100 females. In the Sandwich Islands, the males exceed the females in number. Infanticide was formerly practiced there to a frightful extent, but was by no means confined to female infants, as is shown by Mr. Ellis, and as I have been informed by Bishop Staley and the Reverend Mr. Cohen. Nevertheless, another apparently trustworthy writer, Mr. Jarves, whose observations apply to the whole archipelago, remarks, quote, "Numbers of women are to be found who confess to the murder of from 3 to 6 or 8 children," and he adds, quote, "Females from being considered less useful than males were more often destroyed." End quote. From what is known to occur in other parts of the world, this statement is probable, but must be received with much caution. The practice of infanticide ceased about the year 1819, when idolatry was abolished and missionaries settled in the islands. A careful census in 1839 of the adult and taxable men and women in the island of Kauai, and in one district of Oahu, gives 4,723 males and 3,776 females, that is, in the ratio of 125.08 to 100. At the same time, the number of males under 14 years in Kauai and under 18 in Oahu was 1,797, and of females of the same ages 1,429. And here we have the ratio of 125.75 males to 100 females. In a census of all the islands in 1850, the males of all ages amount to 36,272, and the females to 33,128, or as 109.49 to 100. The males under 17 years amounted to 10,773, and the females under the same age to 9,593, or as 112.3 to 100. From the census of 1872, the proportion of males of all ages, including half-castes, to females is as 125.36 to 100. It must be borne in mind that all these returns for the Sandwich Islands give the proportion of living males to living females, and not of the births, and judging from all civilized countries, the proportion of males would have been considerably higher if the numbers had referred to births. Footnote: Dr. Coulter, in describing the state of California about the year 1830, says that the natives, reclaimed by the Spanish missionaries, have nearly all perished, or are perishing, although well treated, not driven from their native land and kept from the use of spirits. He attributes this in great part to the undoubted fact that the men greatly exceed the women in number, but he does not know whether this is due to a failure of female offspring or to more females dying during early youth. The latter alternative, according to all analogy, is very improbable. He adds that, "infanticide, properly so called, is not common, though very frequent recourse is had to abortion." If Dr. Coulter is correct about infanticide, this case cannot be advanced in support of Colonel Marshall's view. From the rapid decrease of the reclaimed natives, we may suspect that, as in the cases lately given, their fertility has been diminished from changed habits of life. I had hoped to gain some light on this subject from the breeding of dogs, inasmuch as in most breeds, with the exception perhaps of greyhounds, many more female puppies are destroyed than males, just as with the Toda infants. Mr. Cupples assures me that this is unusual with Scotch deerhounds. Unfortunately, I know nothing of the proportion of the sexes in any breed, except in greyhounds, and there the male births are to the females as 110.1 to 100. Now, from inquiries made from many breeders, it seems that the females are in some respects more esteemed, though otherwise troublesome, and it does not appear that the female puppies of the best bred dogs are systematically destroyed more than the males, though this does sometimes take place to a limited extent. Therefore I am unable to decide whether we can, on the above principles, account for the preponderance of male births in greyhounds. On the other hand, we have seen that with horses, cattle, and sheep, which are too valuable for the young of either sex to be destroyed, if there is any difference, the females are slightly in excess. From the several foregoing cases, we have some reason to believe that infanticide practised in the manner above explained tends to make a male-producing race, but I am far from supposing that this practice in the case of man, or some analogous process with other species, has been the sole determining cause of an excess of males. There may be some unknown law leading to this result in decreasing races, which have already become somewhat infertile. Besides the several causes previously alluded to, the greater facility of parturition amongst savages, and the less consequent injury to their male infants, would tend to increase the proportion of live-born males to females. There does not, however, seem to be any necessary connection between savage life and a marked excess of males, that is, if we may judge by the character of the scanty offspring of the lately existing Tasmanians, and of the crossed offspring of the Tahitians now inhabiting Norfolk Island. As the males and females of many animals differ somewhat in habits and are exposed in different degrees to danger, it is probable that in many cases more of one sex than of the other are habitually destroyed. But as far as I can trace out the complication of causes, an indiscriminate though large destruction of either sex would not tend to modify the sex-producing power of the species. With strictly social animals, such as bees or ants, which produce a vast number of sterile and fertile females in comparison with the males, and to whom this preponderance is of paramount importance, we can see that those communities would flourish best which contained females having a strong inherited tendency to produce more and more females, and in such cases an unequal sex-producing tendency would be ultimately gained through natural selection. With animals living in herds or troops in which the males come to the front and defend the herd, as with the bisons of North America and certain baboons, it is conceivable that the male-producing tendency might be gained by natural selection, for the individuals of the better defended herds would leave more numerous descendants. In the case of mankind, the advantage arising from having a preponderance of men in the tribe is supposed to be one chief cause of the practice of female infanticide. In no case, as far as we can see, would an inherited tendency to produce both sexes in equal numbers or to produce one sex in excess be a direct advantage or disadvantage to certain individuals more than to others. For instance, an individual with a tendency to produce more males than females would not succeed better in the battle for life than an individual with an opposite tendency, and therefore a tendency of this kind could not be gained through natural selection. Nevertheless, there are certain animals, for instance fishes and cirripedes, in which 2 or more males appear to be necessary for the fertilization of the female, and the males accordingly largely preponderate, but it is by no means obvious how this male-producing tendency could have been acquired. I formerly thought that when a tendency to produce the 2 sexes in equal numbers was advantageous to the species, it would follow from natural selection, but I now see that the whole problem is so intricate that it is safer to leave its solution for the future. End of section 6.
Section 7 of The Descent of Man, Part 2. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Elsa Youngsted. The Descent of Man, Part 2, by Charles Darwin. Chapter 9. Secondary Sexual Characteristics in the Lower Classes of the Animal Kingdom. With animals belonging to the lower classes, the 2 sexes are not rarely united in the same individual, and therefore secondary sexual characters cannot be developed. In many cases where the sexes are separate, both are permanently attached to some support, and the one cannot search or struggle for the other. Moreover, it is almost certain that these animals have too imperfect senses and much too low mental powers to appreciate each other's beauty or other attractions, or to feel rivalry. Hence in these classes or subkingdoms, such as the Protozoa, Coelenterata, Echinodermata, and Scolacida, secondary sexual characters of the kind which we have to consider do not occur, and this fact agrees with the belief that such characters in the higher classes have been acquired through sexual selection, which depends on the will, desire, and choice of either sex. Nevertheless, some few apparent exceptions occur. Thus, as I hear from Dr. Baird, the males of certain entozoa, or internal parasitic worms, differ slightly in color from the females, but we have no reason to suppose that such differences have been augmented through sexual selection. Contrivances by which the male holds the female, and which are indispensable for the propagation of the species, are independent of sexual selection, and have been acquired through ordinary selection. Many of the lower animals, whether hermaphrodites or with separate sexes, are ornamented with the most brilliant tints, or are shaded and striped in an elegant manner. For instance, many corals and sea anemones, some jellyfish, some planarians, many starfishes, echini, ascidians, etc. But we may conclude from the reasons already indicated, namely the union of the 2 sexes in some of these animals, the permanently affixed condition of others, and the low mental powers of all, that such colors do not serve as a sexual attraction, and have not been acquired through sexual selection. It should be borne in mind that in no case have we sufficient evidence that colors have been thus acquired, except where one sex is much more brilliantly or conspicuously colored than the other, and where there is no difference in habits between the sexes sufficient to account for their different colors. But the evidence is rendered as complete as it can ever be only when the more ornamented individuals, almost always the males, voluntarily display their attractions before the other sex, for we cannot believe that such display is useless, and if it be advantageous, sexual selection will almost inevitably follow. We may, however, extend this conclusion to both sexes, when colored alike, if their colors are plainly analogous to those of one sex alone in certain other species of the same group. How, then, are we to account for the beautiful or even gorgeous colors of many animals in the lowest classes? It appears doubtful whether such colors often serve as a protection, but that we may easily err on this head will be admitted by everyone who reads Mr. Wallace's excellent essay on that subject. It would not, for instance, at first occur to anyone that the transparency of the medusae or jellyfish is of the highest service to them as a protection, But when we are reminded by Haeckel that not only the medusae, but many floating mollusca, crustaceans, and even small oceanic fishes partake of this same glass-like appearance, often accompanied by prismatic colours, we can hardly doubt that they thus escape the notice of pelagic birds and other enemies. M. Giard is also convinced that the bright tints of certain sponges and ascidians serve as a protection. Conspicuous colours are likewise beneficial to many animals as a warning to their would-be devourers that they are distasteful, or that they possess some special means of defence, but this subject will be discussed more conveniently hereafter. We can, in our ignorance of most of the lowest animals, only say that their bright tints result either from the chemical nature of the minute structure of their tissues, independently of any benefit thus derived. Hardly any colour is finer than that of arterial blood, but there is no reason to suppose that the colour of the blood is in itself an advantage, and though it adds to the beauty of the maiden's cheek, no one will pretend that it has been acquired for this purpose. So again with many animals, especially the lower ones, the bile is richly coloured. Thus, as I am informed by Mr. Hancock, the extreme beauty of the naked sea slugs is chiefly due to the biliary glands being seen through the translucent integuments, this beauty being probably of no service to these animals. The tints of the decaying leaves in an American forest are described by everyone as gorgeous, yet no one supposes that these tints are of the least advantage to the trees. Bearing in mind how many substances closely analogous to natural organic compounds have been recently formed by chemists, and which exhibit the most splendid colours, it would have been a strange fact if substances similarly coloured had not often originated, independently of any useful end thus gained, in the complex laboratory of living organisms. The subkingdom of the mollusca. Throughout this great division of the animal kingdom, as far as I can discover, secondary sexual characters, such as we are here considering, never occur, nor could they be expected in the three lowest classes, namely in the ascidians, polyzoa, and brachiopods, constituting the molluscoidea of some authors, for most of these animals are permanently affixed to a support, or have their sexes united in the same individual. In the lamellibranchiata, or bivalve shells, hermaphroditism is not rare. In the next higher class of the gastropoda, or univalve shells, the sexes are either united or separate, but in the latter case the males never possess special organs for finding, securing, or charming the females, or for fighting with other males. As I am informed by Mr. Gwyn Jeffreys, the sole external difference between the sexes consists in the shell sometimes differing a little in form. For instance, the shell of the male periwinkle, Littorina littoria, is narrower and has a more elongated spire than that of the female, but differences of this nature, it may be presumed, are directly connected with the act of reproduction, or with the development of the ova. The gasteropoda, though capable of locomotion, and furnished with imperfect eyes, do not appear to be endowed with sufficient mental powers for the members of the same sex to struggle together in rivalry, and thus to acquire secondary sexual characters. Nevertheless, with the pulmoniferous gasteropods, or land snails, the pairing is preceded by courtship, for these animals, though hermaphrodites, are compelled by their structure to pair together. Agassiz remarks, "Quiconque a eu l'occasion d'observer les amours de limaçons ne saurait mettre en doute la séduction déployée dans le mouvement et les allures qui préparent et accomplissent le double embrassement de ces hermaphrodites." These animals appear also susceptible of some degree of permanent attachment. An accurate observer, Mr. Lonsdale, informs me that he placed a pair of land snails, Helix pomatia, one of which was weakly, into a small and ill-provisioned garden. After a short time the strong and healthy individual disappeared, and was traced by its track of slime over a wall into an adjoining well-stocked garden. Mr. Lonsdale concluded that it had deserted its sickly mate, but after an absence of 24 hours it returned, and apparently communicated the result of its successful exploration, for both then started along the same track and disappeared over the wall. Even in the highest class of the mollusca, the cephalopoda or cuttlefishes, in which the sexes are separate, secondary sexual characters of the present kind do not, as far as I can discover, occur. This is a surprising circumstance, as these animals possess highly developed sense organs and have considerable mental powers, as will be admitted by everyone who has watched their artful endeavours to escape from an enemy. Certain cephalopoda, however, are characterized by one extraordinary sexual character, namely that the male element collects within one of the arms or tentacles, which is then cast off, and clinging by its sucking discs to the female, lives for a time an independent life. So completely does the cast-off arm resemble a separate animal, that it was described by Cuvier as a parasitic worm under the name of hectocotyle. But this marvellous structure may be classed as a primary, rather than as a secondary, sexual character. Although with the mollusca sexual selection does not seem to have come into play, yet many univalve and bivalve shells, such as volutes, cones, scallops, etc., are beautifully coloured and shaped. The colours do not appear, in most cases, to be of any use as protection. They are probably the direct result, as in the lowest classes, of the nature of the tissues, the patterns and the sculpture of the shell depending on its manner of growth. The amount of light seems to be influential to a certain extent, for although, as repeatedly stated by Mr. Gwyn Jeffreys, the shells of some species living at a profound depth are brightly coloured, yet we generally see the lower surfaces, as well as the parts covered by the mantle, less highly coloured than the upper and exposed surfaces. I have given a curious instance of the influence of light on the colours of a frondescent incrustation deposited by the surf on the coast rocks of Ascension and formed by the solution of triturated seashells. In some cases, as with shells living amongst corals and brightly tinted seaweeds, the bright colours may serve as a protection. Dr. Morse has lately discussed this subject in his paper on the adaptive coloration of mollusca. But that many of the nudibranch mollusca, or sea slugs, are as beautifully coloured as any shells, may be seen in Messrs. Alder and Hancock's magnificent work, and from the information kindly given me by Mr. Hancock, it seems extremely doubtful whether these colours usually serve as protection. With some species, this may be the case, as with one kind which lives on the green leaves of algae, and is itself bright green. But many brightly coloured, white, or otherwise conspicuous species do not seek concealment, whilst again some equally conspicuous species, as well as other dull-coloured kinds, live under stones and in dark recesses. So that with these nudibranch mollusks, colour apparently does not stand in any close relation to the nature of the places which they inhabit. These naked sea slugs are hermaphrodites, yet they pair together, as do land snails, many of which have extremely pretty shells. It is conceivable that two hermaphrodites, attracted by each other's greater beauty, might unite and leave offspring which would inherit their parents' greater beauty. But with such lowly organized creatures this is extremely improbable, nor is it at all obvious how the offspring from the more beautiful pairs of hermaphrodites would have any advantage over the offspring of the less beautiful, so as to increase in number, unless indeed vigour and beauty generally coincided. We have not here the case of a number of males becoming mature before the females, with the more beautiful males selected by the more vigorous females. If indeed brilliant colours were beneficial to a hermaphrodite animal in relation to its general habits of life, the more brightly tinted individuals would succeed best, and would increase in number, but this would be a case of natural, and not sexual selection. Subkingdom of the Vermes, class Annelida, or sea worms. In this class, although the sexes, while separate, sometimes differ from each other in characters of such importance that they have been placed under distinct genera, or even families, yet the differences do not seem of the kind which can safely be attributed to sexual selection. These animals are often beautifully coloured, but as the sexes do not differ in this respect, we are but little concerned with them. Even the Nemertians, though so lowly organized, vie in beauty and variety of colouring with any other group in the invertebrate series. Yet Dr. Mackintosh cannot discover that these colours are of any service. The sedentary annelids become duller coloured, according to M. Quatrefages, after the period of reproduction, and this, I presume, may be attributed to the less vigorous conditions at that time. All these worm-like animals apparently stand too low in the scale for the individuals of either sex to exert any choice in selecting a partner, or for the individuals of the same sex to struggle together in rivalry. Subkingdom of the Arthropoda, class Crustacea. In this great class we first meet with undoubted secondary sexual characters, often developed in a remarkable manner. Unfortunately, the habits of crustaceans are very imperfectly known, and we cannot explain the uses of many structures peculiar to one sex. With the lower parasitic species, the males are of small size, and they alone are furnished with perfect swimming legs, antennae, and sense organs, the females being destitute of these organs, with their bodies often consisting of a mere distorted mass. But these extraordinary differences between the two sexes are no doubt related to their widely different habits of life, and consequently do not concern us. In various crustaceans belonging to distinct families, the anterior antennae are furnished with peculiar thread-like bodies, which are believed to act as smelling organs, and these are much more numerous in the males than in the females. As the males, without any unusual development of their olfactory organs, would almost certainly be able to sooner or later find the females, the increased number of the smelling threads has probably been acquired through sexual selection, by the better provided males having been the more successful in finding partners and in producing offspring. Fritz Müller has described a remarkable dimorphic species of Tanais, in which the male is represented by two distinct forms, which never graduate into each other. In the one form the male is furnished with more numerous smelling threads, and in the other form with more powerful and more elongated chelae or pincers, which serve to hold the female. Fritz Müller suggests that these differences between the two male forms of the same species may have originated in certain individuals having varied in the number of the smelling threads, whilst other individuals varied in the shape and size of their chelae, so that of the former those which were best able to find the female, and of the latter those which were best able to hold her, have left the greatest number of progeny to inherit their respective advantages. In some of the lower crustaceans, the right anterior antenna of the male differs greatly in structure from the left, the latter resembling in its simple tapering joints the antennae of the female. In the male the modified antenna is either swollen in the middle, or angularly bent, or converted into an elegant and sometimes wonderfully complex prehensile organ. It serves, as I hear from Sir J. Lubbock, to hold the female, and for this same purpose one of the two posterior legs on the same side of the body is converted into a forceps. In another family the inferior or posterior antennae are curiously zigzagged in the males alone. In the higher crustaceans the anterior legs are developed into chelae or pincers, and these are generally larger in the male than in the female, so much so that the market value of the male edible crab, Cancer pagurus, according to Mr. C. Spence Bate, is 5 times as great as that of the female. In many species the chelae are of unequal size on the opposite side of the body, the right hand one being, as I am informed by Mr. Bate, generally, though not invariably, the largest. This inequality is also often much greater in the male than in the female. The two chelae of the male often differ in structure, the smaller one resembling that of the female. What advantage is gained by their inequality in size on the opposite sides of the body, and by the inequality being much greater in the male than in the female, and why, when they are of equal size, both are often much larger in the male than in the female, is not known. As I hear from Mr. Bate, the chelae are sometimes of such length and size that they cannot possibly be used for carrying food to the mouth. In the males of certain freshwater prawns the right leg is actually longer than the whole body. The great size of the one leg with its chelae may aid the male in fighting with his rivals, but this will not account for the inequality in the female on the opposite sides of the body. In Gelasimus, according to a statement quoted by Milne Edwards, the male and the female live in the same burrow, and this shows that they pair. The male closes the mouth of the burrow with one of its chelae, which is enormously developed, so that here it indirectly serves as a means of defense. Their main use, however, is probably to seize and to secure the female, and this in some instances, as with Gammarus, is known to be the case. The male of the hermit or soldier crab, Pagurus, for weeks together carries about the shell inhabited by the female. The sexes, however, of the common shore crab, Carcinus minus, as Mr. Bate informs me, unite directly after the female has molted her hard shell, when she is so soft that she would be injured if seized by the strong pincers of the male, but as she is caught and carried about by the male before molting, she could then be seized with impunity. Fritz Müller states that certain species of Melita are distinguished from all other amphipods by the females having the coxal lamellae of the penultimate pair of feet produced into hook-like processes, of which the males lay hold with the hands of the first pair. The development of these hook-like processes has probably followed from those females which were the most securely held during the act of reproduction, having left the largest number of offspring. Another Brazilian amphipod represents a case of dimorphism like that of Tanais, for there are two male forms, which differ in the structure of their chelae. As either chela would certainly suffice to hold the female, for both are now used for this purpose, the two male forms probably originated by some having varied in one manner and some in another, both forms having derived certain special, but nearly equal, advantages from their differently shaped organs. It is not known that male crustaceans fight together for the possession of the females, but it is probably the case. For with most animals, when the male is larger than the female, he seems to owe his greater size to his ancestors having fought with other males during many generations. In most of the orders, especially in the highest or the Brachyura, the male is larger than the female. The parasitic genera, however, in which the sexes follow different habits of life, and most of the Entomostraca must be excepted. The chelae of many crustaceans are weapons well adapted for fighting. Thus, when a devil crab, Portunus puber, was seen by a son of Mr. Bate fighting with a Carcinus menis, the latter was soon thrown on its back, and had every limb torn from its body. When several males of a Brazilian gelasimus, a species furnished with immense pincers, were placed together in a glass vessel by Fritz Müller, they mutilated and killed one another. Mr. Bate put a large male Carcinus menis into a pan of water, inhabited by a female which was paired with a smaller male, but the latter was soon dispossessed. Mr. Bate adds, "If they fought, the victory was a bloodless one, for I saw no wounds." This same naturalist separated a male sandskipper, so common on our seashores, Gammarus marinus, from its female, both of whom were imprisoned in the same vessel, with many individuals of the same species. The female, when thus divorced, soon joined the others. After a time the male was put again into the same vessel, and he then, after swimming about for a time, dashed into the crowd, and without any fighting, at once took away his wife. This fact shows that in the Amphipoda, an order low in the scale, the males and females recognize each other and are mutually attached. The mental powers of the Crustacea are probably higher than at first sight appears probable. Anyone who tries to catch one of the shore crabs, so common on tropical coasts, will perceive how wary and alert they are. There is a large crab, Birgus latra, found on coral islands, which makes a thick bed of the picked fibers of the cocoanut at the bottom of a deep burrow. It feeds on the fallen fruit of this tree by tearing off the husk fiber by fiber, and it always begins at that end where the three eye-like depressions are situated. It then breaks through one of these eyes by hammering with its heavy front pincers, and turning round extracts the albuminous core with its narrow posterior pincers. But these actions are probably instinctive, so that they would be performed as well by a young animal as by an old one. The following case, however, can hardly be so considered. A trustworthy naturalist, Mr. Gardner, whilst watching a shore crab, gelasimus, making its burrow, threw some shells toward the hole. One rolled in, and the other shells remained within a few inches of the mouth. In about 5 minutes the crab brought out the shell which had fallen in, and carried it away to a distance of a foot. It then saw the 3 other shells lying near, and, evidently thinking that they might likewise roll in, carried them to the spot where it had laid the first. It would, I think, be difficult to distinguish this act from one performed by a man by the aid of reason. Mr. Bate does not know of any well-marked case of differences of colour in the 2 sexes of our British crustaceans, in which respect the sexes of the higher animals so often differ. In some cases, however, the males and females differ slightly in tint, but Mr. Bate thinks not more than may be accounted for by their different habits of life, such as by the male wandering more about and being thus more exposed to the light. Dr. Power tried to distinguish by colour the sexes of several species which inhabit Mauritius, but failed, except with one species of Squilla, probably S. stylifera, the male of which is described as being of a beautiful bluish green, with some of the appendages cherry red, whilst the female is clouded with brown and grey, with the red about her much less vivid than in the male. In this case we may suspect the agency of sexual selection. From M. Bert's observations on Daphnia, when placed in a vessel illuminated by a prism, we have reason to believe that even the lowest crustaceans can distinguish colours. With Sapphirina, an oceanic genus of Entomostraca, the males are furnished with the minute shields or cell-like bodies, which exhibit beautiful changing colours. These are absent in the females, and in both sexes of one species. It would, however, be extremely rash to conclude that these curious organs serve to attract the females. I am informed by Fritz Müller that in the female of a Brazilian species of gelasimus the whole body is of a nearly uniform greyish-brown. In the male the posterior part of the cephalothorax is a pure white, with the anterior part of a rich green shading into dark brown, and it is remarkable that these colours are liable to change in the course of a few minutes, the white becoming dirty grey or even black, the green losing much of its brilliancy. It deserves special notice that the males do not acquire their bright colours until they become mature. They appear to be much more numerous than the females. They differ also in the larger size of their chelae. In some species of the genus, probably in all, The sexes pair and inhabit the same burrow. They are also, as we have seen, highly intelligent animals. From these various considerations, it seems probable that the male in this species has become gaily ornamented in order to attract or excite the female. It has just been stated that the male Gelasimus does not acquire his conspicuous colours until mature and nearly ready to breed. This seems a general rule in the whole class in respect to the many remarkable structural differences between the sexes. We shall hereafter find the same law prevailing throughout the great subkingdom of the vertebrata, and in all cases it is eminently distinctive of characters which have been acquired through sexual selection. Fritz Müller gives some striking instances of this law. Thus the male sandhopper, or Kestia, does not, until nearly full grown, acquire his large claspers, which are very differently constructed from those of the female. Whilst young, his claspers resemble those of the female. Class Arachnida, spiders. The sexes do not generally differ much in colour, but the males are often darker than the females, as may be seen in Mr. Blackwell's magnificent work. In some species, however, the difference is conspicuous. Thus the female of Sparasus smaragdulus is dullish green, whilst the adult male has the abdomen of a fine yellow, with 3 longitudinal stripes of rich red. In certain species of Tomesis, the sexes closely resemble each other, in others they differ much, and analogous cases occur in many other genera. It is often difficult to say which of the two sexes departs most from the ordinary coloration of the genus to which the species belong. But Mr. Blackwell thinks that, as a general rule, it is the male, and Canestrini remarks that in certain genera the males can be specifically distinguished with ease, but the females with great difficulty. I am informed by Mr. Blackwell that the sexes, whilst young, usually resemble each other, and both often undergo great changes in colour during their successive moults, before arriving at maturity. In other cases the male alone appears to change colour. Thus the male of the above bright-coloured Sparasus first resembles the female, and acquires his peculiar tints only when nearly adult. Spiders are possessed of acute senses, and exhibit much intelligence. As is well known, the females often show the strongest affection for their eggs, which they carry about enveloped in a silken web. The males search eagerly for the females, and have been seen by Canestrini and others to fight for possession of them. This same author says that the union of the two sexes has been observed in about 20 species, and he asserts positively that the female rejects some of the males who court her, threatens them with open mandibles, and at last, after long hesitation, accepts the chosen one. From these several considerations we may admit with some confidence that the well-marked differences in colour between the sexes of certain species are the results of sexual selection, though we have not here the best kind of evidence, the display by the male of his ornaments. From the extreme variability of colour in the males of some species, for instance of Theridion lineatum, it would appear that these sexual characters of the males have not as yet become well fixed. Canestrini draws the same conclusion from the fact that the males of certain species present 2 forms, differing from each other in the size and length of their jaws, and this reminds us of the above cases of dimorphic crustaceans. The male is generally much smaller than the female, sometimes to an extraordinary degree. Vinson gives a good instance of the small size of the male in Apera nigra. In this species, as I may add, the male is testaceous and the female black with legs banded with red. Other even more striking cases of inequality in size between the sexes have been recorded, but I have not seen the original accounts. And he is forced to be extremely cautious in making his advances, as the female often carries her coyness to a dangerous pitch. De Geer saw a male that, in the midst of his preparatory caresses, was seized by the object of his attentions, enveloped by her in a web, and then devoured, a sight which, as he adds, filled him with horror and indignation. The Rev. O.P. Cambridge accounts in the following manner for the extreme smallness of the male in the genus Nephila. Vinson gives a graphic account of the agile way in which the diminutive male escapes from the ferocity of the female, by gliding about and playing hide-and-seek over her body and along her gigantic limbs. In such a pursuit it is evident that the chances of escape would be in favour of the smallest males, while the larger ones would fall early victims. Thus gradually a diminutive race of males would be selected, until at last they would dwindle to the smallest possible size comparative with the existence of their generative functions. In fact, probably to the size we now see them, that is, so small as to be a sort of parasite upon the female, and either beneath her notice or too agile and too small for her to catch without great difficulty. Westring has made the interesting discovery that the males of several species of Theridion have the power of making a stridulating sound, whilst the females are mute. The apparatus consists of a serrated ridge at the base of the abdomen, against which the hard hinder part of the thorax is rubbed, and of this structure not a trace can be detected in the females. It deserves notice that several writers, including the well-known arachnologist Vulcanaire, have declared that spiders are attracted by music. From the analogy of the Orthoptera and the Homoptera, to be described in the next chapter, we may feel almost sure that the stridulation serves, as Westring also believes, to call or to excite the female, and this is the first case known to me in the ascending scale of the animal kingdom of sounds emitted for this purpose. Hilgendorf, however, has lately called attention to an analogous structure in some of the higher crustaceans, which seems adapted to produce sound. Class Myriapoda. In neither of the two orders in this class, the millipedes and the centipedes, can I find any well-marked instances of such sexual differences as more particularly concern us. In Glomeris limbata, however, and perhaps in some few other species, the males differ slightly in colour from the females, but this Glomeris is a highly variable species. In the males of the Diplopoda, the legs belonging either to one of the anterior or of the posterior segments of the body are modified into prehensile hooks which serve to secure the female. In some species of Eulis, the tarsi of the male are furnished with membranous suckers for the same purpose. As we shall see when we treat of the insects, it is a much more unusual circumstance that it is the female in Lithobius, which is furnished with prehensile appendages at the extremity of her body for holding the male. End of section 7. Section 8 of The Descent of Man, Part 2. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Elsa Youngstead. The Descent of Man, Part 2, by Charles Darwin. Chapter 10. Secondary Sexual Characters of Insects, Part 1. In the immense class of insects, the sexes sometimes differ in their locomotive organs, and often in their sense organs, as in the pectinated and beautifully plumose antennae of the males of many species. In the Chloeon, one of the Ephemerae, the male has great pillared eyes, of which the female is entirely destitute. The ocelli are absent in the females of certain insects, as in the Mutilidae, and here the females are likewise wingless. But we are chiefly concerned with the structures by which one male is enabled to conquer another, either in a battle or courtship, through his strength, pugnacity, ornaments, or music. The innumerable contrivances, therefore, by which the male is able to seize the female may be briefly passed over. Besides the complex structures of the apex of the abdomen, which ought perhaps to be ranked as primary organs, these organs in the male often differ in closely allied species, and afford excellent specific characters. But their importance from a functional point of view, as Mr. R. McLaughlin has remarked to me, has probably been overrated. It has been suggested that slight differences in these organs would suffice to prevent the intercrossing of well-marked varieties or incipient species, and would thus aid in their development. That this can hardly be the case we may infer from the many recorded cases of distinct species having been observed in union. Mr. McLaughlin informs me that when several species of Phryganidae, which present strongly pronounced differences of this kind, were confined together by Dr. August Meyer, they coupled, and one pair produced fertile ova. It is astonishing, as Mr. B. D. Walsh has remarked, how many different organs are worked in by nature for the seemingly insignificant object of enabling the male to grasp the female firmly. The mandibles or jaws are sometimes used for this purpose. Thus the male Corydalus cornutus, a neuropterous insect in some degree allied to the dragonflies, etc., has immense curved jaws, many times longer than those of the female, and they are smooth instead of being toothed, so that he is thus enabled to seize her without injury. One of the stag beetles of North America, Lucanus elaphus, uses his jaws, which are much larger than those of the females, for the same purpose, but probably likewise for fighting. In one of the sand wasps, Ammophila, the jaws in the two sexes are closely alike, but they are used for widely different purposes. The males, as Professor Westwood observes, are exceedingly ardent, seizing their partners around the neck with their sickle-shaped jaws. Mr. Walsh, who called my attention to the double use of the jaws, says that he has repeatedly observed this fact, whilst the females use these organs for burrowing in sandbanks and making their nests. The tarsi of the front legs are dilated in many male beetles, or are furnished with broad cushions of hairs, and in many genera of water beetles they are armed with a round flat sucker, so that the male may adhere to the slippery body of the female. It is a much more unusual circumstance that the females of some water beetles, Dytiscus, have their elytra deeply grooved, and in Acilius sulcatus thickly set with hairs, as an aid to the male. The females of some other water beetles, Hydroporus, have their elytra punctured for the same purpose. We have here a curious and inexplicable case of dimorphism, for some of the females of 4 European species of Dytiscus and of certain species of Hydroporus have their elytra smooth and no intermediate gradations between the sulcated or punctured and the quite smooth elytra have been observed. In the male of Crabrocribrarius it is the tibia which is dilated in a broad horny plate, with minute membranous dots giving to it a singular appearance like that of a riddle. The following statement about Penthe, and others in inverted commas, are taken from Mr. Walsh. In the male of Penthe, a genus of beetles, a few of the middle joints of the antennae are dilated and furnished on the inferior surface with cushions of hair, exactly like those on the tarsi of the Carabidae, and obviously for the same end. In male dragonflies, the appendages at the tip of the tail are modified in an almost infinite variety of curious patterns to enable them to embrace the neck of the female. Lastly, in the males of many insects, the legs are furnished with peculiar spines, knobs, or spurs, or the whole leg is bowed or thickened, but this is by no means invariably a sexual character, or one pair or all 3 pairs are elongated, sometimes to an extravagant length. The sexes of many species in all the orders present differences, of which the meaning is not understood. One curious case is that of a beetle, the male of which has the left mandible much enlarged, so that the mouth is greatly distorted. In another Carabidus beetle, Eurynathus, we have the case, unique as far as known to Mr. Wollaston, of the head of the female being much broader and larger, though in a variable degree, than that of the male. Any number of such cases could be given. They abound in the Lepidoptera. One of the most extraordinary is that certain male butterflies have their forelegs more or less atrophied, with the tibia and tarsi reduced to mere rudimentary knobs. The wings also in the 2 sexes often differ in neuration. I may add that the wings in certain Hymenoptera differ in neuration according to sex, and sometimes considerably in outline, as in the Ericoris epitus, which was shown to me in the British Museum by Mr. A. Butler. The males of certain South American butterflies have tufts of hair on the margins of the wings, and horny excrescences on the discs of the posterior pair. In several British butterflies, as shown by Mr. Wonfor, the males alone are in parts clothed with peculiar scales. The use of the bright light of the female glowworm has been subject to much discussion. The male is feebly luminous, as are the larvae and even the eggs. It has been supposed by some authors that the light serves to frighten away enemies, and by others to guide the male to the female. At last Mr. Belt appears to have solved the difficulty. He finds that all the Lampyridae which he has tried are highly distasteful to insectivorous mammals and birds. Hence it is in accordance with Mr. Bates' view, hereafter to be explained, that many insects mimic the Lampyridae closely in order to be mistaken for them, and thus to escape destruction. He further believes that the luminous species profit by being at once recognized and unpalatable. It is probable that the same explanation may be extended to the elateres, both sexes of which are highly luminous. It is not known why the wings of the female glowworm have not been developed, but in her present state she closely resembles a larva, and as larvae are so largely preyed on by many animals, we can understand why she has been rendered so much more luminous and conspicuous than the male, and why the larvae themselves are likewise luminous. Difference in size between the sexes. With insects of all kinds, the males are commonly smaller than the females, and this difference can often be detected even in the larval state. So considerable is the difference between the male and female cocoons of the silk moth, Bombyx mori, that in France they are separated by a particular mode of weighing. In the lower classes of the animal kingdom, the greater size of females seems generally to depend on their developing an enormous number of ova, and this may to a certain extent hold good with insects. But Dr. Wallace has suggested a much more probable explanation. He finds, after carefully attending to the development of the caterpillars of Bombyx cynthia and Yamamai, and especially to that of some dwarfed caterpillars reared from a second brood on unnatural food, that in proportions as the individual moth is finer, so is the time required for its metamorphosis longer, and for this reason the female, which is the larger and heavier insect, from having to carry her numerous eggs, will be preceded by the male, which is smaller and has less to mature. Now, as most insects are short-lived, and as they are exposed to many dangers, it would manifestly be advantageous for the female to be impregnated as soon as possible. This end would be gained by the males being first matured in large numbers ready for the advent of the females, and this again would naturally follow, as Mr. A.R. Wallace has remarked, through natural selection. For the smaller male would be first matured and thus would procreate a large number of offspring, which would inherit the reduced size of their male parents, whilst the larger males, from being matured later, would leave fewer offspring. There are, however, exceptions to the rule of male insects being smaller than the females, and some of these exceptions are intelligible. Size and strength would be an advantage to the males which fight for the possession of the females, and in these cases, as with the stag beetle Lucanus, the males are larger than the females. There are, however, other beetles which are not known to fight together, of which the males exceed the females in size, and the meaning of this fact is not known. But in some of these cases, as with the huge dynasties and Megasoma, we can at least see that there would be no necessity for the males to be smaller than the females in order to be matured before them, for these beetles are not short-lived, and there would be ample time for the pairing of the sexes. So again, male dragonflies, Libellulidae, are sometimes sensibly larger, and never smaller, than the females. And as Mr. McLaughlin believes, they do not generally pair with the females until a week or fortnight has elapsed, and until they have assumed their proper masculine colours. But the most curious case, showing on what complex and easily overlooked relations so trifling a character as difference in size between the sexes may depend, is that of the aculeate Hymenoptera. For Mr. F. Smith informs me that throughout nearly the whole of this large group the males, in accordance with the general rule, are smaller than the females, and emerge about a week before them. But amongst the bees, the males of Apis mellifica, Anthidium manicatum, and Anthophora acervorum, and amongst the Fossores, the males of the Methoca ichneumanoides are larger than the females. The explanation of this anomaly is that a marriage flight is absolutely necessary with these species, and the male requires great strength and size in order to carry the female through the air. Increased size has here been acquired in opposition to the usual relation between size and the period of development, for the males, though larger, emerge before the smaller females. We will now review the several orders, selecting such facts as more particularly concern us. The Lepidoptera, butterflies and moths, will be retained for a separate chapter. Order Thysanura. The members of this lowly organized order are wingless, dull-colored, minute insects with ugly, almost misshapen heads and bodies. Their sexes do not differ, but they are interesting as showing us that the males pay sedulous court to the females even low down in the animal scale. Sir J. Lubbock says, "It is very amusing to see these little creatures, Sminthurus luteus, coquetting together. The male, which is much smaller than the female, runs round her, and they butt one another standing face to face, and moving backward and forward like two playful lambs. Then the female pretends to run away, and the male runs after her with a queer appearance of anger, gets in front, and stands facing her again. Then she turns coyly round, but he, quicker and more active, scuttles round too, and seems to whip her with his antennae. Then for a bit they stand face to face, play with their antennae, and seem to be all in all to one another." Order Diptera, flies. The sexes differ little in colour. The greatest difference, known to Mr. F. Walker, is in the genus Bibio, in which the males are blackish or quite black, and the females obscure brownish-orange. The genus Elaphomyia, discovered by Mr. Wallace in New Guinea, is highly remarkable, as the males are furnished with horns, of which the females are quite destitute. The horns spring from beneath the eyes, and curiously resemble those of a stag, being either branched or palmated. In one of these species they equal the whole body in length. They might be thought to be adapted for fighting, but as in one species they are of a beautiful pink colour, edged with black, with a pale central stripe, and as these insects have altogether a very elegant appearance, it is perhaps more probable that they serve as ornaments. That the males of some Diptera fight together is certain. Professor Westwood has several times seen this with Tipuli. The males of other Diptera apparently try to win the females by their music. H. Müller watched for some time two males of an Aristolus courting a female. They hovered above her, and flew from side to side, making a high humming noise at the same time. Gnats and mosquitoes, Culicidae, also seem to attract each other by humming, and Professor Meyer has recently ascertained that the hairs on the antennae of the male vibrate in unison with the notes of a tuning fork within the range of sounds emitted by the female. The longer hairs vibrate sympathetically with the graver notes, and the shorter hairs with the higher notes. Landois also asserts that he has repeatedly drawn down a whole swarm of gnats by uttering a particular note. It may be added that the mental faculties of the Diptera are probably higher than in most other insects, in accordance with their highly developed nervous system. See Mr. B. T. Lowndes' interesting work on the anatomy of the blowfly Musa vomitoria, 1870. He remarks that the captured flies utter a peculiar plaintive note, and that this sound causes other flies to disappear. Order Hemiptera, field bugs. Mr. J. W. Douglas, who has particularly attended to the British species, has kindly given me an account of their sexual differences. The males of some species are furnished with wings, whilst the females are wingless. The sexes differ in the form of their bodies, elytra, antennae, and tarsi, but as the signification of these differences are unknown, they may be here passed over. The females are generally larger and more robust than the males. With British, and as far as Mr. Douglas knows, with exotic species, the sexes do not commonly differ much in colour, but in about 6 British species the male is considerably darker than the female, and in about 4 other species the female is darker than the male. Both sexes of some species are beautifully coloured, and as these insects emit an extremely nauseous odour, their conspicuous colours may serve as a signal that they are unpalatable to insectivorous animals. In some few cases their colours appear to be directly protective. Thus Professor Hoffman informs me that he could hardly distinguish a small pink and green species from the buds on the trunks of lime trees, which this insect frequents. Some species of Reduvidae make a stridulating noise, and in the case of Parades stridulus this is said to be effected by the movement of the neck within the prothoracic cavity. According to Westring, Reduvius personatus also stridulates, but I have no reason to suppose that this is a sexual character, excepting that with non-social insects there seems to be no use for sound-producing organs unless it be as a sexual call. Order Homoptera. Every one who has wandered in a tropical forest must have been astonished at the din made by the male cicadae. The females are mute. As the Grecian poet Xenarchus says, "Happy the cicadas live, since they all have voiceless wives." The noise thus made could be plainly heard on board the Beagle, when anchored at 1/4 of a mile from the shore of Brazil, and Captain Hancock says it can be heard at least the distance of a mile. The Greeks formerly kept, and the Chinese now keep, these insects in cages for the sake of their song, so that it must be pleasing to the ears of some men. The Cicadidae usually sing during the day, whilst the Filgoridae appear to be night songsters. The sound, according to Landois, is produced by the vibration of the lips of the spiracles, which are set into motion by a current of air emitted from the tracheae, but this view has lately been disputed. Dr. Powell appears to have proved that it is produced by the vibration of a membrane, set into action by a special muscle. In the living insect, while stridulating, this membrane can be seen to vibrate, and in the dead insect the proper sound is heard if the muscle, when a little dried and hardened, is pulled with the point of a pin. In the female the whole complex musical apparatus is present, but is much less developed than in the male, and is never used for producing sound. With respect to the object of the music, Dr. Hartmann, in speaking of the cicada septemdecim of the United States, says, "The drums are now, June 6th and 7th, 1851, heard in all directions. This I believe to be the marital summons from the males. Standing in thick chestnut sprouts about as high as my head, where hundreds were around me, I observed the females coming around the drumming males." He adds, "This season, August 1868, a dwarf pear tree in my garden produced about 50 larvae of Cicada pruinosa, and I several times noticed the females to alight near a male while he was uttering his clanging notes." Fritz Müller writes to me from South Brazil that he has often listened to a musical contest between 2 or 3 males of a species with a particularly loud voice, seated at a considerable distance from each other. As soon as one had finished his song, another immediately began, and then another. As there is so much rivalry between the males, it is probable that the females not only find them by their sounds, but that, like female birds, they are excited or allured by the male with the most attractive voice. I have not heard of any well-marked cases of ornamental differences between the sexes of the Homoptera. Mr. Douglas informs me that there are 3 British species in which the male is black or marked with black bands, whilst the females are pale-coloured or obscure. Order Orthoptera, crickets and grasshoppers. The males in the 3 saltatorial families in this order are remarkable for their musical powers, namely the Achetidae or crickets, the Locustidae, for which there is no equivalent English name, and the Acrididae or grasshoppers. The stridulation produced by some of the Locustidae is so loud that it can be heard during the night at the distance of a mile, and that made by certain species is not unmusical even to the human ear, so that the Indians on the Amazons keep them in wicker cages. All observers agree that the sounds serve either to call or excite the mute females. With respect to the migratory locusts of Russia, Korte has given an interesting case of selection by the female of a male. The males of this species, Pachytylus migratorius, whilst coupled with the female, stridulate from anger or jealousy if approached by other males. The house cricket, when surprised at night, uses its voice to warn its fellows. In North America, the katydid, Platyphilum concavum, one of the Locustidae, is described as mounting on the upper branches of a tree, and in the evening beginning his noisy babble while rival notes issue from the neighbouring trees, and the groves resound with the call of "Katydid, she did," the livelong night. Mr. Bates, in speaking of the European field cricket, one of the Achetidae, says the male has been observed to place himself in the evening at the entrance of his burrow, and stridulate until a female approaches, when the louder notes are succeeded by a more subdued tone, whilst the successful musician caresses with his antennae the mate he has won. Mr. Bates gives a very interesting discussion on the gradations in the musical apparatus of the three families. Dr. Scudder was able to excite one of these insects to answer him by rubbing on a file with a quill. In both sexes a remarkable auditory apparatus has been discovered by von Siebold, situated in the front legs. In the three families the sounds are differently produced. In the males of the Achetidae, both wing covers have the same apparatus, and this in the field cricket consists, as described by Landois, of from 131 to 138 sharp transverse ridges or teeth on the underside of one of the nervures of the wing cover. This toothed nervure is rapidly scraped across a projecting smooth hard nervure on the upper surface of the opposite wing. First one wing is rubbed over the other, and then the movement is reversed. Both wings are raised a little at the same time, so as to increase the resonance. In some species the wing covers of the males are furnished at the base with a talc-like plate. I here give a drawing of the teeth on the underside of the nervure of another species of Gryllus, that is, Gryllus domesticus. With respect to the formation of these teeth, Dr. Gruber has shown that they have been developed by the aid of selection from the minute scales and hairs with which the wings and body are covered, and I came to the same conclusion with respect to those of the Coleoptera. But Dr. Gruber further shows that their development is in part directly due to the stimulus from the friction of one wing over the other. In the Locustidae, the opposite wing covers differ from each other in structure, and the action cannot, as in the last family, be reversed. The left wing, which acts as the bow, lies over the right wing, which serves as the fiddle. One of the nervures on the under surface of the former is finely serrated, and is scraped across the prominent nervures on the upper surface of the opposite or right wing. In our British Phasgonura viridissima, it appears to me that the serrated nervure is rubbed against the rounded hind corner of the opposite wing, the edge of which is thickened, coloured brown, and very sharp. In the right wing, but not in the left, there is a little plate, as transparent as talc, surrounded by nervures, and called the speculum. In Ephippiger a member of this same family, we have a curious subordinate modification, for the wing covers are greatly reduced in size, but the posterior part of the prothorax is elevated into a kind of dome over the wing covers, and which has probably the effect of increasing the sound. We thus see that the musical apparatus is more differentiated or specialized in the Locustidae, which include, I believe, the most powerful performers in the order, than in the Achetidae, in which both wing covers have the same structure and the same function. Landois, however, detected in one of the Locustidae, namely Edecticus, a short and narrow row of small teeth, mere rudiments, on the inferior surface of the right wing cover, which underlies the other and is never used as the bow. I observed the same rudimentary structure on the underside of the right wing cover in Phasgonura viridissima. Hence we may infer with confidence that the Locustidae are descended from a form in which, as in the existing Achetidae, both wing covers had serrated nervures on the under surface, and could be indifferently used as the bow, but that in the Locustidae the two wing covers gradually became differentiated and perfected on the principle of the division of labour, the one to act exclusively as the bow and the other as the fiddle. Dr. Gruber takes the same view, and has shown that rudimentary teeth are commonly found on the inferior surface of the right wing. By what steps the more simple apparatus of the Achetidae originated we do not know, but it is probable that the basal portions of the wing covers originally overlapped each other, as they do at present, and that the friction of the nervures produced a grating sound, as is now the case with the wing covers of the females. Mr. Walsh also informs me that he has noticed that the female of the Platyphilum concavum, when captured, makes a feeble grating noise by shuffling her wing covers together. A grating sound thus occasionally and accidentally made by males, if it served them ever so little as a love call to the females, might readily have been intensified through sexual selection by variations in the roughness of the nervures having been continually preserved. In the last and third family, namely the Acrididae or grasshoppers, the stridulation is produced in a very different manner, and, according to Dr. Scudder, is not so shrill as in the preceding families. The inner surface of the femur is furnished with a longitudinal row of minute, elegant, lancet-shaped elastic teeth, from 85 to 93 in number, and these are scraped across the sharp projecting nervures on the wing covers, which are thus made to vibrate and resound. Harris says that when one of the males begins to play, he first bends the shank of the hind leg beneath the thigh where it is lodged in a furrow designed to receive it, and then draws the leg briskly up and down. He does not play both fiddles together, but alternately, first upon one and then on the other. In many species, the base of the abdomen is hollowed out in a great cavity, which is believed to act as a resounding board. In Pneumora, a South African genus belonging to the same family, we meet with a new and remarkable modification. In the males, a small notched ridge projects obliquely from each side of the abdomen, against which the hind femora are rubbed. As the male is furnished with wings, the female being wingless, it is remarkable that the thighs are not rubbed in the usual manner against the wing covers, but this may perhaps be accounted for by the unusually small size of the hind legs. I have not been able to examine the inner surface of the thighs, which, judging from analogy, would be finely serrated. The species of Pneumora have been more profoundly modified for the sake of stridulation than any other orthopterous insect, for in the male the whole body has been converted into a musical instrument, being distended with air like a great pellucid bladder, so as to increase the resonance. Mr. Trimen informs me that at the Cape of Good Hope these insects make a wonderful noise during the night. In the three foregoing families, the females are almost always destitute of an efficient musical apparatus. But there are a few exceptions to this rule, for Dr. Gruber has shown that both sexes of Amphibian vidium are thus provided, though the organs differ in the male and the female to a certain extent. Hence we cannot suppose that they have been transferred from the male to the female, as appears to have been the case with the secondary sexual characters of many other animals. They must have been independently developed in the two sexes, which no doubt mutually called to each other during the season of love. In most other Locustidae, but not according to Landois in Decticus, the females have rudiments of the stridulatory organs proper to the male, from whom it is probable that these have been transferred. Landois also found such rudiments on the under surface of the wing covers of the female Achetidae and on the femora of the female Acrididae. In the Homoptera also the females have the proper musical apparatus, in a functionless state, and we shall hereafter meet in other divisions of the animal kingdom with many instances of structures proper to the male being present in a rudimentary condition in the female. Landois has observed another important fact, namely that in the females of the Acrididae the stridulating teeth on the femora remain throughout life in the same condition in which they first appear during the larval state in both sexes. In the males, on the other hand, they become further developed, and acquire their perfect structure at the last moult, when the insect is mature and ready to breed. From the facts now given, we see that the means by which the males of the Orthoptera produce their sounds are extremely diversified, and are altogether different from those employed by the Homoptera. Landois has recently found in certain Orthoptera rudimentary structures closely similar to the sound-producing organs in the Homoptera, and this is a surprising fact. But throughout the animal kingdom we often find the same object gained by the most diversified means. This seems due to the whole organization having undergone multifarious changes in the course of ages, and as part after part varied, different variations were taken advantage of for the same general purpose. The diversity of means for producing sound in the three families of the Orthoptera and in the Homoptera impresses the mind with the high importance of these structures to the males, for the sake of calling or alluring the females. We need feel no surprise at the amount of modification which the Orthoptera have undergone in this respect, as we now know, from Dr. Scudder's remarkable discovery, that there has been more than ample time. This naturalist has lately found a fossil insect in the Devonian formation of New Brunswick, which is furnished with the well-known tympanum or stridulating apparatus of the male Locustidae. The insect, though in most respects related to the Neuroptera, appears, as is so often the case with very ancient forms, to connect the two related orders of the Neuroptera and the Orthoptera. I have but little more to say on the Orthoptera. Some of the species are very pugnacious. When two male field crickets, Gryllus campestris, are confined together, they will fight till one kills the other. And the species of mantis are described as manoeuvring with their sword-like front limbs like hussars with their sabres. The Chinese keep these insects in little bamboo cages and match them like gamecocks. With respect to color, some exotic locusts are beautifully ornamented, the posterior wings being marked with red, blue, and black. But as throughout the order the sexes rarely differ much in colour, it is not probable that they owe their bright tints to sexual selection. Conspicuous colours may be of use to these insects by giving notice that they are unpalatable. Thus it has been observed that a bright-coloured Indian locust was invariably rejected when offered to birds and lizards. Some cases, however, are known of sexual differences in colour in this order. The male of an American cricket is described as being as white as ivory, whilst the female varies from almost white to greenish-yellow or dusky. Mr. Walsh informs me that the adult male of Spectrum femeratum, one of the Phasmidae, is of a shining brownish-yellow colour, the adult female being of a dull opaque cinereous brown, the young of both sexes being green. Lastly, I may mention that the male of one curious kind of cricket is furnished with a long membranous appendage which falls over the face like a veil, but what its use may be is not known. Order Neuroptera. Little need here be said, except as to colour. In the Ephemeridae, the sexes often differ slightly in their obscure tints, but it is not probable that the males are thus rendered attractive to the females. The Libellulidae, or dragonflies, are ornamented with splendid green, blue, yellow, and vermilion metallic tints, and the sexes often differ. Thus, as Professor Westwood remarks, the males of some Agrionidae are of a rich blue with black wings, whilst the females are fine green, with colourless wings. But in Agrion ramburi, these colours are exactly reversed in the two sexes. In the extensive North American genus of Heterina, the males alone have a beautiful carmine spot at the base of each wing. In Anax junius, the basal part of the abdomen in the male is a vivid ultramarine blue, and in the female, grass green. In the allied genus Gomphus, on the other hand, and in some other genera, the sexes differ but little in colour. In closely allied forms throughout the animal kingdom, similar cases of the sexes differing greatly, or very little, or not at all, are of frequent occurrence. Although there is so wide a difference in colour between the sexes of many Libellulidae, it is often difficult to say which is the more brilliant, and the ordinary coloration of the two sexes is reversed, as we have just seen, in one species of Agrion. It is not probable that these colours in any case have been gained as a protection. Mr. McLaughlin, who has closely attended to this family, writes to me that the dragonflies, the tyrants of the insect world, are the least liable of any insect to be attacked by birds or other enemies, and he believes that their bright colours serve as a sexual attraction. Certain dragonflies apparently are attracted by particular colours. Mr. Patterson observed that the Agrionidae, of which the males are blue, settled in numbers on the blue float of a fishing line, whilst two other species are attracted by shining white colours. It is an interesting fact, first noted by Shelver, that in several genera belonging to two subfamilies, the males on first emergence from the pupal state are coloured exactly like the females, but that their bodies in a short time assume a conspicuous milky blue tint, owing to the exudation of a kind of oil, soluble in ether and alcohol. Mr. McLaughlin believes that in the male of Libellula depressa this change of colour does not occur until nearly a fortnight after the metamorphosis, when the sexes are ready to pair. Certain species of Neurothemis present, according to Brouwer, a curious case of dimorphism, some of the females having ordinary wings, whilst others have them very richly netted, as in the males of the same species. Brouwer explains the phenomenon on Darwinian principles by the supposition that the close netting of the veins is a secondary sexual character in the males, which has been abruptly transferred to some of the females, instead of, as generally occurs, to all of them. Mr. McLaughlin informs me of another instance of dimorphism in several species of Agrion, in which some individuals are of an orange colour, and these are invariably females. This is probably a case of reversion, for in the true Libellulae, when the sexes differ in colour, the females are orange or yellow, so that supposing Agrion to be descended from some primordial form which resembled the typical Libellulae in its sexual characters, it would not be surprising that a tendency to vary in this manner should occur in the females alone. Although many dragonflies are large, powerful, and fierce insects, the males have not been observed by Mr. McLaughlin to fight together, excepting, as he believes, in some of the smaller species of Agrion. In another group in this order, namely the termites or white ants, both sexes at the time of swarming may be seen running about, the male after the female, sometimes two chasing one female, and contending with great eagerness who shall win the prize. The Atropo pulsatorius is said to make a noise with its jaws, which is answered by other individuals. End of section 8. Section 9 of The Descent of Man, Part 2. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Elsa Youngstead. The Descent of Man, Part 2, by Charles Darwin. Chapter 10, Secondary Sexual Characters of Insects, Part 2. Order Hymenoptera. That inimitable observer, M. Fabre, in describing the habits of Cerceris, a wasp-like insect, remarks that fights frequently ensue between the males for the possession of some particular female, who sits an apparently unconcerned beholder of the struggle for supremacy, and when the victory is decided, quietly flies away in company with the conqueror. Westwood says that the males of one of the sawflies, Tinthridini, have been found fighting together with their mandibles locked. As M. Fabre speaks of the males of Cerceris striving to obtain a particular female, it may be well to bear in mind that insects belonging to this order have the power of recognizing each other after long intervals of time, and are deeply attached. For instance, Pierre Huber, whose accuracy no one doubts, separated some ants, and when, after an interval of 4 months, they met others which had formerly belonged to the same community, they recognized and caressed one another with their antennae. Had they been strangers, they would have fought together. Again, when two communities engage in a battle, the ants on the same side sometimes attack each other in the general confusion, but they soon perceive their mistake, and the one ant soothes the other. In this order, slight differences in colour, according to sex, are common, but conspicuous differences are rare, except in the family of bees. Yet both sexes of certain groups are so brilliantly coloured, for instance in Chrysis, in which vermilion and metallic greens prevail, that we are tempted to attribute the result to sexual selection. In the Ichneumonidae, according to Mr. Walsh, the males are almost universally lighter coloured than the females. On the other hand, in the Tinthridinidae the males are generally darker than the females. In the Cyricidae the sexes frequently differ, thus the male of Cyrex juvencus is banded with orange, whilst the female is dark purple. But it is difficult to say which sex is the more ornamented. In Trimex columbi the female is much brighter coloured than the male. I am informed by Mr. F. Smith that the male ants of several species are black, the females being testaceous. In the family of bees, especially in the solitary species, as I hear from the same entomologist, the sexes often differ in colour. The males are generally the brighter, and in Bombus, as well as in Apathis, much more variable in colour than the females. In Anthophora retusa the male is of a rich fulvous brown, whilst the female is quite black. So are the females of several species of Xylocopa, the males being bright yellow. On the other hand, the females of some species, as of Andrena fulva, are much brighter coloured than the males. Such differences in colour can hardly be accounted for by the males being defenceless and thus requiring protection, whilst the females are well defended by their stings. H. Müller, who has particularly attended to the habits of bees, attributes these differences in colour in chief part to sexual selection. That bees have a keen perception of colour is certain. He says that the males search eagerly and fight for the possession of the females, and he accounts through such contests for the mandibles of the males being in certain species larger than those of the females. In some cases the males are far more numerous than the females, either early in the season or at all times and places or locally, whereas the females in other cases are apparently in excess. In some species the more beautiful males appear to have been selected by the females, and in others the more beautiful females by the males. Consequently, in certain genera the males of the several species differ much in appearance, whilst the females are almost indistinguishable. In other genera the reverse occurs. H. Müller believes that the colours gained by one sex through sexual selection have often been transferred in a variable degree to the other sex, just as the pollen-collecting apparatus of the female has often been transferred to the male, to whom it is absolutely useless. M. Perrier, in his article La sélection sexuelle d'après Darwin, without apparently having reflected much on the subject, objects that as the male of social bees are known to be produced from unfertilized ova, they could not transmit new characters to their male offspring. This is an extraordinary objection. A female bee fertilized by a male, which presented some character facilitating the union of the sexes, or rendering him more attractive to the female, would lay eggs which would produce only females, but these young females would next year produce males, and will it be pretended that such males would not inherit the characters of their male grandfathers? To take a case with ordinary animals as nearly parallel as possible, if a female of any white quadruped or bird were crossed by a male of a black breed, and the male and female offspring were paired together, will it be pretended that the grandchildren would not inherit a tendency to blackness from their male grandfather? The acquirement of new characters by the sterile worker bees is a much more difficult case, but I have endeavoured to show in my Origin of Species how these sterile beings are subjected to the power of natural selection. Mutilla europea makes a stridulating noise, and according to Gouraud both sexes have this power. He attributes the sound to the friction of the third and preceding abdominal segments, and I find that these surfaces are marked with very fine concentric ridges. But so is the projecting thoracic collar into which the head articulates, and this collar, when scratched with the point of a needle, emits the proper sound. It is rather surprising that both sexes should have the power of stridulating, as the male is winged and the female wingless. It is notorious that bees express certain emotions, as of anger, by the tone of their humming, and according to H. Müller, the males of some species make a peculiar singing noise whilst pursuing the females. Order Coleoptera. Beetles. Many beetles are coloured so as to resemble the surfaces which they habitually frequent, and they thus escape detection by their enemies. Other species, for instance diamond beetles, are ornamented with splendid colours, which are often arranged in stripes, spots, crosses, and other elegant patterns. Such colours can hardly serve directly as a protection, except in the case of certain flower-feeding species, but they may serve as a warning or means of recognition on the same principle as the phosphorescence of the glowworm. As with beetles the colours of the two sexes are generally alike, we have no evidence that they have been gained through sexual selection. But this is at least possible, for they have been developed in one sex and then transferred to the other, and this view is even in some degree probable in those groups which possess other well-marked secondary sexual characters. Blind beetles, which cannot of course behold each other's beauty, never, as I hear from Mr. Waterhouse, Jr., exhibit bright colours, though they often have polished coats, but the explanation of their obscurity may be that they generally inhabit caves and other obscure stations. Some longicorns, especially certain Prionidae, offer an exception to the rule that the sexes of beetles do not differ in colour. Most of these insects are large and splendidly coloured. The males in the genus Pyrodes, which I saw in Mr. Bates' collection, are generally redder, but rather duller, than the females, the latter being coloured of a more or less splendid golden green. On the other hand, in one species the male is golden green, the female being richly tinted with red and purple. Pyrodes pulcherimus, in which the sexes differ conspicuously, has been described by Mr. Bates. I will specify the few other cases in which I have heard of a difference in the colour between the sexes of beetles. Kirby and Spence mention Acantharis, Meloa, Regium, and the Leptura testacea, the male of the latter being testaceous with a black thorax, and the female of a dull red all over. These two latter beetles belong to the family of longicorns. Messrs. R. Trimen and Waterhouse, Jr., inform me of two lamellicorns, that is, a Paratrichia and Trichius, the male of the latter being more obscurely coloured than the female. In Tillus elongatus the male is black, and the female always, as it is believed, of a dark blue colour with a red thorax. The male also of Orsodacna atra, as I hear from Mr. Walsh, is black, the female, the so-called O. ruficalis, having a rufous thorax. In the genus Esmeralda the sexes differ so greatly in colour that they have been ranked as distinct species. In one species both are of a beautiful shining green, but the male has a red thorax. On the whole, as far as I could judge, the females of those Prionidae in which the sexes differ are coloured more richly than the males, and this does not accord with the common rule in regard to colour when acquired through sexual selection. A most remarkable distinction between the sexes of many beetles is presented by the great horns which rise from the head, thorax, and clypeus of the males, and in some few cases from the under surface of the body. These horns in the great family of the lamellicorns resemble those of various quadrupeds, such as stags, rhinoceroses, etc., and are wonderful both from their size and diversified shapes. Instead of describing them, I have given figures of the males and females of some of the more remarkable forms. The females generally exhibit rudiments of the horns in the form of small knobs or ridges, but some are destitute of even the slightest rudiment. On the other hand, the horns are nearly as well developed in the female as in the male Phineus lancifer, and only a little less well developed in the females of some other species of this genus, and of Copris. I am informed by Mr. Bates that the horns do not differ in any manner corresponding with the more important characteristic differences between the several subdivisions of the family. Thus within the same section of the genus Onthophagus there are species which have a single horn, and others which have two. In almost all cases the horns are remarkable from their excessive variability, so that a graduated series can be formed from the most highly developed males to others so degenerate that they can barely be distinguished from the females. Mr. Walsh found that in Phineus carnifex the horns were thrice as long in some males as in others. Mr. Bates, after examining above 100 males of Onthophagus rangifer, thought he had at last discovered a species in which the horns did not vary, but further research proved the contrary. The extraordinary size of the horns, and their widely different structure in closely allied forms, indicate that they have been formed for some purpose, but their excessive variability in the males of the same species leads to the inference that this purpose cannot be of a definite nature. The horns do not show marks of friction, as if used for any ordinary work. Some authors suppose that as the males wander about much more than the females, they require horns as a defense against their enemies. But as the horns are often blunt, they do not seem well adapted for defense. The most obvious conjecture is that they are used by the males for fighting together, but the males have never been observed to fight, nor could Mr. Bates, after a careful examination of numerous species, find any sufficient evidence in their mutilated or broken condition of their having been thus used. If the males had been habitual fighters, the size of their bodies would probably have been increased through sexual selection so as to have exceeded that of the females. But Mr. Bates, after comparing the two sexes in above 100 species of the Copridae, did not find any marked difference in this respect amongst the well-developed individuals. In Lethrus, moreover, a beetle belonging to the same great division of the Lamellicorns, the males are known to fight, but are not provided with horns, though their mandibles are much larger than those of the female. The conclusion that the horns have been acquired as ornaments is that which best agrees with the fact of their having been so immensely, yet not fixedly, developed, as shown by their extreme variability in the same species, and by their extreme diversity in closely allied species. This view will at first appear extremely improbable, but we shall hereafter find, with many animals standing much higher in the scale, namely fishes, amphibians, reptiles, and birds, that various kinds of crests, knobs, horns, and combs have been developed, apparently for this sole purpose. The males of Onitis furcifer, and of some other species of the genus, are furnished with singular projections on their anterior femora, and with a great fork or pair of horns on the lower surface of the thorax. Judging from other insects, these may aid the male in clinging to the female. Although the males have not even a trace of a horn on the upper surface of the body, yet the females plainly exhibit a rudiment of a single horn on the head, and of a crest on the thorax. That the slight thoracic crest in the female is a rudiment of a projection proper to the male, though entirely absent in the male of this particular species, is clear. For the female of Bubis bison, a genus which comes next to Onitis, has a similar slight crest on the thorax, and the male bears a great projection in the same situation. So again there can hardly be a doubt that the little point on the head of the female Onitis furcifer, as well as on the head of the females of 2 or 3 allied species, is a rudimentary representative of the cephalic horn, which is common to the males of so many lamellicorn beetles, as in Phineus. The old belief that rudiments have been created to complete the scheme of nature is here so far from holding good that we have a complete inversion of the ordinary state of things in the family. We may reasonably suspect that the males originally bore horns and transferred them to the females in a rudimentary condition, as in so many other lamellicorns. Why the males subsequently lost their horns we know not, but this may have been caused through the principle of compensation, owing to the development of the large horns and projections on the lower surface, and as these are confined to the males, the rudiments of the upper horns on the females would not have been thus obliterated. The cases hitherto given refer to the lamellicorns, but the males of some few other beetles, belonging to 2 widely distinct groups, namely the Curculionidae and Staphylinidae, are furnished with horns, in the former on the lower surface of the body, in the latter on the upper surface of the head and thorax. In the Staphylinidae, the horns of the males are extraordinarily variable in the same species, just as we have seen with the lamellicorns. In Syagonium we have a case of dimorphism, for the males can be divided into two sets, differing greatly in the size of their bodies and in the development of their horns, without intermediate gradations. In a species of Bleedius, also belonging to the Staphylinidae, Professor Westwood states that male specimens can be found in the same locality, in which the central horn of the thorax is very large, but the horns of the head quite rudimental, and others in which the thoracic horn is much shorter, whilst the protuberances on the head are long. In the British Museum I noticed one male specimen of Syagonium in an intermediate condition, so that the dimorphism is not strict. Here we apparently have a case of compensation, which throws light on that just given of the supposed loss of the upper horns by the males of Onitis. Law of battle. Some male beetles, which seem ill-fitted for fighting, nevertheless engage in conflicts for the possession of the females. Mr. Wallace saw two males of Leptorhynchus angustatus, a linear beetle with a much elongated rostrum, fighting for a female, who stood close by busy at her boring. They pushed at each other with their rostra, and clawed and thumped, apparently in the greatest rage. The smaller male, however, soon ran away, acknowledging himself vanquished. In some few cases male beetles are well adapted for fighting by possessing great toothed mandibles much larger than those of the females. This is the case with the common stag beetle, Lucanus cervus, the males of which emerge from the pupal state about a week before the other sex, so that several may often be seen pursuing the same female. At this season they engage in fierce conflicts. When Mr. A. H. Davis enclosed two males with one female in a box, the larger male severely pinched the smaller one until he resigned his pretensions. A friend informs me that when a boy he often put the males together to see them fight, and he noticed that they were much bolder and fiercer than the females, as with the higher animals. The males would seize hold of his finger if held in front of them, but not so the females, although they have stronger jaws. The males of many of the Lucanidae, as well as of the above-mentioned Leptorhynchus, are larger and more powerful insects than the females. The two sexes of Lethrus cephalotes, one of the lamellicorns, inhabit the same burrow, and the male has larger mandibles than the female. If, during the breeding season, a strange male attempts to enter the burrow, he is attacked. The female does not remain passive, but closes the mouth of the burrow, and encourages her mate by continually pushing him on from behind, and the battle lasts until the aggressor is killed or runs away. The two sexes of another lamellicorn beetle, the Atucus cicatricosus, live in pairs and seem much attached to each other. The male excites the females to roll the balls of dung in which the ova are deposited, and if she is removed he becomes much agitated. If the male is removed, the female ceases all work, and, as M. Brulery believes, would remain on the same spot until she died. The great mandibles of the male Lucanidae are extremely variable both in size and structure, and in this respect resemble the horns on the head and thorax of many male lamellicorns and Staphylinidae. A perfect series can be formed from the best provided to the worst provided or degenerate males. Although the mandibles of the common stag beetle, and probably of many other species, are used as efficient weapons for fighting, it is doubtful whether their great size can thus be accounted for. We have seen that they are used by the Lucanus elaphus of North America for seizing the female. As they are so conspicuous and so elegantly branched, and as owing to their great length they are not well adapted for pinching, the suspicion has crossed my mind that they may in addition serve as an ornament, like the horns on the head and thorax of the various species above described. The male Chiasognathus grantii of South Chile, a splendid beetle belonging to the same family, has enormously developed mandibles. He is bold and pugnacious. When threatened, he faces round, opens his great jaws, and at the same time stridulates loudly. But the mandibles were not strong enough to pinch my finger so as to cause actual pain. Sexual selection, which implies the possession of considerable perceptive powers and of strong passions, seems to have been more effective with the lamellicorns than with any other family of beetles. With some species the males are provided with weapons for fighting. Some live in pairs and show mutual affection. Many have the power of stridulating when excited. Many are furnished with the most extraordinary horns, apparently for the sake of ornament. And some, which are diurnal in their habits, are gorgeously colored. Lastly, several of the largest beetles in the world belong to this family, which was placed by Linnaeus and Fabricius as the head of the order. Stridulating organs. Beetles belonging to many and widely distinct families possess these organs. The sound thus produced can sometimes be heard at the distance of several feet or even yards, but it is not comparable with that made by the Orthoptera. The rasp generally consists of a narrow, slightly raised surface crossed by very fine parallel ribs, sometimes so fine as to cause iridescent colours, and having a very elegant appearance under the microscope. In some cases, as with Typhoeus, minute bristly or scale-like prominences, with which the whole surrounding surface is covered in approximately parallel lines, could be traced passing into the ribs of the rasp. The transition takes place by their becoming confluent and straight, and at the same time more prominent and smooth. A hard ridge on the adjoining part of the body serves as the scraper for the rasp, but this scraper in some cases has been specially modified for the purpose. It is rapidly moved across the rasp, or conversely the rasp across the scraper. These organs are situated in widely different positions. In the carrion beetles, Necrophorus, two parallel rasps stand on the dorsal surface of the fifth abdominal segment, each rasp consisting of 126 to 140 fine ribs. These ribs are scraped across the posterior margins of the elytra, a small portion of which projects beyond the general outline. In many Cryoceridae, and in Clythra quadripunctata, one of the Chrysomelidae, and in some Tenebrionidae, the rasp is seated on the dorsal apex of the abdomen, on the pygidium or propygidium, and is scraped in the same manner by the elytra. I am greatly indebted to Mr. G. R. Crotch for having sent me many prepared specimens of various beetles belonging to these three families and to others, as well as for valuable information. He believes that the power of stridulation in the Clythra has not been previously observed. I am also much indebted to Mr. E. W. Jansen for information and specimens. I may add that my son, Mr. F. Darwin, finds that Dermestes marinus stridulates, but he searched in vain for the apparatus. Scolitis has lately been described by Dr. Chapman as a stridulator. In Heteroceras, which belongs to another family, the rasps are placed on the sides of the first abdominal segment, and are scraped by ridges on the femora. In certain Curculionidae and Carabidae the parts are completely reversed in position, for the rasps are seated on the inferior surface of the elytra, near their apices or along the outer margins, and the edges of the abdominal segments serve as the scrapers. Westring has described the stridulating organs in these two, as well as in other families. In the Carabidae I have examined Elaphrus uliginosus and Blathisa multipunctata, sent to me by Mr. Crotch. In Blathisa, the transverse ridges on the furrowed border of the abdominal segment do not, as far as I could judge, come into play in scraping the rasps on the elytra. In Pelobius hermani, one of the Dyticidae or water beetles, a strong ridge runs parallel and near to the sutural margin of the elytra, and is crossed by ribs, coarse in the middle part, but becoming gradually finer at both ends, especially at the upper end. When this insect is held under water or in the air, a stridulating noise is produced by the extreme horny margin of the abdomen being scraped against the rasps. In a great number of longhorn beetles, Longicornia, the organs are situated quite otherwise, the rasp being on the mesothorax, which is rubbed against the prothorax. Landois counted 238 very fine ribs on the rasp of Cerambix heros. Many lamellicorns have the power of stridulating, and the organs differ greatly in position. Some species stridulate very loudly, so that when Mr. F. Smith caught a Trox sabulosus, a gamekeeper who stood by thought he had caught a mouse. But I failed to discover the proper organs in this beetle. In Geotrupes and Typhoeus, a narrow ridge runs obliquely across the coxa of each hind leg, having in G. stercorarius 84 ribs, which is scraped by a specially projecting part of one of the abdominal segments. In the nearly allied Copris lunaris, an excessively narrow fine rasp runs along the sutural margin of the elytra, with another short rasp near the basal outer margin. But in some other Coprini the rasp is seated, according to Leconte, on the dorsal surface of the abdomen. In Oryctes it is seated on the propygidium, and according to the same entomologist in some other Dynastinae, on the under surface of the elytra. Lastly, Westring states that in Omaloplia brunea the rasp is placed on the prosternum, and the scraper on the metasternum, the parts thus occupying the under surface of the body instead of the upper surface, as in the Longicorns. We thus see that in the different Coleopterous families, the stridulating organs are wonderfully diversified in position, but not much in structure. Within the same family, some species are provided with these organs, and others are destitute of them. This diversity is intelligible if we suppose that originally various beetles made a shuffling or hissing noise by the rubbing together of any hard and rough parts of their bodies which happened to be in contact, and that from the noise thus produced being in some way useful, the rough surfaces were gradually developed into regular stridulating organs. Some beetles, as they move, now produce, either intentionally or unintentionally, a shuffling noise, without possessing any proper organs for the purpose. Mr. Wallace informs me that the Euchirus longimanus, a lamellicorn with the anterior legs wonderfully elongated in the male, makes, whilst moving, a low hissing sound by the protrusion and contraction of the abdomen, and when seized it produces a grating sound by rubbing its hind legs against the edges of the elytra. The hissing sound is clearly due to a narrow rasp running along the sutural margin of each elytron, and I could likewise make the grating sound by rubbing the shagreened surface of the femur against the granulated margin of the corresponding elytron. But I could not here detect any proper rasp, nor is it likely that I could have overlooked it in so large an insect. After examining Cychrus, and reading what Westring has written about this beetle, it seems very doubtful whether it possesses any true rasp, though it has the power of emitting a sound. From the analogy of the Orthoptera and Homoptera, I expected to find the stridulating organs in the Coleoptera differing according to sex. But Landois, who has carefully examined several species, observed no such difference. Nor did Westring, nor did Mr. G.R. Crotch in preparing the many specimens which he had the kindness to send me. Any difference in these organs, if slight, would, however, be difficult to detect on account of their great variability. Thus, in the first pair of specimens of Necrophorus humator and of Pelobius which I examined, the rasp was considerably larger in the male than in the female, but not so with the succeeding specimens. In Geotrupes stercorarius the rasp appeared to me thicker, opaquer, and more prominent in 3 males than in the same number of females. In order, therefore, to discover whether the sexes differed in their power of stridulating, my son, Mr. F. Darwin, collected 57 living specimens, which he separated into 2 lots, according as they made a greater or lesser noise when held in the same manner. He then examined all these specimens, and found that the males were very nearly in the same proportion to the females in both the lots. Mr. F. Smith has kept alive numerous specimens of Mononychus pseudocori, Curculionidae, and is convinced that both sexes stridulate, and apparently in an equal degree. Nevertheless, the power of stridulating is certainly a sexual character in some few Coleoptera. Mr. Crotch discovered that the males alone of 2 species of Heliopathes, Tenebrionidae, possess stridulating organs. I examined 5 males of H. gibbus, and in all these there was a well-developed rasp, partially divided into 2, on the dorsal surface of the terminal abdominal segment, whilst in the same number of females there was not even a rudiment of the rasp, the membrane of this segment being transparent and much thinner than in the male. In H. cribratostriatus, the male has a similar rasp, excepting that it is not partially divided into 2 portions, and the female is completely destitute of this organ. The male, in addition, has on the apical margins of the elytra, on each side of the suture, 3 or 4 short longitudinal ridges, which are crossed by extremely fine ribs parallel to and resembling those on the abdominal rasp. Whether these ridges serve as an independent rasp, or as a scraper for the abdominal rasp, I could not decide. The female exhibits no trace of the latter structure. Again, in 3 species of the lamellicorn genus Oryctes, we have a nearly parallel case. In the females of O. gryphus and Nasocornus, the ribs on the rasp of the propygidium are less continuous and less distinct than in the males, but the chief difference is that the whole upper surface of this segment, when held in the proper light, is seen to be clothed with hairs, which are absent or represented by excessively fine down in the males. It should be noticed that in all Coleoptera the effective part of the rasp is destitute of hairs. In O. senegalensis the difference between the sexes is more strongly marked, and this is best seen when the proper abdominal segment is cleaned and viewed as a transparent object. In the female the whole surface is covered with little separate crests bearing spines, whilst in the male these crests, in proceeding toward the apex, become more and more confluent, regular, and naked, so that 3/4 of the segment is covered with extremely fine parallel ribs, which are quite absent in the female. In the females, however, of all 3 species of Oryctes, a slight grating or stridulating sound is produced when the abdomen of a softened specimen is pushed backward and forward. In the case of the Heliopathes and Oryctes, there can hardly be a doubt that the males stridulate in order to call or excite the females. But with most beetles the stridulation apparently serves both sexes as a mutual call. Beetles stridulate under various emotions in the same manner as birds use their voices for many purposes besides singing to their mates. The great Chiasognathus stridulates in anger or defiance. Many species do the same from distress or fear if held so that they cannot escape. By striking the hollow stems of trees in the Canary Islands, Messrs. Wollaston and Crotch were able to discover the presence of beetles belonging to the genus Acales by their stridulation. Lastly, the male Etuchus stridulates to encourage the female in her work, and from distress when she is removed. Some naturalists believe that beetles make this noise to frighten away their enemies, but I cannot think that a quadruped or bird able to devour a large beetle would be frightened by so slight a sound. The belief that the stridulation serves as a sexual call is supported by the fact that death ticks, Anobium tessellatum, are well known to answer each other's ticking, and, as I have myself observed, a tapping noise artificially made. Mr. Doubleday also informs me that he has sometimes observed a female ticking, and in an hour or two afterward has found her united with a male, and on one occasion surrounded by several males. According to Mr. Doubleday, the noise is produced by the insect raising itself on its legs as high as it can, and then striking its thorax 5 or 6 times in rapid succession against the substance upon which it is sitting. Olivier says that the female of Pimelia striata produces a rather loud sound by striking her abdomen against any hard substance, and that the male, obedient to this call, soon attends her, and they pair. Finally, it is probable that the two sexes of many kinds of beetles were at first enabled to find each other by the slight shuffling noise produced by the rubbing together of the adjoining hard parts of their bodies, and that as those males or females which made the greatest noise succeeded best in finding partners, rugosities on various parts of their bodies were gradually developed, by means of sexual selection, into true stridulating organs. End of section 9. Section 10 of The Descent of Man, Part 2. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Elsa Youngstead. The Descent of Man, Part 2, by Charles Darwin. Chapter 11, Insects Continued, Part 1. Order Lepidoptera, Butterflies and Moths. In this great order, the most interesting points for us are the differences in color between the sexes of the same species, and between the distinct species of the same genus. Nearly the whole of the following chapter will be devoted to this subject, but I will first make a few remarks on one or two other points. Several males may often be seen pursuing and crowding round the same female. Their courtship appears to be a prolonged affair, for I have frequently watched one or more males pirouetting round a female until I was tired, without seeing the end of the courtship. Mr. A. G. Butler also informs me that he has several times watched a male courting a female for a full quarter of an hour, but she pertinaciously refused him, and at last settled on the ground and closed her wings, so as to escape from his addresses. Although butterflies are weak and fragile creatures, they are pugnacious, and an emperor butterfly has been captured with the tips of its wings broken from a conflict with another male. Mr. Collingwood, in speaking of the frequent battles between the butterflies of Borneo, says they whirl round each other with the greatest rapidity, and appear to be incited by the greatest ferocity. The Agaronia feronia makes a noise like that produced by a toothed wheel passing under a spring catch, and which can be heard at the distance of several yards. I noticed this sound at Rio de Janeiro, only when two of these butterflies were chasing each other in an irregular course, so that it is probably made during the courtship of the sexes. See my Journal of Researches, 1845, page 33. Mr. Doubleday has detected a peculiar membranous sac at the base of the front wings, which is probably connected with the production of the sound. Some moths also produce sounds, for instance the males of Theocophora fovea. On 2 occasions Mr. F. Buchanan White heard a sharp quick noise made by the male of Hylophila prasinana, and which he believes to be produced, as in cicada, by an elastic membrane furnished with a muscle. He quotes also Guénet that Satina produces a sound like the ticking of a watch, apparently by the aid of two large tympaniform vesicles situated in the pectoral region, and these are much more developed in the male than in the female. Hence the sound-producing organs in the Lepidoptera appear to stand in some relation with the sexual functions. I have not alluded to the well-known noise made by the death's head sphinx, for it is generally heard soon after the moth has emerged from its cocoon. Giard has always observed that the musky odour, which is emitted by two species of sphinx moths, is peculiar to the males, and in the higher classes we shall meet with many instances of the males alone being odoriferous. Every one must have admired the extreme beauty of many butterflies and of some moths, and it may be asked, are their colours and diversified patterns the result of the direct action of the physical conditions to which these insects have been exposed, without any benefit thus derived? Or have successive variations been accumulated and determined as a protection, or for some unknown purpose, or that one sex may be attractive to the other? And again, what is the meaning of the colours being widely different in the males and females of certain species, and alike in the two sexes of other species of the same genus? Before attempting to answer these questions, a body of facts must be given. With our beautiful English butterflies, the admiral, peacock, and painted lady, Vanessae, as well as many others, the sexes are alike. This is also the case with the magnificent Heliconidae and most of the Danaidae in the tropics. But in certain other tropical groups, and in some of our English butterflies, as the purple emperor, orange tip, etc., Apatura iris, and Anthocharis cardominus, the sexes differ either greatly or slightly in colour. No language suffices to describe the splendor of the males of some tropical species. Even within the same genus we often find species presenting extraordinary differences between the sexes, whilst others have their sexes closely alike. Thus, in the South American genus Epicalia, Mr. Bates, to whom I am indebted for most of the following facts, and for looking over this whole discussion, informs me that he knows 12 species, the two sexes of which haunt the same stations, and this is not always the case with butterflies, and which therefore cannot have been differently affected by external conditions. In 9 of these 12 species, the males rank amongst the most brilliant of all butterflies, and differ so greatly from the comparatively plain females that they were formerly placed in distinct genera. The females of these 9 species resemble each other in their general type of coloration, and they likewise resemble both sexes of the species in several allied genera found in various parts of the world. Hence we may infer that these 9 species, and probably all the others of the genus, are descended from an ancestral form which was coloured in nearly the same manner. In the 10th species the female still retains the same general colouring, but the male resembles her, so that he is coloured in a much less gaudy and contrasted manner than the males of the previous species. In the 11th and 12th species the females depart from the usual type, for they are gaily coloured almost like the males, but in a somewhat less degree. Hence in these two latter species the bright colours of the males seem to have been transferred to the females, whilst in the 10th species the male has either retained or recovered the plain colours of the female, as well as of the parent form of the genus. The sexes in these 3 cases have thus been rendered nearly alike, though in an opposite manner. In the allied genus Eubagus both sexes of some of the species are plain-coloured and nearly alike, whilst the greater number of the males are decorated with beautiful metallic tints in a diversified manner, and differ much from their females. The females throughout the genus retain the same general style of colouring, so that they resemble one another much more closely than they resemble their own males. In the genus Papilio, all of the species of the Aeneas group are remarkable for their conspicuous and strongly contrasted colours, and they illustrate the frequent tendency to gradation in the amount of difference between the sexes. In a few species, for instance in Papilio ascanius, the males and females are alike. In others the males are either a little brighter or very much more superb than the females. The genus Junonia, allied to our Vanessae, offers a nearly parallel case, for although the sexes of most of the species resemble each other, and are destitute of rich colours, yet in certain species, as in Junonia oenon, the male is rather more bright-coloured than the female, and in a few, for instance Junonia andromiaja, the male is so different from the female that he might be mistaken for an entirely different species. Another striking case was pointed out to me in the British Museum by Mr. A. Butler, namely one of the tropical American theclae, in which both sexes are nearly alike and wonderfully splendid. In another species the male is coloured in a similarly gorgeous manner, whilst the whole upper surface of the female is of a dull uniform brown. Our common little English blue butterflies of the genus Lycaena illustrate the various differences in color between the sexes almost as well, though not in so striking a manner, as the above exotic genera. In Lycaena agestis both sexes have wings of a brown color, bordered with small ocellated orange spots, and are thus alike. In Lycaena aegon the wings of the males are of a fine blue, bordered with black, whilst those of the female are brown, with a similar border closely resembling the wings of Lycaena agestis. Lastly, in Lycaena aerion both sexes are of a blue color, and are very alike, though in the female the edges of the wings are rather duskier, with the black spots plainer. And in a bright blue Indian species both sexes are still more alike. I have given the foregoing details in order to show, in the first place, that when the sexes of butterflies differ, the male, as a general rule, is the more beautiful, and departs more from the usual type of colouring of the group to which the species belongs. Hence in most groups the females of the several species resemble each other much more closely than do the males. In some cases, however, to which I shall hereafter allude, the females are coloured more splendidly than the males. In the second place, these details have been given to bring clearly before the mind that within the same genus the two sexes frequently present every gradation from no difference in colour to so great a difference that it was long before the two were placed by entomologists in the same genus. In the third place, we have seen that when the sexes nearly resemble each other, this appears due either to the male having transferred his colours to the female, or to the male having retained, or perhaps recovered, the primordial colours of the group. It also deserves notice that in those groups in which the sexes differ, the females usually somewhat resemble the males, so that when the males are beautiful to an extraordinary degree, the females almost invariably exhibit some degree of beauty. From the many cases of gradation in the amount of difference between the sexes, and from the prevalence of the same general type of coloration throughout the whole of the same group, we may conclude that the causes have generally been the same which have determined the brilliant colouring of the males alone in some species, and of both sexes of other species. As so many gorgeous butterflies inhabit the tropics, it has often been supposed that they owe their colours to the great heat and moisture of these zones, but Mr. Bates has shown by the comparison of various closely allied groups of insects from the temperate and tropical regions that this view cannot be maintained, and the evidence becomes conclusive when brilliantly coloured males and plain-coloured females of the same species inhabit the same district, feed on the same food, and follow exactly the same habits of life. Even when the sexes resemble each other, we can hardly believe that their brilliant and beautifully arranged colours are the purposeless result of the nature of the tissues and of the action of the surrounding conditions. With animals of all kinds, whenever colour has been modified for some special purpose, this has been, as far as we can judge, either for direct or indirect protection, or as an attraction between the sexes. With many species of butterflies, the upper surfaces of the wings are obscure, and this, in all probability, leads to their escaping observation and danger. But butterflies would be particularly liable to be attacked by their enemies when at rest, and most kinds, whilst resting, raise their wings vertically over their backs, so that the lower surface alone is exposed to view. Hence it is this side which is often coloured so as to imitate the objects on which these insects commonly rest. Dr. Rossler, I believe, first noticed the similarity of the closed wings of certain vanessae and other butterflies to the bark of trees. Many analogous and striking facts could be given. The most interesting one is that recorded by Mr. Wallace of a common Indian and Sumatran butterfly, Kallima, which disappears like magic when it settles on a bush, for it hides its head and antennae between its closed wings, which in form, colour, and veining cannot be distinguished from a withered leaf with its footstalk. In some other cases the lower surfaces of the wings are brilliantly coloured, and yet are protective. Thus in Thecla rubi the wings, when closed, are of an emerald green, and resemble the young leaves of the bramble, on which in spring this butterfly may often be seen seated. It is also remarkable that in very many species in which the sexes differ greatly in colour on their upper surface, the lower surface is closely similar or identical in both sexes, and serves as a protection. Although the obscure tints both of the upper and undersides of many butterflies no doubt serve to conceal them, yet we cannot extend this view to the brilliant and conspicuous colours on the upper surface of such species as our admiral and peacock vanessae, our white cabbage butterflies, Pyrrhus, or the great swallowtail Papilio which haunts the open fens, for these butterflies are thus rendered visible to every living creature. In these species both sexes are alike, But in the common brimstone butterfly, Gonopteryx rhamni, the male is of an intense yellow, whilst the female is much paler, and in the orange tip, Anthocharis cardamines, the males alone have their wings tipped with bright orange. Both the males and females in these cases are conspicuous, and it is not credible that their difference in colour should stand in any relation to ordinary protection. Professor Weismann remarks that the female of one of the Lycaenae expands her brown wings when she settles on the ground, and is then almost invisible. The male, on the other hand, as if aware of the danger incurred from the bright blue of the upper surface of his wings, rests with them closed, and this shows that the blue colour cannot be in any way protective. Nevertheless, it is probable that conspicuous colours are indirectly beneficial to many species, as a warning that they are unpalatable. For in certain other cases beauty has been gained through the imitation of other beautiful species, which inhabit the same district and enjoy an immunity from attack by being in some way offensive to their enemies, but then we have to account for the beauty of the imitated species. As Mr. Walsh has remarked to me, the females of our orange-tip butterfly, above referred to, and of an American species, Anthocharis genutia, probably show us the primordial colours of the parent species of the genus. For both sexes of 4 or 5 widely distributed species are coloured in nearly the same manner. As in several previous cases, we may here infer that it is the males of Anthocharis cardamines and genutia which have departed from the usual type of the genus. In the Anthocharis cera from California, the orange tips to the wings have been partially developed in the female, but they are paler than in the male, and slightly different in some other respects. In an allied Indian form, the Iphias glaucipi, the orange tips are fully developed in both sexes. In this Iphias, as pointed out to me by Mr. A. Butler, the under surface of the wings marvellously resembles a pale-coloured leaf, and in our English orange tip the under surface resembles the flower head of the wild parsley on which the butterfly often rests at night. The same reason which compels us to believe that the lower surfaces have here been coloured for the sake of protection leads us to deny that the wings have been tipped with bright orange for the same purpose, especially when this character is confined to the males. Most moths rest motionless during the whole or greater part of the day with their wings depressed, and the whole upper surface is often shaded and coloured in an admirable manner, as Mr. Wallace has remarked, for escaping detection. The front wings of the Bombicidae and Noctuidae, when at rest, generally overlap and conceal the hind wings, so that the latter might be brightly coloured without much risk, and they are, in fact, often thus coloured. During flight, moths would often be able to escape from their enemies. Nevertheless, as the hind wings are then fully exposed to view, their bright colours must generally have been acquired at some little risk. But the following fact shows how cautious we ought to be in drawing conclusions on this head. The common yellow underwings, Tryphena, often fly about during the day or early evening, and are then conspicuous from the colour of their hind wings. It would naturally be thought that this would be a source of danger, but Mr. J. Jenner Weir believes that it actually serves them as a means of escape, for birds strike at these brightly coloured and fragile surfaces instead of at the body. For instance, Mr. Weir turned into his aviary a vigorous specimen of Tryphena pronuba, which was instantly pursued by a robin. But the bird's attention being caught by the coloured wings, the moth was not captured until after 50 attempts, and small portions of the wings were repeatedly broken off. He tried the same experiment in the open air with a swallow and Tryphena fimbria, but the large size of this moth probably interfered with its capture. We are thus reminded of a statement made by Mr. Wallace, namely, that in the Brazilian forests and Malayan islands, many common and highly decorated butterflies are weak flyers, though furnished with a broad expanse of wing, and they are often captured with pierced and broken wings, as if they had been seized by birds from which they had escaped. If the wings had been much smaller in proportion to the body, it seems probable that the insect would more frequently have been struck or pierced in a vital part, and thus the increased expanse of the wings may have been indirectly beneficial. Display. The bright colours of many butterflies and of some moths are specially arranged for display, so that they may be readily seen. During the night, colours are not visible, and there can be no doubt that the nocturnal moths, taken as a body, are much less gaily decorated than butterflies, all of which are diurnal in their habits. But the moths of certain families, such as the Zygaenidae, several Sphingidae, Uraniidae, some Arctiidae, and Saturniidae, fly about during the day or early evening, and many of these are extremely beautiful, being far brighter coloured than the strictly nocturnal kinds. A few exceptional cases, however, of bright-coloured nocturnal species have been recorded. There is evidence of another kind in regard to display. Butterflies, as before remarked, elevate their wings when at rest, but whilst basking in the sunshine often alternately raise and depress them, thus exposing both surfaces to full view. And although the lower surface is often coloured in an obscure manner as a protection, yet in many species it is as highly decorated as the upper surface, and sometimes in a very different manner. In some tropical species the lower surface is even more brilliantly coloured than the upper. In the English fritillaries, Argynnis, the lower surface alone is ornamented with shining silver. Nevertheless, as a general rule, the upper surface, which is probably more fully exposed, is coloured more brightly and diversely than the lower. Hence the lower surface generally affords to entomologists the more useful character for detecting the affinities of the various species. Fritz Müller informs me that 3 species of Cassia are found near his house in southern Brazil. Of 2 of them the hind wings are obscure, and are always covered by the front wings, when these butterflies are at rest. But the 3rd species has black hind wings, beautifully spotted with red and white, and these are fully expanded and displayed whenever the butterfly rests. Other such cases could be added. If we now turn to the enormous group of moths, which, as I hear from Mr. Stainton, do not habitually expose the under surfaces of their wings to full view, we find this side very rarely coloured with a brightness greater than or even equal to that of the upper side. Some exceptions to the rule, either real or apparent, must be noticed, as the case of Hypopyra. Mr. Trimen informs me that in Guéné's great work 3 moths are figured in which the under surface is much the more brilliant. For instance, in the Australian Gastrophora, the upper surface of the forewing is pale greyish ochreous, while the lower surface is magnificently ornamented by an ocellus of cobalt blue, placed in the midst of a black mark, surrounded by orange-yellow, and this by bluish-white. But the habits of these 3 moths are unknown, so that no explanation can be given of their unusual style of colouring. Mr. Trimen also informs me that the lower surface of the wings in certain other geometry and noctui are either more variegated or more brightly coloured than the upper surface. But some of these species have the habit of holding their wings quite erect over their backs, retaining them in this position for a considerable time, and thus exposing the under surface to view. Other species, when settled on the ground or herbage, now and then suddenly and slightly lift up their wings. Hence the lower surface of the wings, being brighter than the upper surface in certain moths, is not so anomalous as it at first appears. The Saturniidae include some of the most beautiful of all moths, their wings being decorated, as in our British emperor moth, with fine ocelli. And Mr. T. W. Wood observes that they resemble butterflies in some of their movements, for instance in the gentle waving up and down of the wings as if for display, which is more characteristic of diurnal than of nocturnal Lepidoptera. It is a singular fact that no British moths which are brilliantly coloured, and as far as I can discover hardly any foreign species, differ much in colour according to sex, though this is the case with many brilliant butterflies. The male, however, of one American moth, the Saturnia io, is described as having its forewings deep yellow, curiously marked with purplish-red spots, whilst the wings of the female are purple-brown, marked with grey lines. The British moths which differ sexually in colour are all brown, or of various dull yellow tints, or nearly white. In several species the males are much darker than the females, and these belong to groups which generally fly about during the afternoon. Footnote. For instance, I observe in my son's cabinet that the males are darker than the females in the Lasiocampa quercus, Odonestis potatoria, Hypogymna dispar, Dasychira pudibunda, and Cisnia mendica. In this latter species, the difference in colour between the 2 sexes is strongly marked, and Mr. Wallace informs me that we here have, as he believes, an instance of protective mimicry confined to one sex, as will hereafter be more fully explained. The white female of the Cisnia resembles the very common Spilosoma menthrasti, both sexes of which are white, and Mr. Stainton observes that this latter moth was rejected with utter disgust by a whole brood of young turkeys which were fond of eating other moths, so that if the Cisnia was commonly mistaken by British birds for the Spilosoma, it would escape being devoured, and its white deceptive colour would thus be highly beneficial. End footnote. On the other hand, in many genera, as Mr. Stainton informs me, the males have the hind wings whiter than those of the female, of which fact Agrotis exclamationis offers a good instance. In the ghost moth, Hepialus humili, the difference is more strongly marked, the males being white and the females yellow with darker markings. It is remarkable that in the Shetland Islands the male of this moth, instead of differing widely from the female, frequently resembles her closely in colour. Mr. G. Fraser suggests that at the season of the year when the ghost moth appears in these northern islands, the whiteness of the males would not be needed to render them visible to the females in the twilight night. It is probable that in these cases the males are thus rendered more conspicuous and more easily seen by the females whilst flying about in the dusk. From the several foregoing facts, it is impossible to admit that the brilliant colours of butterflies and of some few moths have commonly been acquired for the sake of protection. We have seen that their colours and elegant patterns are arranged and exhibited as if for display. Hence I am led to believe that the females prefer or are most excited by the more brilliant males. For on any other supposition the males would, as far as we can see, be ornamented to no purpose. We know that ants and certain lamellicorn beetles are capable of feeling an attachment for each other, and that ants recognize their fellows after an interval of several months. Hence there is no abstract improbability in the Lepidoptera, which probably stand nearly or quite as high in the scale as these insects, having sufficient mental capacity to admire bright colours. They certainly discover flowers by colour. The hummingbird sphinx may often be seen to swoop down from a distance on a bunch of flowers in the midst of green foliage, and I have been assured by 2 persons abroad that these moths repeatedly visit flowers painted on the walls of a room, and vainly endeavour to insert their proboscis into them. Fritz Müller informs me that several kinds of butterflies in South Brazil show an unmistakable preference for certain colours over others. He observed that they very often visited the brilliant red flowers of 5 or 6 genera of plants, but never the white or yellow flowering species of the same and other genera growing in the same garden, and I have received other accounts to the same effect. As I hear from Mr. Doubleday, the common white butterfly often flies down to a bit of paper on the ground, no doubt mistaking it for one of its own species. Mr. Collingwood, in speaking of the difficulty in collecting certain butterflies in the Malay archipelago, states that a dead specimen pinned upon a conspicuous twig will often arrest an insect of the same species in its headlong flight, and bring it down within easy reach of the net, especially if it be of the opposite sex. The courtship of butterflies is, as before remarked, a prolonged affair. The males sometimes fight together in rivalry, and many may be seen pursuing or crowding round the same female. Unless, then, the females prefer one male to another, the pairing must be left to mere chance, and this does not appear probable. If, on the other hand, the females habitually, or even occasionally, prefer the more beautiful males, the colours of the latter will have been rendered brighter by degrees, and will have been transmitted to both sexes or to one sex according to the law of inheritance which has prevailed. The process of sexual selection will have been much facilitated, if the conclusion can be trusted arrived at from various kinds of evidence in the supplement to the 9th chapter, namely, that the males of many Lepidoptera, at least in the imago state, greatly exceed the females in number. Some facts, however, are opposed to the belief that female butterflies prefer the more beautiful males. Thus, as I have been assured by several collectors, fresh females may frequently be seen paired with battered, faded, or dingy males. But this is a circumstance which could hardly fail often to follow from the males emerging from their cocoons earlier than the females. With the moths of the family Bombicidae, the sexes pair immediately after assuming the imago state, for they cannot feed owing to the rudimentary condition of their mouths. The females, as several entomologists have remarked to me, lie in an almost torpid state, and appear not to evince the least choice in regard to their partners. This is the case with the common silk moth, Bombyx mori, as I have been told by some continental and English breeders. Dr. Wallace, who has had great experience in breeding Bombyx cynthia, is convinced that the females evince no choice or preference. He has kept above 300 of these moths together, and has often found the most vigorous females mated with stunted males. The reverse appears to occur seldom, for as he believes the more vigorous males pass over the weakly females, and are attracted by those endowed with the most vitality. Nevertheless, the Bombicidae, though obscurely coloured, are often beautiful to our eyes from their elegant and mottled shades. End of section 10.
Section 11 of The Descent of Man, Part 2. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Matthew Reese. The Descent of Man, Part 2, by Charles Darwin. Chapter 12. Secondary Sexual Characters of Fishes, Amphibians, and Reptiles. Fishes. Courtship and battles of the males. Larger size of the females. Males, bright colors and ornamental appendages, other strange characters. Colors and appendages acquired by the males during the breeding season alone. Fishes with both sexes brilliantly colored. Protective colors. The less conspicuous colors of the female cannot be accounted for on the principle of protection. Male fishes building nests and taking charge of the ova and young. Amphibians. Differences in structure and color between the sexes. Vocal organs. Reptiles. Chelonians. Crocodiles. Snakes. Colors, in some cases protective. Lizards, battles of. Ornamental appendages. Strange differences in structure between the sexes. Colors. Sexual differences almost as great as with birds. We have now arrived at the great sub-kingdom of the vertebrata, and will commence with the lowest class, that of fishes. The males of plagiostomous fishes, sharks, rays, and of chimeroid fishes, are provided with claspers which serve to retain the female, like the various structures possessed by many of the lower animals. Besides the claspers, the males of many rays have clusters of strong sharp spines on their heads, and several rows along the upper outer surface of their pectoral fins. These are present in the males of some species which have other parts of their bodies smooth. They are only temporarily developed during the breeding season, and Dr. Gunther suspects that they are brought into action as prehensile organs, by the doubling inwards and downwards of the two sides of the body. It is a remarkable fact that the females and not the males of some species, as of Rhea clavata, have their backs studded with large hook-formed spines. The males alone of the capelin, Malotus villosus, one of the Salmonidae, are provided with a ridge of closely set, brush-like scales, by the aid of which two males, one on each side, hold the female, whilst she runs with great swiftness on the sandy beach, and there deposits her spawn. The widely distinct Monocanthus scopus presents a somewhat analogous structure. The male, as Dr. Gunther informs me, has a cluster of stiff, straight spines, like those of a comb, on the sides of the tail, and these in a specimen 6 inches long, where nearly 1½ inches in length. The female has in the same place a cluster of bristles, which may be compared with those of a toothbrush. In another species, M. peronii, the male has a brush like that possessed by the female of the last species, whilst the sides of the tail in the female are smooth. In some other species of the same genus, the tail can be perceived to be a little roughened in the male, and perfectly smooth in the female; and lastly, in others, both sexes have smooth sides. The males of many fish fight for the possession of the females. Thus the male stickleback, Gasterosteus leiurus, has been described as mad with delight when the female comes out of her hiding place and surveys the nest which he has made for her. He darts round her in every direction, then to his accumulated materials for the nest, then back again in an instant, and as she does not advance he endeavours to push her with his snout, and then tries to pull her by the tail and side spine to the nest. The males are said to be polygamists. They are extraordinarily bold and pugnacious, whilst the females are quite pacific. Their battles are at times desperate, for these puny combatants fasten tight on each other for several seconds, tumbling over and over again until their strength appears completely exhausted. With the rough-tailed stickleback, G. trachorus, the males whilst fighting swim round and round each other, biting and endeavouring to pierce each other with their raised lateral spines. The same writer adds, the bite of these little furies is very severe. They also use their lateral spines with such fatal effect that I have seen one during a battle absolutely rip his opponent quite open, so that he sank to the bottom and died. When a fish is conquered, his gallant bearing forsakes him, his gay colours fade away, and he hides his disgrace among his peaceable companions, but is for some time the constant object of his conqueror's persecution. The male salmon is as pugnacious as the little stickleback, and so is the male trout, as I hear from Dr. Gunther. Mr. Shaw saw a violent contest between two male salmon which lasted the whole day, and Mr. R. Buist, Superintendent of Fisheries, informs me that he has often watched from the bridge at Perth the males driving away their rivals, whilst the females were spawning. The males are constantly fighting and tearing each other on the spawning beds, and many so injure each other as to cause the death of numbers, many being seen swimming near the banks of the river in a state of exhaustion, and apparently in a dying state. Remarks that, like the stag, the male would, if he could, keep all other males away. Mr. Buist informs me that in June 1868 the keeper of the Stormontfield breeding ponds visited the northern Tyne and found about 300 dead salmon, all of which, with one exception, were males, and he was convinced that they had lost their lives by fighting. The most curious point about the male salmon is that, during the breeding season, besides a slight change in colour, the lower jaw elongates and a cartilaginous projection turns upward from the point, which, when the jaws are closed, occupies a deep cavity between the intermaxillary bones of the upper jaw. In our salmon, this change of structure lasts only during the breeding season, but in the Salmolycodon of Northwest America the change, as Mr. J. K. Lord believes, is permanent, and best marked in the older males which have previously ascended the rivers. In these old males the jaw becomes developed into an immense hook-like projection, and the teeth grow into regular fangs, often more than half an inch in length. With the European salmon, according to Mr. Lloyd, the temporary hook-like structure serves to strengthen and protect the jaws when one male charges another with wonderful violence, but the greatly developed teeth of the male American salmon may be compared with the tusks of many male mammals, as they indicate an offensive rather than a protective purpose. The salmon is not the only fish in which the teeth differ in the two sexes, as this is the case with many rays. In the thornback, Rhea clavata, the adult male has sharp pointed teeth directed backwards, whilst those of the female are broad and flat and form a pavement, so that these teeth differ in the two sexes of the same species more than is usual in distinct genera of the same family. The teeth of the male become sharp only when he is adult, whilst young they are broad and flat like those of the female. As so frequently occurs with secondary sexual characters, both sexes of the same species of rays, for instance R. batis, when adult, possess sharp-pointed teeth, and here a character, proper to and primarily gained by the male, appears to have been transmitted to the offspring of both sexes. The teeth are likewise pointed in both sexes of R. maculata, but only when quite adult, the males acquiring them at an earlier age than the females. We shall hereafter meet with analogous cases in certain birds, in which the male acquires the plumage common to both sexes when adult, at a somewhat earlier age than does the female. With other species of rays the males even when old never possess sharp teeth, and consequently the adults of both sexes are provided with broad, flat teeth like those of the young, and like those of the mature females of the above-mentioned species. As the rays are bold, strong, and voracious fish, we may suspect that the males require their sharp teeth for fighting with their rivals, but as they possess many parts modified and adapted for the prehension of the female, it is possible that their teeth may be used for this purpose. In regard to size, M. Carbonnier, as quoted in The Farmer, 1868, page 369, maintains that the female of almost all fishes is larger than the male, and Dr. Gunther does not know of a single instance in which the male is actually larger than the female. With some cyprinodonts, the male is not even half as large. As in many kinds of fishes, the males habitually fight together. It is surprising that they have not generally become larger and stronger than the females through the effects of sexual selection. The males suffer from their small size, for, according to M. Carbonnier, they are liable to be devoured by the females of their own species when carnivorous, and no doubt by other species. Increased size must be in some manner of more importance to the females than strength and size are to the males for fighting with other males, and this perhaps is to allow of the production of a vast number of ova. In many species the male alone is ornamented with bright colours, or these are much brighter in the male than the female. The male also is sometimes provided with appendages which appear to be of no more use to him for the ordinary purposes of life than are the tail feathers to the peacock. I am indebted for most of the following facts to the kindness of Dr. Gunther. There is reason to suspect that many tropical fishes differ sexually in colour and structure, and there are some striking cases with our British fishes. The male Callionymus lyra has been called the gemmeous dragonet, from its brilliant gem-like colours. When fresh caught from the sea the body is yellow of various shades, striped and spotted with vivid blue on the head. The dorsal fins are pale brown with dark longitudinal bands, the ventral, caudal, and anal fins being bluish-black. The female, or sordid dragonet, was considered by Linnaeus, and by many subsequent naturalists, as a distinct species. It is of a dingy reddish-brown, with the dorsal fin brown and the other fins white. The sexes differ also in the proportional size of the head and mouth, and in the position of the eyes, but the most striking difference is the extraordinary elongation in the male of the dorsal fin. Mr. W. Saville Kent remarks that this singular appendage appears from my observations of the species in confinement to be subservient to the same end as the wattles, crests, and other abnormal adjuncts of the male in gallinaceous birds, for the purpose of fascinating their mates. The young males resemble the adult females in structure and colour. Throughout the genus the male is generally much more brightly spotted than the female, and in several species not only the dorsal but the anal fin is much elongated in the males. The male of the Cottus scorpius, or sea scorpion, is slenderer and smaller than the female. There is also a great difference in colour between them. It is difficult, as Mr. Lloyd remarks, for anyone who has not seen this fish during the spawning season, when its hues are brightest, to conceive the admixture of brilliant colours with which it, in other respects so ill-favoured, is at that time adorned. Both sexes of the Labrus mixtus, although very different in colour, are beautiful, the male being orange with bright blue stripes, and the female bright red with some black spots on the back. In the very distinct family of the Cyprinodontidae, inhabitants of the fresh waters of foreign lands, the sexes sometimes differ much in various characters. In the male of the Malianesia petinensis, the dorsal fin is greatly developed and is marked with a row of large, round, ocellated, bright-coloured spots, whilst the same fin in the female is smaller, of a different shape, and marked only with irregularly curved brown spots. In the male, the basal margin of the anal fin is also a little produced and dark-coloured. In the male of an allied form, the Xiphophorus hellerii, the inferior margin of the caudal fin is developed into a long filament which, as I hear from Dr. Gunther, is striped with bright colours. This filament does not contain any muscles, and apparently cannot be of any direct use to the fish. As in the case of the Callionymus, the males whilst young resemble the adult females in colour and structure. Sexual differences such as these may be strictly compared with those which are so frequent with gallinaceous birds. In a coeluroid fish inhabiting the fresh waters of South America, the Plecostomus barbatus, the male has its mouth and interoperculum fringed with a beard of stiff hairs, of which the female shows hardly a trace. These hairs are of the nature of scales. In another species of the same genus, soft flexible tentacles project from the front part of the head of the male, which are absent in the female. These tentacles are prolongations of the true skin, and therefore are not homologous with the stiff hairs of the former species. But it can hardly be doubted that both serve the same purpose. What this purpose may be, it is difficult to conjecture. Ornament does not here seem probable, but we can hardly suppose that stiff hairs and flexible filaments can be useful in any ordinary way to the males alone. In that strange monster, the Chimera monstrosa, the male has a hook-shaped bone on the top of the head, directed forwards, with its end rounded and covered in sharp spines. In the female, this crown is altogether absent, but what its use may be to the male is utterly unknown. Many other cases could be added of structures peculiar to the male, of which their uses are not known. The structures as yet referred to are permanent in the male after he has arrived at maturity, but with some blennies and in another allied genus, a crest is developed on the head of the male only during the breeding season, and the body at the same time becomes more brightly coloured. There can be little doubt that this crest serves as a temporary sexual ornament, for the female does not exhibit a trace of it. In other species of the same genus both sexes possess a crest, and in at least one species neither sex is thus provided. In many of the Chromidae, for instance Geophagus and especially in Cichla, the males, as I hear from Professor Agassiz, have a conspicuous protuberance on the forehead, which is wholly wanting in the females and in the young males. Professor Agassiz adds, "I have often observed these fishes at the time of spawning when the protuberance is largest, and at other seasons when it is totally wanting, and the two sexes shew no difference whatever in the outline of the profile of the head. I never could ascertain that it subserves any special function, and the Indians on the Amazon know nothing about its use. These protuberances resemble, in their periodical appearance, the fleshy carbuncles on the heads of certain birds, but whether they serve as ornaments must remain at present doubtful." I hear from Professor Agassiz and Dr. Gunther that the males of those fishes which differ permanently in colour from the females often become more brilliant during the breeding season. This is likewise the case with a multitude of fishes, the sexes of which are identical in colour at all other seasons of the year. The tench, roach, and perch may be given as instances. The male salmon at this season is marked on the cheeks with orange-coloured stripes, which give it the appearance of a labrus, and the body partakes of a golden-orange tinge. The females are dark in colour, and are commonly called blackfish. An analogous and even greater change takes place with the salmo eriox or bull trout. The males of the char (S. umbla) are likewise at this season rather brighter in colour than the females. The colours of the pike (Esox reticulatus) of the United States, especially of the male, become, during the breeding season, exceedingly intense, brilliant, and iridescent. Another striking instance out of many is afforded by the male stickleback, Gasterosteus leiurus, which is described by Mr. Warrington as being then beautiful beyond description. The back and eyes of the female are simply brown and the belly white. The eyes of the male, on the other hand, are of the most splendid green, having a metallic lustre like the green feathers of some hummingbirds. The throat and belly are of a bright crimson, the back of an ashy green, and the whole fish appears as though it were somewhat translucent, and glowed with an internal incandescence. After the breeding season these colours all change, the throat and belly become of a paler red, the back more green, and the glowing tints subside. With respect to the courtship of fishes, other cases have been observed since the first edition of this book appeared, besides that already given of the stickleback. Mr. W.S. Kent says that the male of the Labrus mixtus, which, as we have seen, differs in colour from the female, makes a deep hollow in the sand of the tank, and then endeavours in the most persuasive manner to induce a female of the same species to share it with him, swimming backwards and forwards between her and the completed nest, and plainly exhibiting the greatest anxiety for her to follow. The males of Cantharus lineatus become, during the breeding season, of deep leaden black. They then retire from the shoal and excavate a hollow as a nest. Each male now mounts vigilant guard over his respective hollow, and vigorously attacks and drives away any other fish of the same sex. Towards his companions of the opposite sex his conduct is far different. Many of the latter are now distended with spawn, and these he endeavours by all the means in his power to lure singly to his prepared hollow, and there to deposit the myriad ova with which they are laden, which he then protects and guards with the greatest care. A more striking case of courtship, as well as of display, by the males of a Chinese Marcopus, has been given by M. Carbonnier, who carefully observed these fishes under confinement. The males are most beautifully coloured, more so than the females. During the breeding season they contend for the possession of the females, and, in the act of courtship, expand their fins, which are spotted and ornamented with brightly coloured rays, in the same manner, according to M. Carbonnier, as the peacock. They then also bound about the females with much vivacity, and appear by l'étalage de leur vive couleur chercher à attirer l'attention des femelles, lesquelles ne paraissant indifférentes à ces manèges, elles nagent avec une molle lenteur vers les males et semblant se complaire dans leur voisinage. After the male has won his bride, he makes a little disc of froth by blowing air and mucus out of his mouth. He then collects the fertilized ova, dropped by the female, in his mouth, and this caused M. Carbonnier much alarm, as he thought that they were going to be devoured. But the male soon deposits them in the disc of froth, afterwards guarding them, repairing the froth, and taking care of the young when hatched. I mention these particulars because, as we shall presently see, there are fishes, the males of which hatch their eggs in their mouths. and those who do not believe in the principle of gradual evolution might ask, how could such a habit have originated? But the difficulty is much diminished when we know that there are fishes which thus collect and carry the eggs; for if delayed by any cause in depositing them, the habit of hatching them in their mouths might have been acquired. To return to our more immediate subject, the case stands thus: female fishes, as far as I can learn, never willingly spawn except in the presence of the males, and the males never fertilise the ova except in the presence of the females. The males fight for the possession of the females. In many species, the males whilst young resemble the females in colour, but when adult become much more brilliant and retain their colours throughout life. In other species the males become brighter than the females and otherwise more highly ornamented only during the season of love. The males sedulously court the females, and in one case, as we have seen, take pains in displaying their beauty before them. Can it be believed that they would thus act to no purpose during their courtship? As this would be the case unless the females exert some choice and select those males which please or excite them most. If the female exerts such choice, all the above facts on the ornamentation of the males become at once intelligible by the aid of sexual selection. We have next to enquire whether this view of the bright colours of certain male fishes having been acquired through sexual selection can, through the law of the equal transmission of characters to both sexes, be extended to those groups in which the males and females are brilliant in the same or nearly the same degree and manner. In such a genus as Labrus, which includes some of the most splendid fishes in the world, for instance, the peacock Labrus, L. pavo, described with pardonable exaggeration as formed of polished scales of gold, encrusting lapis lazuli, rubies, sapphires, emeralds, and amethysts, we may with much probability accept this belief, for we have seen that the sexes in at least one species of the genus differ greatly in colour. With some fishes, as with many of the lowest animals, splendid colours may be the direct result of the nature of their tissues and of the surrounding conditions, without the aid of selection of any kind. The goldfish, Cyprinus auratus, judging from the analogy of the golden variety of the common carp, is perhaps a case in point, as it may owe its splendid colours to a single abrupt variation, due to the conditions to which this fish has been subjected under confinement. It is, however, more probable that these colours have been intensified through artificial selection, as this species has been carefully bred in China from a remote period. Owing to some remarks on this subject, made in my work on the variation of animals under domestication, Mr. W. F. Myers has searched the ancient Chinese encyclopedias. He finds that goldfish were first reared in confinement during the Sung dynasty, which commenced A.D. 960. In the year 1129 these fishes abounded. In another place it is said that since the year 1548 there has been produced at Hangchow a variety called the firefish, from its intensely red colour. It is universally admired, and there is not a household where it is not cultivated, in rivalry as to its colour, and as a source of profit. Under natural conditions it does not seem probable that beings so highly organised as fishes, and which live under such complex relations, should become brilliantly coloured without suffering some evil or receiving some benefit from so great a change, and consequently without the intervention of natural selection. What then are we to conclude in regard to the many fishes, both sexes of which are splendidly coloured? Mr. Wallace believes that the species which frequent reefs, where corals and other brightly coloured organisms abound, are brightly coloured in order to escape detection by their enemies; but, according to my recollection, they were thus rendered highly conspicuous. In the fresh waters of the tropics there are no brilliantly coloured corals or other organisms for the fishes to resemble, yet many species in the Amazons are brightly coloured, and many of the carnivorous Cyprinidae in India are ornamented with bright longitudinal lines of various tints. Mr. McClelland, in describing these fishes, goes so far as to suppose that the peculiar brilliancy of their colours serves as a better mark for kingfishers, terns, and other birds which are destined to keep the number of these fishes in check. But at the present day few naturalists will admit that any animal has been made conspicuous as an aid to its own destruction. It is possible that certain fishes may have been rendered conspicuous in order to warn birds and beasts of prey that they were unpalatable, as explained when treating of caterpillars; but it is not, I believe, known that any fish, at least any freshwater fish, is rejected from being distasteful to fish-devouring animals. On the whole, the most probable view in regard to the fishes, of which both sexes are brilliantly coloured, is that their colours were acquired by the males as a sexual ornament, and were transferred equally, or nearly so, to the other sex. We have now to consider whether, when the male differs in a marked manner from the female in colour or in other ornaments, he alone has been modified, the variations being inherited by his male offspring alone, or whether the female has been specially modified and rendered inconspicuous for the sake of protection, such modifications being inherited only by the females. It is impossible to doubt that colour has been gained by many fishes as a protection. No one can examine the speckled upper surface of a flounder and overlook its resemblance to the sandy bed of the sea on which it lives. Certain fishes, moreover, can through the action of the nervous system change their colours in adaptation to surrounding objects, and that within a short time. One of the most striking instances ever recorded of an animal being protected by its colour, as far as it can be judged of in preserved specimens, as well as by its form, is that given by Dr. Gunther of a pipefish, which, with its reddish streaming filaments, is hardly distinguishable from the seaweed to which it clings with its prehensile tail. But the question now under consideration is whether the females alone have been modified for this object. We can see that one sex will not be modified through natural selection for the sake of protection more than the other, supposing both to vary, unless one sex is exposed for a longer period to danger, or has less power of escaping from such danger than the other; and it does not appear that with fishes the sexes differ in these respects. As far as there is any difference, the males, from being generally smaller and from wandering more about, are exposed to greater danger than the females. And yet, when the sexes differ, the males are almost always the more conspicuously coloured. The ova are fertilised immediately after being deposited, and when this process lasts for several days, as in the case of the salmon, the female during the whole time is attended by the male. After the ova are fertilised they are, in most cases, left unprotected by both parents, so that the males and females, as far as oviposition is concerned, are equally exposed to danger, and both are equally important for the production of fertile ova. Consequently the more or less brightly coloured individuals of either sex would be equally liable to be destroyed or preserved, and both would have an equal influence on the colours of their offspring. Certain fishes belonging to several families make nests, and some of them take care of their young when hatched. Both sexes of the bright-coloured Crenulabrus massa and Melops work together in building their nests with seaweed, shells, etc. But the males of certain fishes do all the work, and afterwards take exclusive charge of the young. This is the case with the dull-coloured gobies, in which the sexes are not known to differ in colour, and likewise with the sticklebacks, Gasterosteus, in which the male becomes brilliantly coloured during the spawning season. The male of the smooth-tailed stickleback, G. leiurus, performs the duties of a nurse with exemplary care and vigilance during a long time, and is continually employed in gently leading back the young to the nest when they stray too far. He courageously drives away all enemies, including the females of his own species. It would indeed be no small relief to the male if the female, after depositing her eggs, were immediately devoured by some enemy, for he is forced incessantly to drive her from the nest. End of Section 11. Section 12 of The Descent of Man, Part 2. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Matthew Reese. The Descent of Man, Part 2, by Charles Darwin. Chapter 12. Secondary Sexual Characters of Fishes, Amphibians, and Reptiles. Part 2. The males of certain other fishes inhabiting South America and Ceylon, belonging to two distinct orders, have the extraordinary habit of hatching within their mouths or bronchial cavities the eggs laid by the females. I am informed by Professor Agassiz that the males of the Amazonian species which follow this habit not only are generally brighter than the females, but the difference is greater at the spawning season than at any other time. The species of Geophagus act in the same manner, and in this genus a conspicuous protuberance becomes developed on the forehead of the males during the breeding season. With the various species of chromids, as Professor Agassiz likewise informs me, sexual differences in colour may be observed, whether they lay their eggs in the water among aquatic plants, or deposit them in holes, leaving them to come out without further care, or build shallow nests in the river mud, over which they sit, as our Pomotis does. It ought also to be observed that these sitters are among the brightest species in their respective families. For instance, Hygrogonus is bright green with large black ocelli, encircled with the most brilliant red. Whether with all the species of chromids it is the male alone which sits on the eggs is not known. It is, however, manifest that the fact of the eggs being protected or unprotected by the parents has had little or no influence on the differences in colour between the sexes. It is further manifest in all the cases in which the males take exclusive charge of the nests and young, that the destruction of the brighter coloured males would be far more influential on the character of the race than the destruction of the brighter coloured females, for the death of the male during the period of incubation or nursing would entail the death of the young, so that they could not inherit his peculiarities. Yet in many of these very cases the males are more conspicuously coloured than the females. In most of the Lophobranchii, pipefish, hippocampi, etc., the males have either marsupial sacs or hemispherical depressions on the abdomen, in which the ova laid by the female are hatched. The males also shew great attachment to their young. The sexes do not commonly differ much in colour, but Dr. Gunther believes that the male hippocampi are rather brighter than the females. The genus Solenostoma, however, offers a curious exceptional case. Dr. Gunther, since publishing an account of this species, has re-examined the specimens and has given me the above information. For the female is much more vividly coloured and spotted than the male, and she alone has a marsupial sac and hatches the eggs, so that the female of Solenostoma differs from all the other Lophobranchii in this latter respect, and from almost all other fishes in being more brightly coloured than the male. It is improbable that this remarkable double inversion of character in the female should be an accidental coincidence. As the males of several fishes which take exclusive charge of the eggs and young are more brightly coloured than the females, and as here the female Solenostoma takes the same charge and is brighter than the male, it might be argued that the conspicuous colours of that sex which is the more important of the two for the welfare of the offspring must be in some manner protective. But from the large number of fishes of which the males are either permanently or periodically brighter than the females, but whose life is not at all more important for the welfare of the species than that of the female, this view can hardly be maintained. When we treat of birds we shall meet with analogous cases, where there has been a complete inversion of the usual attributes of the two sexes, and we shall then give what appears to be the probable explanation, namely, that the males have selected the more attractive females, instead of the latter having selected, in accordance with a usual rule throughout the animal kingdom, the more attractive males. On the whole we may conclude that with most fishes, in which the sexes differ in colour or in other ornamental characters, the males originally varied, with their variations transmitted to the same sex, and accumulated through sexual selection by attracting or exciting the females. In many cases, however, such characters have been transferred, either partially or completely, to the females. In other cases again, both sexes have been coloured alike for the sake of protection, but in no instance does it appear that the female alone has had her colours or other characters specially modified for this latter purpose. The last point which need be noticed is that fishes are known to make various noises, some of which are described as being musical. Dr. Dufossy, who has especially attended to this subject, says that the sounds are voluntarily produced in several ways by different fishes: by the friction of the pharyngeal bones, by the vibration of certain muscles attached to the swim bladder, which serves as a resounding board, and by the vibration of the intrinsic muscles of the swim bladder. By this latter means the trigla produces pure and long-drawn sounds which range over nearly an octave. But the most interesting case for us is that of two species of Ophidium, in which the males alone are provided with a sound-producing apparatus, consisting of small movable bones with proper muscles in connection with the swim bladder. The noise made by the umbrinas (Cyanna aquila) is said by some authors to be more like that of a flute or organ than drumming. Dr. Zouteveen gives some further particulars on the sounds made by fishes. The drumming of the umbrinas in the European seas is said to be audible from a depth of 20 fathoms, and the fishermen of Rochelle assert that the males alone make the noise during the spawning time, and that it is possible by imitating it to take them without bait. From this statement, and more especially from the case of Ophidium, it is almost certain that in this, the lowest class of the vertebrata, as with so many insects and spiders, sound-producing instruments have, at least in some cases, been developed through sexual selection, as a means for bringing the sexes together. Amphibians. Urodela. I will begin with the tailed amphibians. The sexes of salamanders or newts often differ much, both in colour and structure. In some species, prehensile claws are developed on the forelegs of the males during breeding season; and at this season, in the male Triton palmipes, the hind feet are provided with a swimming web, which is almost completely absorbed during the winter, so that their feet then resemble those of the female. This structure no doubt aids the male in his eager search and pursuit of the female. Whilst courting her he rapidly vibrates the end of his tail. With our common newts, Triton punctatus and cristatus, a deep, much indented crest is developed along the back and tail of the male during the breeding season, which disappears during the winter. Mr. St. George Mivart informs me that it is not furnished with muscles, and therefore cannot be used for locomotion. As during the season of courtship it becomes edged with bright colours, there can hardly be a doubt that it is a masculine ornament. In many species the body presents strongly contrasted, though lurid tints, and these become more vivid during the breeding season. The male, for instance, of our common little newt, Triton punctatus, is brownish grey above, passing into yellow beneath, which in the spring becomes a rich bright orange, marked everywhere with round dark spots. The edge of the crest also is then tipped with bright red or violet. The female is usually of a yellowish brown colour with scattered brown dots, and the lower surface is often quite plain. The young are obscurely tinted. The ova are fertilised during the act of deposition, and are not subsequently tended by either parent. We may therefore conclude that the males have acquired their strongly marked colours and ornamental appendages through sexual selection, these being transmitted either to the male offspring alone or to both sexes. Anura or Batrachia. With many frogs and toads the colours evidently serve as a protection, such as the bright green tints of tree frogs and the obscure mottled shades of many terrestrial species. The most conspicuously coloured toad which I ever saw, the Phryniscus nigricans, had the whole upper surface of the body as black as ink, with the soles of the feet and parts of the abdomen spotted with the brightest vermilion. It crawled about the bare sandy or open grassy plains of La Plata under a scorching sun, and could not fail to catch the eye of every passing creature. These colours are probably beneficial by making this animal known to all birds of prey as a nauseous mouthful. In Nicaragua there is a little frog dressed in a bright livery of red and blue, which does not conceal itself like most other species, but hops about during the daytime, and Mr. Belt says that as soon as he saw its happy sense of security, he felt sure that it was uneatable. After several trials he succeeded in tempting a young duck to snatch up a young one, but it was instantly rejected, and the duck went about jerking its head as if trying to throw off some unpleasant taste. With respect to sexual differences of colour, Dr. Gunther does not know of any striking instance either with frogs or toads, yet he can often distinguish the male from the female by the tints of the former being a little more intense. Nor does he know of any striking difference in external structure between the sexes, excepting the prominences which become developed during the breeding season on the front legs of the male, by which he is enabled to hold the female. The male alone of the Bufo sycamensis has two plate-like callosities on the thorax and certain rugosities on the fingers, which perhaps subserve the same end as the above-mentioned prominences. It is surprising that these animals have not acquired more strongly marked sexual characters, for though cold-blooded, their passions are strong. Dr. Gunther informs me that he has several times found an unfortunate female toad dead and smothered from having been so closely embraced by 3 or 4 males. Frogs have been observed by Professor Hoffmann in Gießen fighting all day long during the breeding season, and with so much violence that one had its body ripped open. Frogs and toads offer one interesting sexual difference, namely in the musical powers possessed by the males; but to speak of music, when applied to the discordant and overwhelming sounds emitted by male bullfrogs and some other species, seems, according to our taste, a singularly inappropriate expression. Nevertheless, certain frogs sing in a decidedly pleasing manner. Near Rio Janeiro I used often to sit in the evening to listen to a number of little hylae, perched on blades of grass close to the water, which sent forth sweet chirping notes in harmony. The various sounds are emitted chiefly by the males during the breeding season, as in the case of the croaking of our common frog. In accordance with this fact, the vocal organs of the males are more highly developed than those of the females. In some genera, the males alone are provided with sacs which open into the larynx. For instance, in the edible frog, Rana esculenta, The sacs are peculiar to the males, and become, when filled with air in the act of croaking, large globular bladders, standing out one on each side of the head, near the corners of the mouth. The croak of the male is thus rendered exceedingly powerful, whilst that of the female is only a slight groaning noise. In the several genera of the family, the vocal organs differ considerably in structure, and their development in all cases may be attributed to sexual selection. Reptiles. Chelonia. Tortoises and turtles do not offer well-marked sexual differences. In some species the tail of the male is longer than that of the female. In some the plastron, or lower surface of the shell, of the male is slightly concave in relation to the back of the female. The male of the mud turtle of the United States, Chrysemys picta, has claws on its front feet twice as long as those of the female, and these are used when the sexes unite. With the huge tortoise of the Galapagos Islands, Testudo nigra, the males are said to grow a larger size than the females. During the pairing season, and at no other time, the male utters a hoarse bellowing noise which can be heard at the distance of more than 100 yards. The female, on the other hand, never uses her voice. With the Testudo elegans of India, it is said that the combats of the males may be heard at some distance, from the noise they produce in butting against each other. Crocodilia. The sexes apparently do not differ in colour, nor do I know that the males fight together, though this is probable, for some kinds make a prodigious display before the females. Bartram describes the male alligator as striving to win the female by splashing and roaring in the midst of a lagoon. Swollen to an extent ready to burst, with its head and tail lifted up, he springs or twirls round on the surface of the water, like an Indian chief rehearsing his feats of war. During the season of love, a musky odour is emitted by the submaxillary glands of the crocodile, and pervades their haunts. Ophidia. Dr. Gunther informs me that the males are always smaller than the females, and generally have longer and slenderer tails, but he knows of no other difference in external structure. In regard to colour, he can almost always distinguish the male from the female by his more strongly pronounced tints. Thus the black zigzag band on the back of the male English viper is more distinctly defined than in the female. The difference is much plainer in the rattlesnakes of North America, the male of which, as the keeper in the Zoological Gardens shewed me, can at once be distinguished from the female by having more lurid yellow about its whole body. In South Africa, the Bucephalus capensis presents an analogous difference, for the female is never so fully variegated with yellow on the sides as the male. The male of the Indian Dipsas cynodon, on the other hand, is blackish-brown with the belly partly black, whilst the female is reddish or yellowish-olive, with the belly either uniform yellowish or marbled with black. In the Tragops dispar of the same country, the male is bright green and the female bronze-coloured. No doubt the colours of some snakes are protective, as shewn by the green tints of tree snakes, and the various mottled shades of the species which live in sandy places, but it is doubtful whether the colours of many kinds, for instance the common English snake and viper, serve to conceal them, and this is still more doubtful with the many foreign species which are coloured with extreme elegance. The colours of certain species are very different in the adult and young states. During the breeding season the anal scent glands of snakes are in active function, and so it is with the same glands in lizards, and, as we have seen, with the submaxillary glands of crocodiles. As the males of most animals search for the females, these odoriferous glands probably serve to excite or charm the female, rather than to guide her to the spot where the male may be found. Male snakes, though appearing so sluggish, are amorous, for they have been observed crowding round the same female, and even round her dead body. They are not known to fight together from rivalry. Their intellectual powers are higher than might have been anticipated. In the Zoological Gardens they soon learn not to strike at the iron bar with which their cages are cleaned, and Dr. Keene of Philadelphia informs me that some snakes which he kept learned after 4 or 5 times to avoid a noose, with which they were at first easily caught. An excellent observer in Ceylon, Mr. E. Layard, saw a cobra thrust its head through a narrow hole and swallow a toad. With this encumbrance he could not withdraw himself. Finding this, he reluctantly disgorged the precious morsel, which began to move off. This was too much for snake philosophy to bear, and the toad was again seized, and again was the snake, after violent efforts to escape, compelled to part with its prey. This time, however, a lesson had been learnt, and the toad was seized by one leg, withdrawn, and then swallowed in triumph. The keeper in the zoological gardens is positive that certain snakes, for instance Crotalus and Python, distinguish him from all other persons. Cobras kept together in the same cage apparently feel some attachment towards each other. It does not, however, follow, because snakes have some reasoning power, strong passions, and mutual affection, that they should likewise be endowed with sufficient taste to admire brilliant colours in their partners, so as to lead to the adornment of the species through sexual selection. Nevertheless, it is difficult to account in any other manner for the extreme beauty of certain species, for instance, of the coral snakes of South America, which are of a rich red with black and yellow transverse bands. I well remember how much surprise I felt at the beauty of the first coral snake which I saw gliding across a path in Brazil. Snakes coloured in this peculiar manner, as Mr. Wallace states on the authority of Dr. Gunther, are found nowhere else in the world except in South America, and here no less than 4 genera occur. One of these, Elaps, is venomous, a second and widely distinct genus is doubtfully venomous, and the 2 others are quite harmless. The species belonging to these distinct genera inhabit the same districts, and are so like each other that no one but a naturalist would distinguish the harmless from the poisonous kinds. Hence, as Mr. Wallace believes, the innocuous kinds have probably acquired their colours as protection, on the principle of imitation, for they would naturally be thought dangerous by their enemies. The cause, however, of the bright colours of the venomous Elaps remains to be explained, and this may perhaps be sexual selection. Snakes produce other sounds besides hissing. The deadly Echis carinata has on its sides some oblique rows of scales of a peculiar structure with serrated edges, and when the snake is excited these scales are rubbed against each other, which produces a curious, prolonged, almost hissing sound. With respect to the rattling of the rattlesnake, we have at last some definite information, for Professor Augie states that on 2 occasions, being himself unseen, he watched from a little distance a rattlesnake coiled up with the head erect, which continued to rattle at short intervals for half an hour. And at last he saw another snake approach, and when they met they paired. Hence he is satisfied that one of the uses of the rattle is to bring the sexes together. Unfortunately, he did not ascertain whether it was the male or the female which remained stationary and called for the other. But it by no means follows from the above fact that the rattle may not be of use to these snakes in other ways, as a warning to animals which would otherwise attack them. Nor can I quite disbelieve the several accounts which have appeared of their thus paralyzing their prey with fear. Some other snakes also make a distinct noise by rapidly vibrating their tails against the surrounding stalks of plants, and I have myself heard this in the case of a Trigonocephalus in South America. Lacertilia. The males of some, probably of many kinds of lizards, fight together from rivalry. Thus the arboreal Anolis cristatellus of South America is extremely pugnacious. During the spring and early part of the summer 2 adult males rarely meet without a contest. On first seeing one another, they nod their heads up and down 3 or 4 times, and at the same time expanding the frill or pouch beneath the throat. Their eyes glisten with rage, and after waving their tails from side to side for a few seconds, as if to gather energy, they dart at each other furiously, rolling over and over, and holding firmly with their teeth. The conflict generally ends in one of the combatants losing his tail, which is often devoured by the victor. The male of this species is considerably larger than the female. Mr. N.L. Austin kept these animals alive for a considerable time. And this, as far as Dr. Gunther has been able to ascertain, is the general rule with lizards of all kinds. The male alone of the Certodactylus rubidus of the Andaman Islands possesses pre-anal pores, and these pores, judging from analogy, probably serve to emit an odor. The sexes often differ greatly in external characters. The male of the above-mentioned Anolis is furnished with a crest which runs along the back and tail, and can be erected at pleasure, but of this crest the female does not exhibit a trace. In the Indian Cophotis ceylanica, the female has a dorsal crest, though much less developed than in the male, and so it is, as Dr. Gunther informs me, with the females of many iguanas, chameleons, and other lizards. In some species, however, the crest is equally developed in both sexes, as in the Iguana tuberculata. In the genus Sitana, the males alone are furnished with a large throat pouch, which can be folded up like a fan, and is coloured blue, black, and red. But these splendid colours are exhibited only during the pairing season. The female does not possess even a rudiment of this appendage. In the Anolis cristatellus, according to Mr. Austin, the throat pouch, which is bright red marbled with yellow, is present in the female, though in a rudimental condition. Again, in certain other lizards, both sexes are equally well provided with throat pouches. Here we see, with species belonging to the same group, as in so many previous cases, the same character either confined to the males, or more largely developed in them than in the females, or again equally developed in both sexes. The little lizards of the genus Draco, which glide through the air on their rib-supported parachutes, and which in the beauty of their colours baffle description, are furnished with skinny appendages to the throat like the wattles of the gallinaceous birds. These become erected when the animal is excited. They occur in both sexes, but are best developed when the male arrives at maturity, at which age the middle appendage is sometimes twice as long as the head. Most of the species likewise have a low crest running along the neck, and this is much more developed in the full-grown males than in the females or young males. All the foregoing statements and quotations in regard to Cophotis, Sitana, and Draco, as well as the following facts in regard to Ceratophora and Chameleon, are from Dr. Gunther himself, or from his magnificent work on the reptiles of British India. A Chinese species is said to live in pairs during the spring, and if one is caught, the other falls from the tree to the ground, and allows itself to be captured with impunity. I presume from despair. There are other and much more remarkable differences between the sexes of certain lizards. The male of Ceratophora aspera bears on the extremity of his snout an appendage half as long as the head. It is cylindrical, covered with scales, flexible, and apparently capable of erection. In the female it is quite rudimental. In a second species of the same genus a terminal scale forms a minute horn on the summit of the flexible appendage, and in a third species the whole appendage is converted into a horn, which is usually of a white colour, but assumes a purplish tint when the animal is excited. In the adult male of this latter species the horn is half an inch in length, but it is of quite minute size in the female and in the young. These appendages, as Dr. Gunther has remarked to me, may be compared with the combs of gallinaceous birds, and apparently serve as ornaments. In the genus of Chameleon, we come to the acme of difference between the sexes. The upper part of the skull of the male C. bifurcus, an inhabitant of Madagascar, is produced into two great, solid, bony projections, covered with scales like the rest of the head, and of this wonderful modification of structure the female exhibits only a rudiment. Again, in Cameleo owenii, from the west coast of Africa, the male bears on his snout and forehead three curious horns, of which the female has not a trace. These horns consist of an excrescence of bones covered with a smooth sheath, forming part of the general integuments of the body, so that they are identical in structure with those of a bull, goat, or other sheath-horned ruminant. Although the three horns differ so much in appearance from the two great prolongations of the skull in C. bifurcus, we can hardly doubt that they serve the same general purpose in the economy of these two animals. The first conjecture, which will occur to everyone, is that they are used by the males for fighting together, and as these animals are very quarrelsome, this is probably a correct view. Mr. T.W. Wood also informs me that he once watched two individuals of C. pumilus fighting violently on the branch of a tree. They flung their heads about and tried to bite each other. Then they rested for a time, and afterwards continued their battle. With many lizards the sexes differ slightly in colour, the tints and stripes of the males being brighter and more distinctly defined than in the females. This, for instance, is the case with the above Cophotis, and with the Acanthodactylus capensis of South Africa. In a Cordalis of the latter country, the male is either much redder or greener than the female. In the Indian Calotis nigrillabris there is a still greater difference. The lips also of the male are black, whilst those of the female are green. In our common little viviparous lizard, the underside of the body and base of the tail in the male are bright orange spotted with black. In the female these parts are pale grayish-green without spots. We have seen that the males alone of Sitana possess a throat pouch, and this is splendidly tinted with blue, black, and red. In the Proctotris tenuis of Chile, the male alone is marked with spots of blue, green, and coppery red. In many cases the males retain the same colours throughout the year, but in others they become much brighter during the breeding season. I may give as an additional instance the Calotis maria, which at this season has a bright red head, the rest of the body being green. Both sexes of many species are beautifully coloured exactly alike, and there is no reason to suppose that such colours are protective. No doubt with the bright green kinds which live in the midst of vegetation this colour serves to conceal them, and in North Patagonia I saw a lizard which, when frightened, flattened its body, closed its eyes, and then from its mottled tints was hardly distinguishable from the surrounding sand. But the bright colors with which so many lizards are ornamented, as well as their various curious appendages, were probably acquired by the males as an attraction, and then transmitted either to their male offspring alone, or to both sexes. Sexual selection, indeed, seems to have played almost as important a part with reptiles as with birds, and the less conspicuous colors of the females in comparison with the males cannot be accounted for, as Mr. Wallace believes to be the case with birds, by the greater exposure of the females to danger during incubation. End of section 12.
Section 13 of The Descent of Man, Part 2. This is a LibriVox recording. All the LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Descent of Man, Part 2, by Charles Darwin. Chapter 13. Secondary Sexual Characters of Birds, Part 1. Sexual Differences, Law of Battle, Special Weapons, Vocal Organs, Instrumental Music, Love Antics and Dances, Decorations permanent and seasonal, Double and single annual molds, Display of ornaments by the males. Secondary sexual characters are more diversified and conspicuous in birds, though not perhaps entailing more important changes of structure than in any other class of animals. I shall therefore treat the subject at considerable length. Male birds sometimes, though rarely, possess special weapons for fighting with each other. They charm the female by vocal or instrumental music of the most varied kinds. They are ornamented by all sorts of combs, wattles, protuberances, horns, air-distended sacs, top-knots, naked shafts, plumes, and lengthened feathers gracefully springing from all parts of the body. The beak and naked skin about the head, and the feathers, are often gorgeously coloured. The males sometimes pay their court by dancing, or by fantastic antics, performed either on the ground or in the air. In one instance at least, the male emits a musky odour, which we may suppose serves to charm or excite the female. For that excellent observer, Mr. Ramsay, says of the Australian musk duck Biziura lobata, that the smell which the male emits during the summer months is confined to that sex, and in some individuals is retained throughout the year. I have never, even in the breeding season, shot a female which had any smell of musk. So powerful is this odour during the pairing season, that it can be detected long before the bird can be seen. On the whole, birds appear to be the most aesthetic of all animals, excepting of course man, and they have nearly the same taste for the beautiful as we have. This is shown by our enjoyment of the singing of birds, and by our women, both civilized and savage, decking their heads with borrowed plumes, and using gems which are hardly more brilliantly coloured than the naked skin and wattles of certain birds. In man, however, when cultivated, the sense of beauty is manifestly a far more complex feeling, and is associated with various intellectual ideas. Before treating of the sexual characters with which we are here more particularly concerned, I may just allude to certain differences between the sexes, which apparently depend on differences in their habits of life. For such cases, though common in the lower, are rare in the higher classes. Two humming-birds belonging to the genus Eustephanus, which inhabit the island of Juan Fernandez, were long thought to be specifically distinct, but are now known, as Mr. Gould informs me, to be the male and female of the same species, and they differ slightly in the form of the beak. In another genus of humming-birds, Grypus, The beak of the male is serrated along the margin and hooked at the extremity, thus differing much from that of the female. In the neomorpha of New Zealand there is, as we have seen, a still wider difference in the form of the beak in relation to the manner of feeding of the two sexes. Something of the same kind has been observed with the goldfinch (Carduelis elegans), for I am assured by Mr. J. Jenner Weir that the bird-catchers can distinguish the males by their slightly longer beaks. The flocks of males are often found feeding on the seeds of the teasel (Dipsacus), which they can reach with their elongated beaks, whilst the females more commonly feed on the seeds of the Bethany or Scrofularia. With a slight difference of this kind as a foundation, we can see how the beaks of the two sexes might be made to differ greatly through natural selection. In some of the above cases, however, it is possible that the beaks of the males may have been first modified in relation to their contests with other males, and that this afterwards led to slightly changed habits of life. Law of battle. Almost all male birds are extremely pugnacious, using their beaks, wings, and legs for fighting together. We see this every spring with our robins and sparrows. The smallest of all birds, namely the humming-bird, is one of the most quarrelsome. Mr. Gasser describes a battle in which a pair seized hold of each other's beaks, and whirled round and round till they almost fell to the ground; and M. Montes de Oca, in speaking of another genus of humming-bird, says that two males rarely meet without a fierce aerial encounter. When kept in cages, their fighting has mostly ended in the splitting of the tongue of one of the two, which then surely dies from being unable to feed. With waders, the males of the common water-hen Gallinula chloropus, when pairing, fight violently for the females. They stand nearly upright in the water and strike with their feet. Two were seen to be thus engaged for half an hour, until one got hold of the head of the other, which would have been killed, had not the observer interfered, the female all the time looking on as a quiet spectator. Mr. Blyth informs me that the males of an allied bird, Gallicrex cristatus, are a third larger than the females, and are so pugnacious during the breeding season, that they are kept by the natives of Eastern Bengal for the sake of fighting. Various other birds are kept in India for the same purpose, for instance the bulbuls Pycnonotus haemoraus, which fight with great spirit. The polygamous ruff Machetes pugnus is notorious for his extreme pugnacity; and in the spring the males, which are considerably larger than the females, congregate day after day at a particular spot, where the females propose to lay their eggs. The fowlers discover these spots by the turf being trampled somewhat bare. Here they fight very much like gamecocks, seizing each other with their beaks and striking with their wings. The great ruff of feathers round the neck is then erected, and, according to Colonel Montagu, sweeps the ground as a shield to defend the more tender parts, and this is the only instance known to me in the case of birds of any structure serving as a shield. The ruff of feathers, however, from its varied and rich colours, probably serves in chief part as an ornament. Like most pugnacious birds, they seem always ready to fight, and when closely confined often kill each other. But Montagu observed that their pugnacity becomes greater during the spring, when the long feathers on their necks are fully developed, and at this period the least movement by any one bird provokes a general battle. Of the pugnacity of web-footed birds 2 instances will suffice. In Guyana, bloody fights occur during the breeding season between the males of the wild musk duck Cairina moschata, and where these fights have occurred, the river is covered for some distance with feathers. Birds which seem ill adapted for fighting engage in fierce conflicts. Thus the stronger males of the pelican drive away the weaker ones, snapping with their huge beaks and giving heavy blows with their wings. Male snipe fight together, tugging and pushing each other with their bills in the most curious manner imaginable. Some few birds are believed never to fight. This is the case, according to Audubon, with one of the woodpeckers of the United States, Picosauratus, although the hens are followed by even half a dozen of their gay suitors. The males of many birds are larger than the females, and this no doubt is the result of the advantage gained by the larger and stronger males over their rivals during many generations. The difference in size between the two sexes is carried to an extreme point in several Australian species. Thus the male musk duck Bisura and the male Cincloramphus crusalis, allied to our pipits, are by measurement actually twice as large as their respective females. With many other birds the females are larger than the males, and, as formerly remarked, the explanation often given, namely, that the females have most of the work in feeding their young, will not suffice. In some few cases, as we shall hereafter see, the females apparently have acquired their greater size and strength for the sake of conquering other females and obtaining possession of the males. The males of many gallinaceous birds, especially of the polygamous kinds, are furnished with special weapons for fighting with their rivals, namely spurs, which can be used with fearful effect. It has been recorded by a trustworthy writer that in Derbyshire a kite struck at a game hen, accompanied by her chickens, when the cock rushed to the rescue, and drove his spur right through the eye and skull of the aggressor. The spur was with difficulty drawn from the skull, and as the kite, though dead, retained his grasp, the two birds were firmly locked together. But the cock, when disentangled, was very little injured. The invincible courage of the game-cock is notorious. A gentleman, who long ago witnessed the brutal scene, told me that a bird had both its legs broken by some accident in the cockpit, and the owner laid a wager that if the legs could be spliced so that the bird could stand upright, he would continue fighting. This was effected on the spot, and the bird fought with undaunted courage until he received his death stroke. In Ceylon a closely allied wild species, the Gallus stanleyi, is known to fight desperately in defence of his seraglio, so that one of the combatants is frequently found dead. An Indian partridge, or Tigornis gularis, the male of which is furnished with strong and sharp spurs, is so quarrelsome that the scars of former fights disfigure the breast of almost every bird you kill. The males of almost all gallinaceous birds, even those which are not furnished with spurs, engage during the breeding season in fierce conflicts. The capercailzie and black-cock, Tetrao urogallus and Tetrao tetrix, which are both polygamists, have regular appointed places where during many weeks they congregate in numbers to fight together and to display their charms before the females. Dr. W. Kovalevsky informs me that in Russia he has seen the snow all bloody on the arenas where the capercailzie have fought, and the black cocks make the feathers fly in every direction when several engage in a battle royal. The elder Brehm gives a curious account of the balz, as the love dances and love songs of the black cock are called in Germany. The bird utters almost continuously the strangest noises. He holds his tail up and spreads it out like a fan. He lifts up his head and neck with all the feathers erect, and stretches his wings from the body. Then he takes a few jumps in different directions, sometimes in a circle, and presses the under part of his beak so hard against the ground that the chin feathers are rubbed off. During these movements he beats his wings and turns round and round. The more ardent he grows, the more lively he becomes, until at last the bird appears like a frantic creature. At such times the black-cocks are so absorbed that they become almost blind and deaf, but less so than the capercailzie. Hence bird after bird may be shot on the same spot, or even caught by the hand. After performing these antics the males begin to fight, and the same black-cock, in order to prove his strength over several antagonists, will visit in the course of one morning several Balz places, which remain the same during successive years. The peacock, with his long train, appears more like a dandy than a warrior, but he sometimes engages in fierce contests. The Rev. W. Darwin Fox informs me that at some little distance from Chester 2 peacocks became so excited whilst fighting, that they flew over the whole city still engaged, until they alighted on the top of St. John's Tower. The spur in those gallinaceous birds which are thus provided is generally single, but Polyplectron has 2 or more on each leg, and one of the blood pheasants, Ithagenis cruentus, has been seen with 5 spurs. The spurs are generally confined to the male, being represented by mere knobs or rudiments in the female; but the females of the Java peacock, Pava muticus, and, as I am informed by Mr. Blyth, of the small fire-backed pheasant Euplacamus erythrophthalmus, possess spurs. In Galliprodyx it is usual for the male to have 2 spurs, and for the females to have only 1 on each leg. Hence spurs may be considered as a masculine structure, which has been occasionally more or less transferred to the females. Like most other secondary sexual characters, the spurs are highly variable both in number and development in the same species. Various birds have spurs on their wings, but the Egyptian goose, Caenolopex aegyptiacus, has only bare obtuse knobs, and these probably show us the first steps by which true spurs have been developed in other species. In the spur-winged goose Plectopterus gambensis, the males have much larger spurs than the females, and they use them, as I am informed by Mr. Bartlett, in fighting together, so that in this case the wing spurs serve as sexual weapons; but according to Livingstone they are chiefly used in the defence of the young. The Palamedia is armed with a pair of spurs on each wing, and these are such formidable weapons that a single blow has been known to drive a dog howling away. But it does not appear that the spurs in this case, or in that of some of the spur-winged rails, are larger in the male than in the female. In certain plovers, however, the wing spurs must be considered as a sexual character. Thus in the male of our common peewit, Vanellus cristatus, the tubercle on the shoulder of the wing becomes more prominent during the breeding season, and the males fight together. In some species of Lobi vanellus a similar tubercle becomes developed during the breeding season into a short horny spur. In the Australian Lobi vanellus labatus both sexes have spurs, but these are much larger in the males than in the females. In an allied bird, the Hoplopterus armatus, the spurs do not increase in size during the breeding season, but these birds have been seen in Egypt to fight together, in the same manner as our peewits, by turning suddenly in the air, and striking sideways at each other, sometimes with fatal results. Thus also they drive away other enemies. The season of love is that of battle, but the males of some birds, as of the game fowl and ruff, and even the young males of the wild turkey and grouse, are ready to fight whenever they meet. The presence of the female is the Teterima bellicausa. The Bengali baboos make the pretty little males of the Amadevat, Estrelda amandava, fight together by placing 3 small cages in a row, with the female in the middle. After a little time the 2 males are turned loose, and immediately a desperate battle ensues. When many males congregate at the same appointed spot and fight together, as in the case of grouse and various other birds, they are generally attended by the females. Brehm, however, asserts that in Germany the grey hens do not generally attend the black cocks, but this is an exception to the common rule. Possibly the hens may lie hidden in the surrounding bushes, as is known to be the case with the grey hens in Scandinavia, and with other species in North America, which afterwards pair with the victorious combatants. But in some cases the pairing precedes instead of succeeding the combat. Thus, according to Audubon, several males of the Virginian goatsucker Caprimulgus virgianus court in a highly entertaining manner the female, and no sooner has she made her choice than her approved gives chase to all intruders, and drives them beyond his dominions. Generally, the males try to drive away or kill their rivals before they pair. It does not, however, appear that the females invariably prefer the victorious males. I have indeed been assured by Dr. W. Kovalevsky that the female capercailzie sometimes steals away with a young male who has not dared to enter the arena with the older cocks, in the same manner as occasionally happens with the does of the red deer in Scotland. When 2 males contend in presence of a single female, the victor no doubt commonly gains his desire, but some of these battles are caused by wandering males trying to distract the peace of an already mated pair. Even with the most pugnacious species, it is probable that the pairing does not depend exclusively on the mere strength and courage of the male, for such males are generally decorated with various ornaments, which often become more brilliant during the breeding season, and which are sedulously displayed before the females. The males also endeavour to charm or excite their mates by love notes, songs, and antics, and the courtship is, in many instances, a prolonged affair. Hence it is not probable that the females are indifferent to the charms of the opposite sex, or that they are invariably compelled to yield to the victorious males. It is more probable that the females are excited either before or after the conflict by certain males, and thus unconsciously prefer them. In the case of Tetrao umbellus, a good observer goes so far as to believe that the battles of the male are all a sham, performed to show themselves to the greatest advantage before the admiring females who assemble around, for I have never been able to find a maimed hero, and seldom more than a broken feather. I shall have to recur to this subject, but I may here add that with the Tetrao cupido of the United States, about a score of males assemble at a particular spot, and strutting about make the whole air resound with their extraordinary noises. At the first answer from a female, the males begin to fight furiously, and the weaker give way. But then, according to Audubon, both the victors and vanquished search for the female, so that the females must either then exert a choice, or the battle must be renewed. So again, with one of the field starlings of the United States, Turnella ludoviciana, the males engage in fierce conflicts, but at the sight of a female they all fly after her as if mad. Vocal and instrumental music. With birds the voice serves to express various emotions, such as distress, fear, anger, triumph, or mere happiness. It is apparently sometimes used to excite terror, as in the case of the hissing noise made by some nestling birds. Audubon relates that a night heron Ardea nycticorax, Linnaean, which he kept tame, used to hide itself when a cat approached, and then suddenly start up uttering one of the most frightful cries, apparently enjoying the cat's alarm and flight. The common domestic cock clucks to the hen, and the hen to her chickens when a dainty morsel is found. The hen, when she has laid an egg, repeats the same note very often, and concludes with the sixth above, which she holds for a longer time, and thus she expresses her joy. Some social birds apparently call to each other for aid, and as they flit from tree to tree, the flock is kept together by chirp answering chirp. During the nocturnal migrations of geese and other waterfowl, sonorous clangs from the van may be heard in the darkness overhead, answered by clangs in the rear. Certain cries serve as danger signals, which, as the sportsman knows to his cost, are understood by the same species and by others. The domestic cock crows, and the humming-bird chirps in triumph over a defeated rival. The true song, however, of most birds and various strange cries are chiefly uttered during the breeding season, and serve as a charm or merely as a call note to the other sex. Naturalists are much divided with respect to the object of the singing of birds. Few more careful observers ever lived than Montagu, and he maintained that the males of song-birds and of many others do not in general search for the female, but, on the contrary, their business in the spring is to perch on some conspicuous spot, breathing out their full and amorous notes, which by instinct the female knows, and repairs to the spot to choose her mate. Mr. Jenner Weir informs me that this is certainly the case with the nightingale. Bechstein, who kept birds during his whole life, asserts that the female canary always chooses the best singer, and that in a state of nature the female finch selects that male out of 100 whose notes please her most. Mr. Harrison Weir likewise writes to me: "I am informed that the best singing males generally get a mate first, when they are bred in the same room." There can be no doubt that birds closely attend to each other's song. Mr. Weir has told me of the case of a bullfinch which had been taught to pipe a German waltz, and who was so good a performer that he cost 10 guineas. When this bird was first introduced into a room where other birds were kept, and he began to sing, all the others, consisting of about 20 linnets and canaries, ranged themselves on the nearest side of their cages, and listened with the greatest interest to the new performer. Many naturalists believe that the singing of birds is almost exclusively the effect of rivalry and emulation, and not for the sake of charming their mates. This was the opinion of Daines Barrington and White of Selborne, who both especially attended to this subject. Barrington, however, admits that superiority in song gives to birds an amazing ascendancy over others, as is well known to bird-catchers. It is certain that there is an intense degree of rivalry between the males in their singing. Bird fanciers match their birds to see which will sing longest, and I was told by Mr. Yarrell that a first-rate bird will sometimes sing till he drops down almost dead, or, according to Bechstein, quite dead, from rupturing a vessel in the lungs. Whatever the cause may be, male birds, as I hear from Mr. Weir, often die suddenly during the season of song. That the habit of singing is sometimes quite independent of love is clear, for a sterile, hybrid canary bird has been described as singing whilst viewing itself in a mirror and then dashing at its own image. It likewise attacked with fury a female canary when put into the same cage. The jealousy excited by the act of singing is constantly taken advantage of by bird catchers. A male in good song is hidden and protected, whilst a starved bird, surrounded by limed twigs, is exposed to view. In this manner, as Mr. Weir informs me, a man has in the course of a single day caught 50, and in one instance 70 male chaffinches. The power and the inclination to sing differ so greatly with birds, that although the price of an ordinary male chaffinch is only 6d., Mr. Weir saw one bird for which the bird-catcher asked £3. The test of a really good singer being that it will continue to sing whilst the cage is swung round the owner's head. That male birds should sing from emulation as well as for charming the female is not at all incompatible, and it might have been expected that these two habits would have concurred, like those of display and pugnacity. Some authors, however, argue that the song of the male cannot serve to charm the female, because the females of some few species, such as of the canary, robin, lark, and bullfinch, especially when in a state of widowhood, as Bechstein remarks, pour forth fairly melodious strains. In some of these cases the habit of singing may be in part attributed to the females having been highly fed and confined, for this disturbs all the functions connected with the reproduction of the species. Many instances have already been given of the partial transference of secondary masculine characters to the female, so that it is not at all surprising that the females of some species should possess the power of song. It has also been argued that the song of the male cannot serve as a charm because the males of certain species, for instance of the robin, sing during the autumn. This is likewise the case with the water ouzel. But nothing is more common than for animals to take pleasure in practising whatever instinct they follow at other times for some real good. How often do we see birds which fly easily, gliding and sailing through the air obviously for pleasure. The cat plays with the captured mouse, and the cormorant with the captured fish. The weather bird Plosius, when confined in a cage, amuses itself by neatly weaving blades of grass between the wires of its cage. Birds which habitually fight during the breeding season are generally ready to fight at all times, and the males of the capercailzie sometimes hold their balzen or leks at the usual place of assemblage during the autumn. Hence it is not at all surprising that male birds should continue singing for their own amusement after the season for courtship is over. As shown in a previous chapter, singing is to a certain extent an art, and is much improved by practice. Birds can be taught various tunes, and even the unmelodious sparrow has learned to sing like a linnet. They acquire the song of their foster parents, and sometimes that of their neighbours. Dureau de la Malle gives a curious instance of some wild blackbirds in his garden in Paris, which naturally learnt a republican air from a caged bird. All the common songsters belong to the order of incessors, and their vocal organs are much more complex than those of most other birds. Yet it is a singular fact that some of the incessors, such as ravens, crows, and magpies, possess the proper apparatus, though they never sing, and do not naturally modulate their voices to any great extent. Hunter asserts that with the true songsters the muscles of the larynx are stronger in the males than in the females, but with this slight exception there is no difference in the vocal organs of the two sexes, although the males of most species sing so much better and more continuously than the females. It is remarkable that only small birds properly sing. The Australian genus Menura, however, must be excepted, for the Menura alberti, which is about the size of a half-grown turkey, not only mocks other birds, but its own whistle is exceedingly beautiful and varied. The males congregate and form corroborating places, where they sing, raising and spreading their tails like peacocks, and drooping their wings. It is also remarkable that birds which sing well are rarely decorated with brilliant colours or other ornaments. Of our British birds, excepting the bullfinch and goldfinch, the best songsters are plain coloured. The kingfisher, bee-eater, roller, hoopoe, woodpeckers, etc., utter harsh cries, and the brilliant birds of the tropics are hardly ever songsters. Hence bright colours and the power of song seem to replace each other. We can perceive that if the plumage did not vary in brightness, or if bright colours were dangerous to the species, other means would be employed to charm the females, and melody of voice offers one such means. In some birds the vocal organs differ greatly in the two sexes. In the tetrao cupido the male has two bare, orange-coloured sacs, one on each side of the neck, and these are largely inflated when the male, during the breeding season, makes his curious hollow sound, audible at a great distance. Audubon proved that the sound was intimately connected with this apparatus, which reminds us of the air sacs on each side of the mouth of certain male frogs, for he found that the sound was much diminished when one of the sacs of a tame bird was pricked, and when both were pricked it was altogether stopped. The female has a somewhat similar, though smaller naked space of skin on the neck, but this is not capable of inflation. Mr. T.W. Wood gives in The Student an excellent account of the attitude and habits of this bird during its courtship. He states that the ear tufts or neck plumes are erected so that they meet over the crown of the head. The male of another kind of grouse, whilst courting the female, has his bare yellow oesophagus inflated to a prodigious size, fully half as large as the body, and he then utters various grating, deep, hollow tones. With his neck feathers erect, his wings lowered and buzzing on the ground, and his long pointed tail spread out like a fan, he displays a variety of grotesque attitudes. The oesophagus of the female is not in any way remarkable. End of section 13.
Section 14 of The Descent of Man, Part 2. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Descent of Man, Part 2, by Charles Darwin. Chapter 13. Secondary Sexual Characters of Birds, Part 2. It seems now well made out that the great throat pouch of the European male bustard, Otis tarda, and of at least 4 other species, does not, as was formerly supposed, serve to hold water, but is connected with the utterance during the breeding season of a peculiar sound resembling oak. A crow-like bird inhabiting South America, see Cephalopterus ornatus, is called the umbrella bird, from its immense top knot, formed of bare white quills surmounted by dark blue plumes, which it can elevate into a great dome no less than 5 inches in diameter, covering the whole head. The bird has on its neck a long, thin, cylindrical, fleshy appendage, which is thickly clothed with scale-like blue feathers. It probably serves in part as an ornament, but likewise as a resounding apparatus, for Mr. Bates found that it is connected with an unusual development of the trachea and vocal organs. It is dilated when the bird utters its singularly deep, loud, and long-sustained fluty note. The head crest and neck appendage are rudimentary in the female. A new species with a still larger neck appendage, C. penduliger, has lately been discovered. The vocal organs of various web-footed and wading birds are extraordinarily complex, and differ to a certain extent in the two sexes. In some cases the trachea is convoluted, like a French horn, and is deeply embedded in the sternum. In the wild swan, Cygnus ferus, it is more deeply embedded in the adult male than in the adult female or young male. In the male merganser, the enlarged portion of the trachea is furnished with an additional pair of muscles. In one of the ducks, however, namely Anas punctata, the bony enlargement is only a little more developed in the male than in the female. But the meaning of these differences in the trachea of the two sexes of the Anatidae is not understood, for the male is not always the more vociferous. Thus with the common duck, the male hisses, whilst the female utters a loud quack. The spoonbill, Platalea, has its trachea convoluted into a figure of 8, and yet this is mute. But Mr. Blyth informs me that the convolutions are not constantly present, so that perhaps they are now tending towards abortion. In both sexes of one of the cranes, Grus virgo, the trachea penetrates the sternum, but presents certain sexual modifications. In the male of the black stork there is also a well-marked sexual difference in the length and curvature of the bronchi. Highly important structures have, therefore, in these cases, been modified according to sex. It is often difficult to conjecture whether the many strange cries and notes uttered by male birds during the breeding season serve as a charm or merely as a call to the female. The soft cooing of the turtle dove and of many pigeons, it may be presumed, pleases the male. When the female of the wild turkey utters her call in the morning, the male answers by a note which differs from the gobbling noise made, when, with erected feathers, rustling wings, and distended wattles, he puffs and struts before her. The spell of the black cock certainly serves as a call to the female, for it has been known to bring 4 or 5 females from a distance to a male under confinement. But as the black cock continues his spell for hours during successive days, and in the case of the capercailzie, with an agony of passion, we are led to suppose that the females which are present are thus charmed. The voice of the common rook is known to alter during the breeding season, and is therefore in some way sexual. But what shall we say about the harsh screams of, for instance, some kinds of macaws? Have these birds as bad taste for musical sounds as they apparently have for colour, judging by the inharmonious contrast of their bright yellow and blue plumage? It is indeed possible that without any advantage being thus gained, the loud voices of many male birds may be the result of the inherited effects of the continued use of their vocal organs when excited by the strong passions of love, jealousy, and rage. But to this point we shall recur when we treat of quadrupeds. We have as yet spoken only of the voice, but the males of various birds practice, during their courtship, what may be called instrumental music. Peacocks and birds of paradise rattle their quills together. Turkey-cocks scrape their wings against the ground, and some kinds of grouse thus produce a buzzing sound. Another North American grouse, the Tetraro umbellus, when with his tail erect, his ruffs displayed, he shows off his finery to the females who lie hid in the neighbourhood, drums by rapidly striking his wings together above his back, according to Mr. R. Haymond, and not, as Audubon thought, by striking them against his sides. The sound thus produced is compared by some to distant thunder, and by others to the quick roll of a drum. The female never drums, but flies directly to the place where the male is thus engaged. The male of the Kylage pheasant, in the Himalayas, often makes a singular drumming noise with his wings, not unlike the sound produced by shaking off a stiff piece of cloth. On the west coast of Africa the little black weavers (Ploceus) congregate in a small party on the bushes round a small open space, and sing and glide through the air with quivering wings, which make a rapid whirring sound like a child's rattle. One bird after another thus performs for hours together, but only during the courting season. At this season, and at no other time, the males of certain nightjars (Caprimulgus) make a strange booming noise with their wings. The various species of woodpeckers strike a sonorous branch with their beaks, with so rapid a vibratory movement that the head appears to be in two places at once. The sound thus produced is audible at a considerable distance, but cannot be described, and I feel sure that its source would never be conjectured by any one hearing it for the first time. As this jarring sound is made chiefly during the breeding season, it has been considered as a love song, but it is perhaps more strictly a love call. The female, when driven from her nest, has been observed thus to call her mate, who answered in the same manner and soon appeared. Lastly, the male hoopoe (Upupa apops) combines vocal and instrumental music, for during the breeding season this bird, Mr. Swinhoe observed, first draws in air, and then taps the end of its beak perpendicularly down against a stone or the trunk of a tree, when the breath being forced down the tubular bill produces the correct sound. If the beak is not thus struck against some object, the sound is quite different. Air is at the same time swallowed, and the esophagus thus becomes much swollen, and this probably acts as a resonator, not only with the hoopoe, but with pigeons and other birds. In the foregoing cases sounds are made by the aid of structures already present and otherwise necessary, but in the following cases certain feathers have been specially modified for the express purpose of producing sounds. The drumming, bleating, neighing, or thundering noise, as expressed by different observers, made by the common snipe (Scolopax gallinago), must have surprised every one who has ever heard it. This bird, during the pairing season, flies to perhaps 1,000 feet in height, and after zigzagging about for a time, descends to the earth in a curved line, with outspread tail and quivering pinions, and surprising velocity. The sound is emitted only during this rapid descent. No one was able to explain the cause until M. Meves observed that on each side of the tail the outer feathers are peculiarly formed, having a stiff saber-shaped shaft with the oblique barbs of unusual length, the outer webs being strongly bound together. He found that by blowing on these feathers, or by fastening them to a long thin stick and waving them rapidly through the air, he could reproduce the drumming noise made by the living bird. Both sexes are furnished with these feathers, but they are generally larger in the male than in the female, and emit a deeper note. In some species, as in S. frenata, 4 feathers, and in S. javensis, no less than 8 on each side of the tail, are greatly modified. Different tones are emitted by the feathers of the different species when waved through the air, and the Scolopax wilsonii of the United States makes a switching noise whilst descending rapidly to earth. In the male of the Chamaepetes unicolor, a large gallinaceous bird of America, the first primary wing feather is arched towards the tip, and is much more attenuated than in the female. In an allied bird, the Penelope nigra, Mr. Salvin observed a male, which, whilst it flew downwards with outstretched wings, gave forth a kind of crashing rushing noise, like the falling of a tree. The male alone of one of the Indian bustards, Sypheotides auritus, has its primary wing feathers greatly acuminated, and the male of an allied species is known to make a humming noise whilst courting the female. In a widely different group of birds, namely humming birds, the males alone of certain kinds have either the shafts of their primary wing feathers broadly dilated, or the webs abruptly excised towards the extremity. The male, for instance, of Selasphorus platycercus, when adult, has the first primary wing feather thus excised. Whilst flying from flower to flower, he makes a shrill, almost whistling noise. But it did not appear to Mr. Salvin that the noise was intentionally made. Lastly, in several species of a subgenus of Pipra or Manakin, the males, as described by Mr. Sclater, have their secondary wing feathers modified in a still more remarkable manner. In the brilliantly coloured P. deliciosa, the first three secondaries are thick-stemmed and curved towards the body. In the fourth and fifth the change is greater, and in the sixth and seventh the shaft is thickened to an extraordinary degree, forming a solid horny lump. The barbs also are greatly changed in shape, in comparison with the corresponding feathers in the female. Even the bones of the wing, which support these singular feathers in the male, are said by Mr. Fraser to be much thickened. These little birds make an extraordinary noise, the first sharp note being not unlike the crack of a whip. The diversity of the sounds, both vocal and instrumental, made by the males of many birds during the breeding season, and the diversity of the means for producing such sounds, are highly remarkable. We thus gain a high idea of their importance for sexual purposes, and are reminded of the conclusion arrived at as to insects. It is not difficult to imagine the steps by which the notes of a bird, primarily used as a mere call or for some other purpose, might have been improved into a melodious love song. In the case of the modified feathers, by which the drumming, whistling, or roaring noises are produced, we know that some birds, during their courtship, flutter, shake, or rattle their unmodified feathers together; and if the females were led to select the best performers, the males which possessed the strongest or thickest or most attenuated feathers, situated on any part of the body, would be the most successful. And thus, by slow degrees, the feathers might be modified to almost any extent. The females, of course, would not notice each slight successive alteration in shape, but only the sounds thus produced. It is a curious fact that in the same class of animals, sounds so different as the drumming of the snipe's tail, the tapping of the woodpecker's beak, the harsh trumpet-like cry of certain water fowl, the cooing of the turtle-dove, and the song of the nightingale, should all be pleasing to the females of the several species. But we must not judge of the tastes of distinct species by a uniform standard, nor must we judge by the standard of man's taste. Even with man we should remember that discordant noises, the beating of tom-toms and the shrill notes of reeds, please the ears of savages. Sir S. Baker remarks that, "as the stomach of the Arab prefers the raw meat and reeking liver taken hot from the animal, so does his ear prefer his equally coarse and discordant music to all other." Love antics and dances. The curious love gestures of some birds have already been incidentally noticed, so that little need here be added. In Northern America, large numbers of a grouse, the Tetrao phasianellus, meet every morning during the breeding season on a selected level spot, and here they run round and round in a circle of about 15 or 20 feet in diameter, so that the ground is worn quite bare, like a fairy ring. In these partridge dances, as they are called by the hunters, the birds assume the strangest attitudes, and run around, some to the left and some to the right. Audubon describes the males of a heron, Ardea herodias, as walking about on their long legs with great dignity before the females, bidding defiance to their rivals. With one of the disgusting carrion vultures, Cartartes iota, the same naturalist states that the gesticulations and parade of the males at the beginning of the love season are extremely ludicrous. Certain birds perform their love antics on the wing, as we have seen with the black African weaver, instead of on the ground. During the spring our little white throat, Sylvia cinerea, often rises a few feet or yards in the air above some bush, and flutters with a fitful and fantastic motion, singing all the while, and then drops to its perch. The great English bustard throws himself into indescribably odd attitudes whilst courting the female, as he has been figured by Wolf. An allied Indian bustard, Otis bengalensis, at such times rises perpendicularly into the air with a hurried flapping of his wings, raising his crest and puffing out the feathers of his neck and breast, and then drops to the ground. He repeats this maneuver several times, at the same time humming in a peculiar tone. Such females as happen to be near obey the saltatory summons, and when they approach he trails his wings and spreads his tail like a turkey-cock. But the most curious case is afforded by three allied genera of Australian birds, the famous bower birds, no doubt the co-descendants of some ancient species which first acquired the strange instinct of constructing bowers for performing their love antics. The bowers, which, as we shall hereafter see, are decorated with feathers, shells, bones, and leaves, are built on the ground for the sole purpose of courtship, for their nests are formed in trees. Both sexes assist in the erection of the bowers, but the male is the principal workman. So strong is this instinct that it is practised under confinement, and Mr. Strange has described the bower of the satin bower bird may be seen in the Zoological Society's Gardens, Regent's Park. The habits of some satin bower birds, which he kept in an aviary in New South Wales. At times the male will chase the female all over the aviary, then go to the bower, pick up a gay feather or a large leaf, utter a curious kind of note, set all his feathers erect, run around the bower, and become so excited that his eyes appear ready to start from his bead. He continues, opening first one wing, then the other, uttering a low, whistling note, and like the domestic cock seems to be picking up something from the ground, until at last the female goes gently towards him. Captain Stokes has described the habits and playhouses of another species, the great bower bird, which was seen amusing itself by flying backwards and forwards, taking a shell alternately from each side, and carrying it through the archway in its mouth. These curious structures, formed solely as halls of assemblage, where both sexes amuse themselves and pay their court, must cost the birds much labour. The bower, for instance, of the fawn-breasted species is nearly 4 feet in length, 18 inches in height, and is raised on a thick platform of sticks. Decoration. I will first discuss the cases in which the males are ornamented either exclusively or in a much higher degree than the females, and in a succeeding chapter those in which both sexes are equally ornamented, and finally the rare cases in which the female is somewhat more brightly colored than the male. As with the artificial ornaments used by savage and civilized men, so with the natural ornaments of birds, the head is the chief seat of decoration. The ornaments, as mentioned at the commencement of this chapter, are wonderfully diversified. The plumes on the front or back of the head consist of variously shaped feathers, sometimes capable of erection or expansion, by which their beautiful colours are fully displayed. Elegant ear tufts are occasionally present. The head is sometimes covered with velvety down, as with the pheasant, or is naked and vividly coloured. The throat, also, is sometimes ornamented with a beard, wattles, or caruncles. Such appendages are generally brightly coloured, and no doubt serve as ornaments, though not always ornamental in our eyes, for whilst the male is in the act of courting the female, they often swell and assume vivid tints as in the male turkey. At such times the fleshy appendages about the head of the tragopan pheasant Ceranoris temminckii swell into a large lappet on the throat, and into two horns, one on each side of the splendid topknot, and these are then coloured of the most intense blue which I have ever beheld. The African hornbill, Bucorax abyssinicus, inflates the scarlet bladder-like wattle on its neck, and with its wings drooping and tail expanded makes quite a grand appearance. Even the iris of the eye is sometimes more brightly coloured in the male than in the female, and this is frequently the case with the beak, for instance in our common blackbird. In Buceros corrugatus the whole beak and immense casque are coloured more conspicuously in the male than in the female, and the oblique grooves upon the sides of the lower mandible are peculiar to the male sex. The head, again, often supports fleshy appendages, filaments, and solid protuberances. These, if not common to both sexes, are always confined to the males. The solid protuberances have been described in detail by Dr. W. Marshall, who shows that they are formed either of cancellated bone coated with skin, or of dermal and other tissues. With mammals true horns are always supported on the frontal bones, but with birds various bones have been modified for this purpose, and in species of the same group the protuberances may have cores of bone, or be quite destitute of them, with intermediate gradations connecting these two extremes. Hence, as Dr. Marshall justly remarks, variations of the most different kinds have served for the development through sexual selection of these ornamental appendages. Elongated feathers or plumes spring from almost every part of the body. The feathers on the throat and breast are sometimes developed into beautiful ruffs and collars. The tail feathers are frequently increased in length, as we see in the tail coverts of the peacock, and in the tail itself of the Argus pheasant. With the peacock even the bones of the tail have been modified to support the heavy tail coverts. The body of the Argus is not larger than that of a fowl, yet the length from end of the beak to the extremity of the tail is no less than 5 feet 3 inches, and that of the beautifully ocellated secondary wing feathers nearly 3 feet. In a small African nightjar, Cosmetornis vexillarius, one of the primary wing feathers during the breeding season attains a length of 26 inches, whilst the bird itself is only 10 inches in length. In another closely allied genus of nightjars, the shafts of the elongated wing feathers are naked, except at the extremity, where there is a disc. Again, in another genus of nightjars, the tail feathers are even still more prodigiously developed. In general, the feathers of the tail are more often elongated than those of the wings, as any great elongation of the latter impedes flight. We thus see that in closely allied birds, ornaments of the same kind have been gained by the males through the development of widely different feathers. It is a curious fact that the feathers of species belonging to very distinct groups have been modified in almost exactly the same peculiar manner. Thus the wing feathers in one of the above-mentioned night-jars are bare along the shaft, and terminate in a disc, or are, as they are sometimes called, spoon or racket-shaped. Feathers of this kind occur in the tail of a motmot, Eumomota superciliaris, of a kingfisher, finch, hummingbird, parrot, several Indian drongos, Dicrurus and Edolius, in one of which the disc stands vertically, and in the tail of certain birds of paradise. In these latter birds similar feathers, beautifully ocellated, ornament the head, as is likewise the case with some gallinaceous birds. In an Indian bustard, Siphiotides auritus, the feathers forming the ear tufts, which are about 4 inches in length, also terminate in discs. It is a most singular fact that the motmots, as Mr. Salvin has clearly shown, give to their tail feathers the racket shape by biting off the barbs, and further that this continued mutilation has produced a certain amount of inherited effect. Again, the barbs of the feathers in various widely distinct birds are filamentous or plumose, as with some herons, ibises, birds of paradise, and gallinaceae. In other cases the barbs disappear, leaving the shafts bare from end to end, and these, in the tail of the Paradisea apoda, attain a length of 34 inches. In P. papuana they are much shorter and thin. Smaller feathers, when thus denuded, appear like bristles, as on the breast of the turkey-cock. As any fleeting fashion in dress comes to be admired by man, so with birds a change of almost any kind in the structure or colouring of the feathers in the male appears to have been admired by the female. The fact of the feathers in widely distinct groups having been modified in an analogous manner no doubt depends primarily on all the feathers having nearly the same structure and manner of development, and consequently tending to vary in the same manner. We often see a tendency to analogous variability in the plumage of our domestic breeds belonging to distinct species. Thus topknots have appeared in several species. In an extinct variety of the turkey, the topknot consisted of bare quills surmounted with plumes of down, so that they somewhat resembled the racket-shaped feathers above described. In certain breeds of the pigeon and fowl the feathers are plumose, with some tendency in the shafts to be naked. In the Sebastopol goose the scapular feathers are greatly elongated, curled, or even spirally twisted, with the margins plumose. In regard to colour, hardly anything need here be said, for every one knows how splendid are the tints of many birds, and how harmoniously they are combined. The colours are often metallic and iridescent. Circular spots are sometimes surrounded by one or more different shaded zones, and are thus converted into ocelli. Nor need much be said on the wonderful difference between the sexes of many birds. The common peacock offers a striking instance. Female birds of paradise are obscurely coloured and destitute of all ornaments, whilst the males are probably the most highly decorated of all birds, and in so many different ways that they must be seen to be appreciated. The elongated and golden orange plumes which spring from beneath the wings of the Paradisea apoda, when vertically erected and made to vibrate, are described as forming a sort of halo, in the centre of which the head looks like a little emerald sun with its rays formed by the two plumes. In another most beautiful species the head is bald, and of a rich cobalt blue, crossed by several lines of black velvety feathers. Male hummingbirds almost vie with birds of paradise in their beauty, as every one will admit who has seen Mr. Gould's splendid volumes or his rich collection. It is very remarkable in how many different ways these birds are ornamented. Almost every part of their plumage has been taken advantage of and modified, and the modifications have been carried, as Mr. Gould showed me, to a wonderful extreme in some species belonging to nearly every subgroup. Such cases are curiously like those which we see in our fancy breeds, reared by man for the sake of ornament. Certain individuals originally varied in one character, and other individuals of the same species in other characters, and these have been seized on by man, and much augmented, as shown by the tail of the fan-tail pigeon, the hood of the Jacobin, the beak and wattle of the carrier, and so forth. The sole difference between these cases is that in the one the result is due to man's selection, while in the other, as with hummingbirds, birds of paradise, etc., it is due to the selection by the females of the more beautiful males. I will mention only one other bird, remarkable from the extreme contrast in colour between the sexes, namely the famous bellbird of South America, the note of which can be distinguished at the distance of nearly 3 miles, and astonishes every one when first hearing it. The male is pure white, whilst the female is dusky green, and white is a very rare colour in terrestrial species of moderate size and inoffensive habits. The male also, as described by Waterton, has a spiral tube, nearly 3 inches in length, which rises from the base of the beak. It is jet black, dotted over with minute downy feathers. This tube can be inflated with air, through a communication with a palate, and when not inflated hangs down on one side. The genus consists of 4 species, the males of which are very distinct, whilst the females, as described by Mr. Sclater in a very interesting paper, closely resemble each other, thus offering an excellent instance of the common rule that within the same group the males differ much more from each other than do the females. In a second species, C. nudicalis, the male is likewise snow white, with the exception of a large space of naked skin on the throat and round the eyes, which during the breeding season is of a fine green colour. In a third species, C. tricarinculatus, the head and neck alone of the male are white, the rest of the body being chestnut brown, and the male of this species is provided with 3 filamentous projections, half as long as the body, one rising from the base of the beak, and the 2 others from the corners of the mouth. The coloured plumage and certain other ornaments of the adult males are either retained for life, or are periodically renewed during the summer and breeding season. At this same season the beak and naked skin about the head frequently change colour, as with some herons, ibises, gulls, one of the bellbirds just noticed, etc. In the white ibis, the cheeks, the inflatable skin of the throat, and the basal portion of the beak then become crimson. In one of the rails, Gallicrex cristatus, a large red caruncle is developed during this period on the head of the male. So it is with a thin horny crest on the beak of one of the pelicans, P. erythrorhynchus, for, after the breeding season, these horny crests are shed, like horns from the heads of stags, and the shore of an island in a lake in Nevada was found covered with these curious exuviae. Changes of colour in the plumage according to the season depend firstly on a double annual moult, secondly on an actual change of colour in the feathers themselves, and thirdly on their dull coloured margins being periodically shed, or on these 3 processes more or less combined. The shedding of the deciduary margins may be compared with the shedding of their down by very young birds, for the down in most cases arises from the summits of the first true feathers. End of section 14. Recording by Guero.
Section 15 of The Descent of Man, Part 2. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Rory Lawton in November 2010. The Descent of Man, Part 2, by Charles Darwin. Chapter 13. Secondary Sexual Characters of Birds. Part 3. With respect to the birds which annually undergo a double moult, there are, firstly, some kinds, for instance snipes, swallow plovers (Glariolae), and curlews, in which the 2 sexes resemble each other, and do not change colour at any season. I do not know whether the winter plumage is thicker and warmer than the summer plumage, but warmth seems the most probable end attained of a double moult, where there is no change of colour. Secondly, there are birds, for instance, certain species of Totanus and other Gralatores, the sexes of which resemble each other, but in which the summer and winter plumage differ slightly in colour. The difference, however, in these cases is so small that it can hardly be an advantage to them, and it may perhaps be attributed to the direct action of the different conditions to which the birds are exposed during the two seasons. Thirdly, there are many other birds, the sexes of which are alike, but which are widely different in their summer and winter plumage. Fourthly, there are birds the sexes of which differ from each other in colour, but the females, though moulting twice, retain the same colours throughout the year, whilst the males undergo a change of colour, sometimes a great one, as with certain bustards. Fifthly and lastly, there are birds the sexes of which differ from each other in both their summer and winter plumage, but the male undergoes a greater amount of change at each recurrent season than the female, of which the ruff, Machetes pugnax, offers a good instance. With respect to the cause or purpose of the differences in colour between the summer and winter plumage, this may in some instances, as with the ptarmigan, the brown mottled summer plumage of the ptarmigan is of as much importance to it as a protection as the white winter plumage; for in Scandinavia during the spring, when the snow has disappeared, this bird is known to suffer greatly from birds of prey, before it has acquired its summer dress, serve during both seasons as a protection. When the difference between the two plumages is slight, it may perhaps be attributed, as already remarked, to the direct action of the conditions of life. But with many birds there can hardly be a doubt that the summer plumage is ornamental, even when both sexes are alike. We may conclude that this is the case with many herons, egrets, etc., for they acquire their beautiful plumes only during the breeding season. Moreover, such plumes, topknots, etc., though possessed by both sexes, are occasionally a little more developed in the male than in the female, and they resemble the plumes and ornaments possessed by the males alone of other birds. It is also known that confinement, by affecting the reproductive system of male birds, frequently checks the development of their secondary sexual characters, but has no immediate influence on any other characters; and I am informed by Mr. Bartlett that 8 or 9 specimens of the knot, Tringa canutus, retained their unadorned winter plumage in the Zoological Gardens throughout the year, from which fact we may infer that the summer plumage, though common to both sexes, partakes of the nature of the exclusively masculine plumage of many other birds. From the foregoing facts, more especially from neither sex of certain birds changing colour during either annual moult, or changing so slightly that the change can hardly be of any service to them, and from the females of other species moulting twice, yet retaining the same colours throughout the year, we may conclude that the habit of annually moulting twice has not been acquired in order that the male should assume an ornamental character during the breeding season, but that the double moult, having been originally acquired for some distinct purpose, has subsequently been taken advantage of in certain cases for gaining a nuptial plumage. It appears at first sight a surprising circumstance that some closely allied species should regularly undergo a double annual moult, and others only a single one. The ptarmigan, for instance, moults twice or even thrice in the year, and the blackcock only once. Some of the splendidly coloured honeysuckers, Nectarinae, of India, and some subgenera of obscurely coloured pipits, Anthus, have a double, whilst others have only a single annual moult. But the gradations in the manner of moulting, which are known to occur with various birds, show us how species or whole groups might have originally acquired their double annual moult, or having once gained the habit, have again lost it. With certain bustards and plovers the vernal moult is far from complete, some feathers being renewed and some changed in colour. There is also reason to believe that with certain bustards and rail-like birds, which properly undergo a double moult, some of the older males retain their nuptial plumage throughout the year. A few highly modified feathers may merely be added during the spring to the plumage, as occurs with the disc-formed tail feathers of certain drongos (Vringa) in India, and with the elongated feathers on the back, neck, and crest of certain herons. By such steps as these, the vernal moult might be rendered more and more complete, until a perfect double moult was acquired. Some of the birds of paradise retain their nuptial feathers throughout the year, and thus have only a single moult. Others cast them directly after the breeding season, and thus have a double moult; and others again cast them at this season during the first year, but not afterwards, so that these latter species are intermediate in their manner of moulting. There is also a great difference with many birds in the length of time during which the two annual plumages are retained, so that the one might come to be retained for the whole year, and the other completely lost. Thus in the spring Machetes pugnax retains his ruff for barely 2 months. In Natal, the male widow bird, Chera progne, acquires his fine plumage and long tail feathers in December or January, and loses them in March, so that they are retained only for about 3 months. Most species, which undergo a double moult, keep their ornamental feathers for about 6 months. The male, however, of the wild Gallus bankiva retains his neck hackles for 9 or 10 months, and when these are cast off, the underlying black feathers of the neck are fully exposed to view. But with the domesticated descendant of this species, the neck hackles of the male are immediately replaced by new ones, so that we here see, as to part of the plumage, a double moult changed under domestication into a single moult. The common drake, Anas boscas, after the breeding season, is well known to lose his male plumage for a period of 3 months, during which time he assumes that of the female. The male pin-tail duck, Anas acuta, loses his plumage for the shorter period of 6 weeks or 2 months, and Montagu remarks that "this double moult within so short a time is a most extraordinary circumstance, that seems to bid defiance to all human reasoning." But the believer in the gradual modification of species will be far from feeling surprise at finding gradations of all kinds. If the male pin-tail were to acquire this new plumage within a still shorter period, the new male feathers would almost necessarily be mingled with the old, and both with some proper to the female. And this apparently is the case with the male of a not distantly allied bird, namely the Merganser serrator, for the males are said to "undergo a change of plumage which assimilates them in some measure to the female." By a little further acceleration of the process, the double moult would be completely lost. Some male birds, as before stated, become more brightly coloured in the spring, not by a vernal moult, but either by an actual change of colour in the feathers, or by their obscurely coloured deciduary margins being shed. Changes of colour thus caused may last for a longer or shorter time. In the Pelecanus onocrotalus a beautiful rosy tint, with lemon-coloured marks on the breast, overspreads the whole plumage in the spring; but these tints, as Mr. Sclater states, do not last long, disappearing generally in about 6 weeks or 2 months after they have been attained. Certain finches shed the margins of their feathers in the spring, and then become brighter coloured, while other finches undergo no such change. Thus the Fringilla tristis of the United States, as well as many other American species, exhibits its bright colours only when the winter is past, whilst our goldfinch, which exactly represents this bird in habits, and our siskin, which represents it still more closely in structure, undergo no such annual change. But a difference of this kind in the plumage of allied species is not surprising, for with the common linnet, which belongs to the same family, the crimson forehead and breast are displayed only during the summer in England, whilst in Madeira these colours are retained throughout the year. Display by male birds of their plumage. Ornaments of all kinds, whether permanently or temporarily gained, are sedulously displayed by the males, and apparently serve to excite, attract, or fascinate the females. But the males will sometimes display their ornaments when not in the presence of the females, as occasionally occurs with grouse at their balz places, and as may be noticed with the peacock. This latter bird, however, evidently wishes for a spectator of some kind, and, as I have often seen, will show off his finery before poultry or even pigs. All naturalists who have closely attended to the habits of birds, whether in a state of nature or under confinement, are unanimously of opinion that the males take delight in displaying their beauty. Audubon frequently speaks of the male as endeavouring in various ways to charm the female. Mr. Gould, after describing some peculiarities in a male humming-bird, says he has no doubt that it has the power of displaying them to the greatest advantage before the female. Dr. Jerdon insists that the beautiful plumage of the male serves "to fascinate and attract the female." Mr. Bartlett, at the Zoological Gardens, expressed himself to me in the strongest terms to the same effect. It must be a grand sight in the forests of India to come suddenly on 20 or 30 peafowl, the males displaying their gorgeous trains, and strutting about in all the pomp of pride before the gratified females. The wild turkey-cock erects his glittering plumage, expands his finely zoned tail and barred wing feathers, and altogether, with his crimson and blue wattles, makes a superb, though to our eyes grotesque appearance. Similar facts have already been given with respect to grouse of various kinds. Turning to another order, the male Rupicola crocea is one of the most beautiful birds in the world, being of a splendid orange with some of the feathers curiously truncated and plumose. The female is brownish green, shaded with red, and has a much smaller crest. Sir R. Schomburgk has described their courtship. He found one of their meeting places where 10 males and 2 females were present. The space was from 4 to 5 feet in diameter, and appeared to have been cleared of every blade of grass, and smoothed as if by human hands. A male was capering, to the apparent delight of several others, now spreading its wings, throwing up its head, or opening its tail like a fan, now strutting about with a hopping gait until tired, when it gabbled some kind of note, and was relieved by another. Thus 3 of them successively took the field, and then, with self-approbation, withdrew to rest. The Indians, in order to obtain their skins, wait at one of the meeting places till the birds are eagerly engaged in dancing, and then are able to kill with their poisoned arrows 4 or 5 males, one after the other. With birds of paradise, a dozen or more full-plumaged males congregate in a tree to hold a dancing party, as it is called by the natives, and here they fly about, raise their wings, elevate their exquisite plumes, and make them vibrate, and the whole tree seems, as Mr. Wallace remarks, to be filled with waving plumes. When thus engaged, they become so absorbed that a skilful archer may shoot nearly the whole party. These birds, when kept in confinement in the Malay archipelago, are said to take much care in keeping their feathers clean, often spreading them out, examining them, and removing every speck of dirt. One observer, who kept several pairs alive, did not doubt that the display of the male was intended to please the female. The gold and Amherst pheasants during their courtship not only expand and raise their splendid frills, but twist them, as I have myself seen, obliquely towards the female on whichever side she may be standing, obviously in order that a large surface may be displayed before her. Mr. T. W. Wood has a full account of this manner of display, by the gold pheasant and by the Japanese pheasant Phasianus versicolor, and he calls it the lateral or one-sided display. They likewise turn their beautiful tails and tail coverts a little towards the same side. Mr. Bartlett has observed a male polyplectron in the act of courtship, and has shown me a specimen stuffed in the attitude then assumed. The tail and wing feathers of this bird are ornamented with beautiful ocelli, like those of the peacock's train. Now when the peacock displays himself, he expands and erects his tail transversely to his body, for he stands in front of the female, and has to show off, at the same time, his rich blue throat and breast. But the breast of the polyplectron is obscurely coloured, and the ocelli are not confined to the tail feathers. Consequently the polyplectron does not stand in front of the female, but he erects and expands his tail feathers a little obliquely, lowering the expanded wing on the same side, and raising that on the opposite side. In this attitude the ocelli over the whole body are exposed at the same time before the eyes of the admiring female, in one grand bespangled expanse. To whichever side she may turn, the expanded wings and the obliquely held tail are turned toward her. The male Tragopan pheasant acts in nearly the same manner, for he raises the feathers of the body, though not the wing itself, on the side which is opposite to the female, and which would otherwise be concealed, so that nearly all the beautifully spotted feathers are exhibited at the same time. The Argus pheasant affords a much more remarkable case. The immensely developed secondary wing feathers are confined to the male, and each is ornamented with a row of from 20 to 23 ocelli, above an inch in diameter. These feathers are so elegantly marked with oblique stripes and rows of spots of a dark colour, like those on the skin of a tiger and leopard combined. These beautiful ornaments are hidden until the male shows himself off before the female. He then erects his tail, and expands his wing feathers into a great almost upright circular fan or shield, which is carried in front of the body. The neck and head are held on one side, so that they are concealed by the fan, but the bird, in order to see the female, before whom he is displaying himself, sometimes pushes his head between 2 of the long wing feathers, as Mr. Bartlett has seen, and then presents a grotesque appearance. This must be a frequent habit with the bird in a state of nature, for Mr. Bartlett and his son, on examining some perfect skins sent from the East, found a place between 2 of the feathers which was much frayed, as if the head had here frequently been pushed through. Mr. Wood thinks that the male can also peep at the female on one side, beyond the margin of the fan. The ocelli on the wing feathers are wonderful objects, for they are so shaded that, as the Duke of Argyll remarks, they stand out like balls lying loosely within sockets. When I looked at the specimen in the British Museum, which is mounted with the wings expanded and trailing downwards, I was, however, greatly disappointed, for the ocelli appeared flat, or even concave. But Mr. Gould soon made the case clear to me, for he held the feathers erect, in the position in which they would naturally be displayed, and now, from the light shining on them from above, each ocellus at once resembled the ornament called a ball and socket. These feathers have been shown to several artists, and all have expressed their admiration at the perfect shading. It may well be asked, could such artistically shaded ornaments have been formed by means of sexual selection? But it will be convenient to defer giving an answer to this question until we treat in the next chapter of the principle of gradation. The foregoing remarks relate to the secondary wing feathers, but the primary wing feathers, which in most gallinaceous birds are uniformly coloured, are in the Argus pheasant equally wonderful. They are of a soft brown tint with numerous dark spots, each of which consists of 2 or 3 black dots with a surrounding dark zone. But the chief ornament is a space parallel to the dark blue shaft, which in outline forms a perfect second feather lying within the true feather. This inner part is coloured of a lighter chestnut, and is thickly dotted with minute white points. I have shown this feather to several persons, and many have admired it even more than the ball and socket feathers, and have declared that it was more like a work of art than of nature. Now these feathers are quite hidden in all ordinary occasions, but are fully displayed, together with the long secondary feathers, when they are all expanded together so as to form the great fan or shield. The case of the male Argus pheasant is eminently interesting, because it affords good evidence that the most refined beauty may serve as a sexual charm, and for no other purpose. We must conclude that this is the case, as the secondary and primary wing feathers are not at all displayed, and the ball and socket ornaments are not exhibited in full perfection until the male assumes the attitude of courtship. The Argus pheasant does not possess brilliant colours, so that his success in love appears to depend on the great size of his plumes, and on the elaboration of the most elegant patterns. Many will declare that it is utterly incredible that a female bird should be able to appreciate fine shading and exquisite patterns. It is undoubtedly a marvellous fact that she should possess this almost human degree of taste. He who thinks that he can safely gauge the discrimination and taste of the lower animals may deny that the female Argus pheasant can appreciate such refined beauty, but he will then be compelled to admit that the extraordinary attitudes assumed by the male during the act of courtship, by which the wonderful beauty of his plumage is fully displayed, are purposeless, and this is a conclusion which I for one will never admit. Although so many pheasants and allied gallinaceous birds carefully display their plumage before the females, it is remarkable, as Mr. Bartlett informs me, that this is not the case with the dull-coloured eared and cheer pheasants, Crossoptilon auritum and Phasanius wallichii, so that these birds seem conscious that they have little beauty to display. Mr. Bartlett has never seen the males of either of these species fighting together, though he has not had such good opportunities for observing the cheer as the eared pheasant. Mr. Jenner Weir also finds that all male birds with rich or strongly characterised plumage are more quarrelsome than the dull-coloured species belonging to the same groups. The goldfinch, for instance, is far more pugnacious than the linnet, and the blackbird than the thrush. Those birds which undergo a seasonal change of plumage likewise become much more pugnacious at the period when they are most gaily ornamented. No doubt the males of some obscurely coloured birds fight desperately together, but it appears that when sexual selection has been highly influential, and has given bright colours to the males of any species, it has also very often given a strong tendency to pugnacity. We shall meet with nearly analogous cases when we treat of mammals. On the other hand, with birds the power of song and brilliant colours have rarely been both acquired by the males of the same species, but in this case the advantage gained would have been the same, namely success in charming the female. Nevertheless, it must be owned that the males of several brilliantly coloured birds have had their feathers specially modified for the sake of producing instrumental music, though the beauty of this cannot be compared, at least according to our taste, with that of the vocal music of many songsters. We will now turn to male birds which are not ornamented in any high degree, but which nevertheless display during their courtship whatever attractions they may possess. These cases are in some respects more curious than the foregoing, and have been but little noticed. I owe the following facts to Mr. Weir, who has long kept confined birds of many kinds, including all the British Fringillidae and Emberizidae. The facts have been selected from a large body of valuable notes kindly sent me by him. The bullfinch makes his advances in front of the female, and then puffs out his breast, so that many more of the crimson feathers are seen at once than otherwise would be the case. At the same time he twists and bows his black tail from side to side in a ludicrous manner. The male chaffinch also stands in front of the female, thus showing his red breast and blue bell, as the fanciers call his head, the wings at the same time being slightly expanded, with the pure white bands on the shoulders thus rendered conspicuous. The common linnet distends his rosy breast, slightly expands his brown wings and tail, so as to make the best of them by exhibiting their white edgings. We must, however, be cautious in concluding that the wings are spread out solely for display, as some birds do so whose wings are not beautiful. This is the case with the domestic cock, but it is always the wing on the side opposite to the female which is expanded, and at the same time scraped on the ground. The male goldfinch behaves differently from all other finches. His wings are beautiful, the shoulders being black, with the dark-tipped wing feathers spotted with white and edged with golden yellow. When he courts the female, he sways his body from side to side, and quickly turns his slightly expanded wings first to one side, then to the other, with a golden flashing effect. Mr. Weir informs me that no other British finch turns thus from side to side during his courtship, not even the closely allied male siskin, for he would not thus add to his beauty. Most of the British buntings are plain-coloured birds, but in the spring the feathers on the head of the male reed bunting, Emberiza sconiculus, acquire a fine black colour by the abrasion of the dusky tips, and these are erected during the act of courtship. Mr. Weir has kept two species of Amadina from Australia. The Amadina castanotis is a very small and chastely coloured finch, with a dark tail, white rump, and jet black upper tail coverts, each of the latter being marked with 3 large conspicuous oval spots of white. This species, when courting the female, slightly spreads out and vibrates these parti-coloured tail coverts in a very peculiar manner. The male Amadina lathami behaves very differently, exhibiting before the female his brilliantly spotted breast, scarlet rump, and scarlet upper tail coverts. I may here add from Dr. Jerdon that the Indian bulbul, Pycnonotus hemorrhus, has its under tail coverts of a crimson colour, and these, it might be thought, could never be well exhibited, but the bird when excited often spreads them out laterally, so that they can be seen even from above. The crimson undertail coverts of some other birds, as with one of the woodpeckers, Picus major, can be seen without any such display. The common pigeon has iridescent feathers on the breast, and every one must have seen how the male inflates his breast whilst courting the female, thus showing them off to the best advantage. One of the beautiful bronze-winged pigeons of Australia, Ossiphaps lophotes, behaves, as described to me by Mr. Weir, very differently. The male, while standing before the female, lowers his head almost to the ground, spreads out and raises his tail, and half expands his wings. He then alternately and slowly raises and depresses his body, so that the iridescent metallic feathers are all seen at once, and glitter in the sun. Sufficient facts have now been given to show with what care male birds display their various charms, and this they do with the utmost skill. Whilst preening their feathers, they have frequent opportunities for admiring themselves, and of studying how best to exhibit their beauty. But as all the males of the same species display themselves in exactly the same manner, it appears that actions, at first perhaps intentional, have become instinctive. If so, we ought not to accuse birds of conscious vanity. Yet when we see a peacock strutting about with expanded and quivering tail feathers, he seems the very emblem of pride and vanity. The various ornaments possessed by the males are certainly of the highest importance to them, for in some cases they have been acquired at the expense of greatly impeded powers of flight or of running. The African nightjar, Cosmetornis, which during the pairing season has one of its primary winged feathers developed into a streamer of very great length, is thereby much retarded in its flight, although at other times remarkable for its swiftness. The unwieldy size of the secondary wing feathers of the male Argus pheasant is said almost entirely to deprive the bird of flight. The fine plumes of male birds of paradise trouble them during a high wind. The extremely long tail feathers of the male widow birds (Vidua) of southern Africa render their flight heavy, but as soon as these are cast off, they fly as well as the females. As birds always breed when food is abundant, the males probably do not suffer much inconvenience in searching for food from their impeded powers of movement. But there can hardly be a doubt that they must be much more liable to be struck down by birds of prey. Nor can we doubt that the long train of the peacock and the long tail and wing feathers of the Argus pheasant must render them an easier prey to any prowling tiger cat than would otherwise be the case. Even the bright colours of many male birds cannot fail to make them conspicuous to their enemies of all kinds. Hence, as Mr. Gould has remarked, it probably is that such birds are generally of a shy disposition, as if conscious that their beauty was a source of danger, and are much more difficult to discover or approach, than the sombre coloured and comparatively tame females, or than the young and as yet unadorned males. It is a more curious fact that the males of some birds, which are provided with special weapons for battle, and which in a state of nature are so pugnacious that they often kill each other, suffer from possessing certain ornaments. Cockfighters trim the hackles and cut off the combs and gills of their cocks, and the birds are then said to be dubbed. An undubbed bird, as Mr. Tegetmeier insists, is at a fearful disadvantage. The comb and gills offer an easy hold to his adversary's beak, and as a cock always strikes where he holds, when once he has seized his foe, he has him entirely in his power. Even supposing that the bird is not killed, the loss of blood suffered by an undubbed cock is much greater than that sustained by one that has been trimmed. Young turkey cocks, in fighting, always seize hold of each other's wattles, and I presume that the old birds fight in the same manner. It may perhaps be objected that the comb and wattles are not ornamental, and cannot be of service to the birds in this way, but even to our eyes, the beauty of the glossy black Spanish cock is much enhanced by his white face and crimson comb, and no one who has ever seen the splendid blue wattles of the male Tragopan pheasant, distended in courtship, can for a moment doubt that beauty is the object gained. From the foregoing facts, we clearly see that the plumes and other ornaments of the males must be of the highest importance to them, and we further see that beauty is even sometimes more important than success in battle. End of section 15.